Hi students, welcome to Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. So everybody let me know in the comment section if I'm clearly visible and audible to all of you. And as you know, today is our very important marathon, 16 hours. That is full dedication. You are still sitting here and I'm really proud of you. Firstly, everybody clap for yourself because it's not, see, everyone can be there and be like, okay, ma'am and sir are conducting this marathon. I'll be there, I'll join this marathon. But very few students have that dedication, right? That if teachers are teaching, they will be there in the live session itself. Very few students are there, right? So reason is why very few students have that dedication, because only few seats, right? Okay, those few seats will be filled by only those few students who have the dedication to study like full 16 hours in the class live, right? Trust me on that. If you're thinking that I'll watch the recorded this and that, that's not going to work, because here you know your competition is right in front of you in the chat box, right? So today I'm going to complete full chemistry of 11th class. Ma'am, how you will complete that in 11th class? Like full 4 hours, how you will complete that? You know, if I am standing here for 4 hours to complete your chemistry, that means I have already worked 10 hours to do that for you, right? All the notes have been adjusted like that. Firstly, we will see first chapter important points, then questions. Then second chapter important points, then questions. That is how we are going to complete full chemistry. I'm not even skipping qualitative, quantitative analysis, GOC, every single thing, isomerism, every single topic will be done here only, right? As you can see, PPT already I have made for you. That is the big PPT, but trust me on that. If you watch this chemistry session for your 11th chemistry, you will be able to solve all the questions that will be there in your exam, right? Already we have done the hard work for you. Now what's your duty? To sit here. Even I have drank my coffee, right? Because 4 hours full energy is needed, so for that coffee is definitely needed. So you can drink your chai, tea, coffee, whatever makes you feel energetic. And after that, let's jump into this session. Let's start our chemistry part, because this is going to give you marks for sure, right? Okay, so starting with the first chapter. So whenever I'm starting that chapter, I want all of you to write the name of the chapters in the comment section. Yes, everybody. Ma'am, volume is low, is it? Ma'am, volume is low, is it? If the volume is low, then let me know in the comment section. If that is not low, then also let me know in the comment section, right? Okay, because I don't want you guys to suffer because of the volume, right? Okay, so if that is low, you can just let me know in the comment section, right? Okay, if that is perfectly fine, right? Yes. Now everybody spam it in the comment section. What are the important topics here? So ma'am, see here, one or two questions can be asked, not more than that. That's why we are not going to waste that much time on this chapter, right? One or two questions will be there, right? But the basic will be asked to you in other chapters, right? So main important things that you should know is concentration terms that will be applied throughout the physical chemistry. Then there is limiting reagent question and one empirical formula question. These are the three important things from this chapter that we are going to see now. First is the concentration terms. As you can see the concentration terms, I hope so this is clear to you. Concentration terms, first important concentration term is molarity. Molarity is number of moles of solute divided by volume of solution in liters. Molarity is number of moles of solute divided by weight of solvent in kilograms. That is the different part here between molarity and molality, right? And talking about the mole fraction, that is the number of moles of that component divided by total number of moles, right? And if you see the mole fraction of all the components is going to be unity. Let's say I have 5 components, the mole fraction of those 5 components is going to be unity, right? Then if they ask you weight by weight, weight by volume, volume by volume, This thing we will do tomorrow also in detail, because this thing is asked directly in your class 12 physical chemistry. So that's why based on this, we will not do that many questions. These questions we will try to solve more tomorrow, right? Okay. Then weight by weight, always it is going to be, when you have percentage calculation, it will be solute by solution, right? So if it is weight by weight, it will be weight of solute by weight of solution multiplied by 100, because it is percentage. If it is weight by volume, weight by solute, weight of solute divided by volume of solution. Volume by volume means volume of solute by volume of solution. Always solute by solution multiplied by 100 it is going to be. If they ask you, ma'am, what is the ppm, parts per million, instead of 100, multiply this by 10 raised to power 6 directly, right? So that is going to be your concentration terms. Now, sometimes they also ask you question based on strength. Right now, the trend is little bit shifting. Okay. So what is strength? Strength, see, it is similar to molarity. Molarity is number of solute divided by volume of solution in liters. And this is weight of solute. So instead of number of solute, you have to write here weight of solute, and that will be your strength, right? That means the relation between strength and molarity is strength is equals to molarity multiplied by the molar mass of the solute, right? Then direct formulas, right? This formula is more important for you. This formula is molality and the relation between molarity and molality. Molality is equals to 1000 into molarity divided by 1000 into density minus molarity multiplied by molar mass of solute. This is a very important formula. This formula is not that important. You can also skip this formula if you want to, right? But this formula is extremely important, right? The relation, right? Next we have is, what is mole concept? For mole concept, one thing is you should know the formulas of moles. So that is, moles is always going to be given by molar. Always given by molar. In terms of weight, it is given weight by molar weight. What is molar weight? That is molar mass only, right? In terms of particles, it is going to be given particle by molar particles. That is nothing but Avogadro's number, right? Number of particles in 1 mole is Avogadro's number, that is 6.022 into 10 raised to power 23, right? What is moles in comparison to volume? That is again given by molar. Given volume by molar volume. Molar volume will be what thing? See, molar volume, usually we know 22.4, 22.4, we cram this it like this, right? But in reality, if you see, if nothing is mentioned to you, you will assume that they have given you 0 degree, that is 273 Kelvin and 1 atmospheric, then we can say 22.4 liter. But what if they have given you room temperature, that is 25 degrees Celsius, and they have given you 1 bar, then it is going to be 24.8 liters. What if they have given you they have given you 273 Kelvin only, but the pressure is in 1 bar, then it is going to be 22.7. But again, I am saying, if nothing is mentioned in the question, which usually happens, then you will directly write it as that 22.4 is the molar volume. Directly put it here. Here, the important part is, this given volume should be in liters, okay? Because this is also in liters. Usually, students cram this formula, but they don't know the unit. They will put this in milliliters, this in liters, then they will say, my answer was not correct, okay? Because both of them should be in liters, right? Okay. Next is very important, that is a question based on empirical formula, right? So how you will solve the question of empirical formula and limiting reagent, one by one we will see that. So if they ask you question based on empirical formula, first you should know what is empirical formula. Empirical formula is the simplest ratio, right, of that molecular formula, right? So how you will calculate that? First is, you need to know these formulas. I'll tell you how to solve this, right? Okay. The formula is molar mass is equals to 2 into vapor density. Sometimes they don't give you the molar mass, they give you vapor density. So 2 multiplied by vapor density is going to be the molecular mass here, right? Then you will draw one table, right? In that table, you will calculate the moles, that is percentage, if percentage is given to you. Let's say if ratio is given to you, according to that, you will calculate the moles by percentage by or ratio divided by atomic mass of that particular element, right? Then you will convert it into simple whole number ratio. That will be your empirical formula. These two things you will calculate in the question itself, that is molecular mass and empirical formula, right? Then molar mass will be N into empirical mass, right? Because from empirical formula, you can calculate the empirical mass as well, right? Empirical mass also you can calculate once you calculate the empirical formula. Then you will solve the value of N from here, that is molar mass by empirical mass. Now you will put that N in here, right? Then you will put the value of N over here, that is here. Okay, then you will put the value of N over here, that is empirical formula. Let's say empirical formula is CHO2 and your N value is coming out to be 6. Then it will be C6H6O12 is going to be the molecular formula, right? That is going to be the answer. Now let us see one question based on the empirical formula, what you have here, right? One question, because see, these things I can't tell you by myself, okay, that this will happen, that will happen, right? You should also get an idea what kind of language will be there in the question, right? So a compound was found to contain this much of xenon, this much. Okay, one more thing, because we are revising the whole chemistry of 11th class in very fast manner. So that's why I will not solve each and every point for you. I will give you an idea about the question, how you will solve that question, okay? So compound was found to contain 55.2% of xenon and this much percentage of chlorine it contained, okay? So we have two elements. The empirical formula of the compound is this. Calculate the value of N. So what we will do, again this is based on empirical formula. So what we will do here, this is xenon, this is fluorine, percentage of element is this is given to us. Atomic mass of xenon is 131, for fluorine it is 35.5, right? Then you will calculate the moles of the element, that will be percentage divided by the atomic mass, percentage divided by the atomic mass. This is the moles that you are getting. Now, when you divide both of them by 0.45, this will come out to be 1, this will come out to be 3. That means answer is XeCl3. That means the formula is coming out to be XeCl3. Then the value of N is going to be 3 here, right? Okay. Now, if they ask you what is the molecular formula here, they should also give you the molar mass here, okay? Then you will say that N is equals to molar mass by empirical mass. Then molecular formula is equals to empirical formula. In the subscript, you will have N here, right? That is how you will get your answer of empirical formula. Now, next is a very famous question based on limiting reagent. Okay, limiting reagent. Now, limiting reagent, like very high chances that they will see. One question is a kind of question that they can ask you is empirical formula, other is limiting reagent. These two, I can guarantee you can solve this very easily. But based on stoichiometry, moles, because there is no direct formula, so some students might get stuck there. For that, you need a lot of practice of question if difficult question they ask you. Here, even if difficult question is asked, even then you can answer this very easily with the help of this concept here. That is, given by stoichiometry is the smallest. Remember this, I'll tell you how to solve. I'll take an example of one question, okay? Given by stoichiometry, the smallest number is the limiting reagent. And product always depends on the limiting reagent. Ma'am, what do you mean by that? Let's see that with the help of a question, how the question will be framed. First is, ma'am, how I will get to know whether this is a question of limiting reagent or stoichiometry. Simple is, in stoichiometry, you will use unitary method, very simple unitary method you will use that you have used like in mathematics you used to use that, right? Now, how you will identify this is a question of limiting reagent? All the reactants, you can easily calculate the moles. Let's say you have A plus B. This is a question of stoichiometry. If they have given you all the things about A, but for B, they have not given you any hint where you can solve the moles of B or moles of A. If any of the reactant, you can't calculate the moles of any of the reactant, That means that is a question of stoichiometry. Directly unitary method will be applied. Okay. But if that is a question of, let's say that is a question of, ma'am, limiting reagent, then you will be able to solve both the moles of all the reactants that are present in that reaction. Okay, so let us see this here. They have not mentioned anywhere that this is a question of limiting reagent. How I get to know this is a question of limiting reagent? They are saying when H2 is mixed with Cl2, right, the moles of HCl gas is formed. Okay, that is formed. Okay, now they are saying they have given us 22.4 liters of H2 is mixed with 11.2 liters of Cl2. That means can I calculate the number of moles of both the reactants? Yes or not? Everybody let me know in the comment section. Can I calculate the number of moles of both of this or no? Right? I can easily calculate, you can easily calculate. That will be number of moles of H2 will be, that will be 22.4 divided by 22.4, that is 1. And number of moles of Cl2 will be 11.2 divided by 22.4, that is 0.5. Now, you have to calculate the limiting reagent here, right? That we are sure that if they are asking you anything, how many moles of HCl, what is the volume of HCl, what is the mass of whatever they ask you, right? You can calculate the moles. Moles is like mummy. Whenever we are in problem, we go to our mummy, right? So this is our mummy. Mummy is moles. Okay. So whatever is given to you here, gram is given to you, particle is given to you. Firstly, calculate the moles. Then these are the given moles, right? And what is the stoichiometry? Stoichiometry is 1. Stoichiometry is 1. And here what I have told you, given by stoichiometry, the one that is smallest is limiting reagent. So given by stoichiometry is what? Given is 1. Stoichiometry is 1. So it will be equals to 1. Given is 0.5. That is half, you can say. Right? And you can just write 0.5 here. 0.5 divided by stoichiometry is 1. Right? So you can remember this by GS. GS. Okay. So that is going to be 0.5 only. Now tell me which is smaller. This one or this one? This one is smaller, right? So you can see this is my limiting reagent. And I told you here that all the products will be dependent on the limiting reagent. Product depends on the limiting reagent. So directly what you have to do, now apply the unitary method. Simply what you have to tell here that, okay, you have 1 mole will give you 2 mole of HCl, right? Then 0.5 will give you 2 divided by 0.5, right? Okay. No, 2 multiplied by 0.5, right? So that will be 1 only. 1 mole of HCl will be there, right? So answer will be C is the correct answer. So very simple it is, okay? That is how you're going to calculate solve the questions of limiting reagent. Is that clear to everybody or not? Yes, students? Next chapter is structure of atom. Now this is a very big chapter, right? I would say this is actually one of the biggest chapter of your 11th class, right? Okay. And here the problem is that 2-3 topics are important here, right? So I'll tell you from which topics they ask you the question. Firstly, we're going to brush up all the questions, all the topics of structure of atom. If you're ready for structure of atom, write SOA in the comment section, everybody. Write SOA, structure of atom. Spam the chat box with SOA in the chat box, everybody, right? I'll not even stop for 1 single minute, actually just for you, right? Okay, so everybody, I want to see your energy also in the chat box, okay? So SOA, structure of atom, if you are ready for that, then let me know in the comment section so that we can start with the formulas. Questions will be very simple. Directly formula based questions. And your Diksha ma'am is going to tell you each and everything that can go wrong in the question. But I'll save you from that, right? So now here, first is, ma'am, electromagnetic waves. What I have to study, just remember one thing, that lambda into mu is equals to C. Okay, lambda into mu is equals to C, or you can say that 1 by lambda is wave number, right? And 1 by mu is time period. 1 by frequency is time period. Some general things. Then Planck's quantum theory, this everyone knows. E is equals to h mu, E is equals to h c by lambda. Everyone knows that. This is the important part that you have to. This is the important part. That is the reason you are here in this lecture. Okay, because these things you know already. Ma'am, E is equals to h c by lambda. What's the new thing in that? Okay, the new thing is that h value is this, h c value is this. Again, ma'am, the calculations is tough. But ma'am, we are future doctors, ma'am. We are not very good in calculations, ma'am. We are very good in bio, ma'am. We are very afraid of calculations, ma'am. So how to make it easy? If energy, very simple thing. Ignore this part right now. If lambda is given in nanometers, even if it is not given in nanometers, convert it into nanometers. Meters to nanometer is not a big conversion, right? Okay. So lambda in nanometers, you use this formula, then energy in electron volt will be 1240 divided by lambda in nanometers. Or if you say, ma'am, Armstrong is easy for me. 1 meter is equals to 10 raised power minus 10 Armstrong. 1 meter equals to 10 raised power minus 9 nanometer. Right? So here it will be electron volt 12400 if lambda is in Armstrong. Now, ma'am, if my energy is in electron volt, but in the question they have asked it in joules, then what to do? Nothing to worry. This is the conversion of electron volt to joules. 1 eV is equals to 1.6 into 10 raised to power minus 19 joules. Right? That is the direct conversion. Okay, so this part is very important for you for your calculation part. Right? Then this also you all know mu is additive in nature. Right? Lambda is not additive in nature. Lambda is not additive. If they, what kind of question, ma'am, they can ask, ma'am, what is this, ma'am? They will ask question based on this, ma'am. Yes. What kind of question they can ask you? I'll give you one example here. They can ask you that, okay, there is a lambda. They have observed some wavelength and they are emitting two wavelengths from their lambda 1 and lambda 2. Let's say they have given you this lambda is, let's say, 152. This is 65. What is the value of this lambda 2? So whenever things are given in wavelength, you can't add this. You can't say lambda is equals to lambda 1 by lambda 2. But you can say 1 by lambda is equals to 1 by lambda 1 plus 1 by lambda 2. That is why they will not ask you question based on frequency. They will ask you based on wavelength here. Okay. So these are the small topics which are not exactly in your mind, but they can be directly asked to. Right. Then there is from Bohr model. They can ask you direct question based on the Bohr angular momentum, that is MBR is equals to NH by 2 pi. It is the integral multiple of H by 2 pi, right? Okay, so that is very important formula, right? Next is photoelectric effect, right? This you have studied in physics as well. So I'll just recap it fast because all these concepts you have already studied in physics as well, right? So this is the thing that here you have a metallic structure. Some incident light will attack, electron will be ejected here. Now this incident light is h mu and this the energy needed to eject this electron is h mu naught, which is called a work function also. And the energy with which electron is moving is called the kinetic energy. So that's why we say h mu is equals to h mu naught plus kinetic energy, and this can also be written in terms of, see, kinetic energy in terms of stopping potential. If you have to stop this electron to get ejected, then this will be equals to electron into Vs, that is the stopping potential. Now, the question that they can ask you is, if your frequency is high, right, then h mu naught, then the electron easily will be ejected and plus it will have the kinetic energy. If h mu is less than, it does not have enough power, then the electron will not be ejected. And if both are equal, then the electron will be ejected, but it will not have any kinetic energy here, right? Okay. And one more thing to remember here, that if you have, let's say, if the frequency, if mu is increasing, then kinetic energy will increase. And if number of photon is increasing, then number of electron ejected will increase. Okay, these are the two important points from where theoretical question can be asked in your NEET exam, that if frequency is increasing, if they say you are increasing the frequency, which of the following is the correct answer? Then kinetic energy with which electron was moving, that will increase, that will affect the kinetic energy. If number of photons, that means the number of the intensity of the incident light you increases, that means you increase the number of photons here, then number of ejected electrons, that means one photon will eject one electron, right? Okay, next we have is the formulas from the Bohr model. Now here also I'll tell you which formulas you should remember, which formulas you can easily ignore. These formulas, ignore these formulas. Okay, I'm even deleting these formulas because I don't want to have anything here which is not useful for you, right? So here one very, very important question is regarding radius, velocity. So this is the most favorite question of NTA, right? Very simple formula it is. Rm is equals to, if you want to remember this in Armstrong, you can remember in Armstrong or picometer, totally your choice, right? So 0.529 n square by z. N is the orbit number, z is the atomic number of that element. We know that Bohr model is applied to a hydrogen-like species which has one electron. So hydrogen, helium positive, lithium 2 positive, all these are the things which are you would say, which are applicable, where Bohr model is applicable, right? Okay, so directly we can say R is directly proportional to n square by z. For velocity also, simply you can say 2.1 and 10 raised to 6 z by n, velocity is directly proportional to z by n. Time period, you don't have to remember this, just remember that time period is directly proportional to n cube by z square. But based on the proportionality, they can ask you the question, right? Then energy in electron volt also you remember, in joules also you remember, because conversion will make it difficult for you, right? Okay, so where we can remember things, try to remember. Right, minus 13.6 z square by n square electron volt, this is minus 2.18 10 raised by 18 z square by n square joule, right? Okay, so that is going to be the energy. Now, this is the total energy, okay? This is the total energy, right? If total energy is, let's say, x by 2, right? Then kinetic energy, or if I want to write it like this, total energy, let's say x, then kinetic energy is going to be minus x, and potential energy is going to be 2x. Okay, rather than this, remember this thing, because this I feel is more easy for you to remember. Okay, this is more easy for you to remember, that if total energy you calculated from here, that is coming out to be x, then kinetic energy will be negative of that, potential energy will be 2 of x, right? Okay, directly you can remember this particular thing here. You don't need to remember different formulas of potential energy and kinetic energy, nothing is required, right? If they make this even complicated for you, they will not ask you the energy, they will ask ionization energy. You will say, oh my god, this is a question of Bohr model and they are asking periodic classification. What is this, ma'am? Right? So directly remember this thing, that total energy, right? Opposite of that is your ionization energy here, right? Ionization energy is plus of that, okay? Whatever is your total energy, right? Because ionization energy is the energy that is required, right, to take out the electron, right? Now, let us talk about the very important concept, that is the Rydberg equation. For Rydberg equation, how to solve? Don't worry, we will do the questions based on all of this as well. Don't worry about that, right? So, hydrogen atom. So, here all the important points that you require, I have summed it up. Now, students, one thing you should remember is that this was the total energy here, right? So one thing you should remember is whenever orbit number is increasing, these are the energies corresponding to the orbit number, right? Now what you can see, at infinite energy will be 0. So that means as n increases, energy is increasing or decreasing. Energy is minus 13.6, right, electron volt, to it is increasing. That means energy is increasing here, right? Okay, so as n is increasing, energy is also increasing here. Now, as n is increasing, can I say one thing, that here energy gap was large, then it is less, then it is less, even less. That means delta E is decreasing here. The gap between two orbits is maximum here, then it is decreasing. So these are the important theoretical conceptual questions that they can ask you, right? Next is, ma'am, Lyman, Balmer, Paschen, bracket, Pfund. These are the names of the series, right? Okay. Why you have to remember? Because if you want to solve the numerical of Rydberg, see, by just cramming this equation, you can't solve the numericals. To solve this numerical, you have to know this, you have to know this, you have to know this as well, right? Okay. So all the important points. Lymer means your N1, the point in which it is falling is 1. The point in which the orbit in which it is falling is 2, then 3, then 4, then 5. Now, they can also give you the question like that this line belongs to this line belongs to visible spectra. Now you should know that in the visible spectra you have only Balmer series. That means N1 is going to be 2. The line belongs to UV spectra. In UV spectra you only have Lyman. That means N1 is going to be 1, right? Now for N2, how you will decide? Because in Rydberg equation you have both the things. In Rydberg equation you have N1 also and N2 also. N1 I told you that you can easily do by Lyman, Balmer, bracket, Pfund, and this bracket, Pfund, Paschen, bracket, Pfund, right? But N2, for N2 there are some, either they will give you directly that N2 is 3. For that it's not a big deal. But if they make the question complicated, right? How they will ask you? They will ask you, they will say, it is a first line, alpha line, minimum frequency, maximum wavelength. That means N2 is going to be N1 plus 1. You have to add 1 into the N1, right? That is the next line, the first line after that, alpha line, right? What if they say it is last line, limiting line, then N2 is going to be infinity. What if they say it is the second line, then N2 is going to be N2 plus 2. Third line, it is N2 is equals to N1 plus 3, right? This is alpha, this is beta, this is gamma, right? Then why, ma'am, this is minimum energy? Because E is equals to hc by lambda, okay? E is equals to h mu. See one thing, if we are saying it is the next line, you are adding this is the line and it is jumping to just next level. That means the energy gap is very less. If energy is less, that's why we are saying minimum energy, minimum frequency. If energy is less, then lambda will be high. That is why we are saying maximum wavelength here. So they can use any of these terms to tell you that this is the value of N1 and N2. Now let us see, ma'am, how to use this in this equation, ma'am. Next problem that students face is the calculation part. So how to make your calculations easy here? See, one thing is the Rydberg constant. Everyone knows that this is 109677 per centimeter. This is the value. But the problem is, if they ask you the wave number, you just have to multiply this number with z square and with this value. Then that is not a big problem, right? The problem is if they ask you the value of lambda, which usually they ask you the value of lambda only. Now Rydberg constant is the reciprocal of that. So while calculating this, you should know the value of 1 by RH, right? But to calculate that, that will consume a lot of time. So now what you will do, right? You will put the value of 1 by RH, right? Directly as 912 angstrom. Then the lambda value will be in angstrom. If they ask you this in, let's say, meter, you convert it into meter. The conversion of angstrom to meter is not a big deal. But solving 1 by 109677 is a big deal. That is the big calculation, okay? So, save your calculations with this part, okay? Save your calculations like that. Now, next is going to be our some important formulas for different principles, okay? So, one principle is de Broglie hypothesis. So, hypothesis is lambda is equals to h by p, that is h by mv. We know that mv is the momentum. Momentum is equal to under root 2 mke. This you have done in 9th class in Newton laws. If you remember, under root 2 mke is the value of momentum. So we know that kinetic energy can also be charge multiplied by stopping potential. You can also put that as the value. Now, de Broglie hypothesis states that electron, or you can say this follows both dual nature. That means this follows wave and particle nature also. Right? So that means if this is the circle, by the circle, we know that this is the circumference. So its lambda is going to be lambda. That means n number. If you are saying that n number times it is, So n into lambda is going to be 2 pi r, that is the circumference. This is according to the particle nature, this is according to the wave nature. When you equate them, you will get the answer for your Bohr angular momentum. That means this dual nature or de Broglie hypothesis also follows the third postulate of Bohr angular momentum, right? That is why I told you that this particular formula is very important, because it is verified by de Broglie hypothesis only. This is what makes it very important for you, right? Then there is Heisenberg principle. So Heisenberg principle, a very simple direct question will be asked to you based on this is delta x dot delta p. This is the uncertainty in position multiplied by uncertainty in momentum is greater than equals to h by 4 pi, or you can put delta p, you know that is m into delta v. You can solve this also, right? Very rarely they will ask you the question of Heisenberg principle, but they can still ask. Right now, the more, I would say, more focus is on this Rydberg equation. This Rydberg equation is very, very important for you. The formulas, these formulas are very important for you. Second topic from structure of atom. And the third topic that is very important is quantum numbers. So these are the topics that are very important, right? So before doing quantum numbers, students, let us do the questions. I forgot to tell you one important point here. That is this thing. That is, here, one direct question can also be asked based on total number of spectral lines. Okay, they will give you, it is falling from n is equals to 4 to n is equals to 2. How many spectral lines are there? Let's say they are saying from n is equals to 6 to n is equals to 2. How many spectral lines? Maybe someone is falling to 4th, someone is falling to 2nd, someone is falling to 3rd. How many spectral lines? That will be 6 minus 2. 6 minus 2 plus 1 divided by 2. That will be the answer for number of spectral lines. But if they say, usually this question is asked. But see, we have to be also very, very risk-free about the upcoming question that they can ask you, right? Okay, so they can also ask you number of spectral lines for specific orbit. Specific orbit, what do you mean by that? Specific orbit, let's say, if they are saying from 6 to 2nd, it is falling. Maybe how many lines are falling? 6 minus 2 is 4. 4 plus 1, 5. This is 5 to 10 lines are falling. Okay. So we know that from 6 to 2, 10 lines are falling. 10 lines. From this equation, from this formula, we know that 10 lines are falling. But if they mention from 6 to 2, how many lines are falling to n is equals to 3? Now, out of this 10 lines, how many of them are falling directly to n is equals to 3, not to any other orbit? For that, you don't have to draw the lines. Directly use number of specific lines for specific orbit is higher minus specific. That is, higher is 6, specific is 3. So it will be 3. Out of this 10 lines, 3 lines will be the one that are falling on third orbit. Right? That is how you're going to solve total number of spectral lines and the number of specific spectral lines. Is that clear? Okay, students. So now let us solve the questions based on what we have done till now. After that, we'll do quantum numbers as well. Okay. Yes, everybody, let us start that. If electron makes transition from 7th state. Now what we are doing? If electron makes transition from 7th state to 2nd state in hydrogen atom sample, okay, the maximum number of spectral lines. Now they are saying the maximum number. They are not asking you the specific orbit. That means directly this is N2, this is N1. Directly you will use this formula, right? That is delta N is what? Directly it is mentioned like this. So directly also you can say N2 minus N1. N2 minus N1 plus 1 divided by 2, and you can get your answer here. N2 minus N1, 7 minus 2 is 5, right? So it is 5, 6, this is 2, 3, and this is 15 lines will be the maximum number of spectral lines that you will have here, right? Okay, students, is my speed fast, slow, or manageable to you? Let me know in the comment section. According to the session, are you feeling that yes, we are learning something, or you feel that okay, ma'am, it is going fast, or you feel that ma'am, yes, this is the speed that we require for our revision. Okay, the shortest wavelength. Next question is the shortest wavelength of hydrogen atom in the Lyman series. Lyman series, N1 is equals to 1, right? Okay, N1 is equals to 1. Shortest wavelength here, very important. Shortest wavelength means what is the value of N2 here? What is the value of N2? Shortest wavelength means maximum energy. Maximum energy means N2 is going to be infinity here, right? The longest wavelength of Balmer series, we know that for Balmer series, what is the value of N1? N1 is equals to 1. And for longest wavelength means lambda is going to be minimum. Longest wavelength means lambda is going to be maximum. Energy is inversely proportional to lambda, so energy is minimum. So what is the value of N2 here? Let me know in the comment section. I'm waiting for your answers here. Yes, one student has answered it. So Meet is saying that, ma'am, yes, 2 is the correct answer. 2, ma'am, N2 is 2. Perfect. Now we will use Rydberg equation. We will have two equations. First, we will put N2 and N1 this. In the second equation, we will put N2 and N1 this. From there, they are asking you, what is the ratio? Okay. So see, here the value of Z is going to be 1. Here the value of Z is going to be 2. Right? Because this is helium atom, hydrogen, helium, Z is 2. Right? Now we will put this in the equation here, in the Rydberg equation. 1 by lambda 1 is equals to RH. This is for hydrogen atom. 1 by N1, N1 is 1. Minus 1 by N2, N2 is infinity. So for that, answer is going to be RH is equals to 1 by lambda 1. This is the first thing. Right? This is for hydrogen atom. Right? For lambda 2, or you can directly, they have written it lambda, so I'll take it as lambda only. 1 by lambda is equals to RH. 2 is for helium, 2 square. 1 by N1, here N1, wait a minute, N1 was this or what? Array, here N2 is going to be 2, no? Here N2 Balmer series, no? So N2 is going to be 2. And here, the next line is going to be, here N1 is going to be 2. And here N2 is going to be 3. Okay, Balmer series, N1 is equals to 2. Right? Now here, you will put 2 square, 1 by N1 minus 1 by N2 square. That is 1 by 2 square minus 1 by 3 square. Okay, then you will solve this equation. Right? Now they are asking you the ratio here. They are asking you the ratio. What is the question? The longest wavelength of the balance is this is. Okay. The shortest wavelength of hydrogen in the Lyman series is lambda 1. The longest wavelength. So you have to calculate the value of lambda in terms of lambda 1. Right? Because that is the answer. So lambda is coming out to be 5 RH by 9. RH is nothing but 1 by lambda 1. You will put the value of 1 by lambda 1 here. So the answer will be lambda is equals to 9 lambda 1 by 5. That is the correct answer that you will get in the end. Right? So in this one question, they have asked you Lyman-Balmer series. They have asked you the concept of shortest wave, longest wavelength. They have asked you two different questions, right? Made it in one part, right? So these are the kind of questions that we expect from NTA, right? Next is, if de Broglie wavelength of electron is nth orbit is A, hydrogenic atom is equal to this. Okay. De Broglie wavelength is equals to this. Then the value of n by z. Now this is a very interesting question. See, why I have picked questions like these? Because they have involvement of 2-3 formulas here. That's why I picked these kind of questions, so that we can revise a lot of things in one question, right? So they have given you the value of lambda. De Broglie wavelength is 1.5. Lambda naught, what is given? 1.5 pi a naught. Okay, so this will be pi a naught, right? This will be pi a naught. 1.5 pi a naught. We know that this thing we have solved it. If you remember this, I told you that n lambda is equals to 2 pi r in de Broglie hypothesis, right? So radius of stationary states are also this. This we all know that r is equals to a naught n square by z. Now, if you put the value of r here, that is n lambda is equals to 2 pi a naught n square by z. N will cancel each other, and lambda will be equals to 2 pi a naught n by z. Lambda value is given to be 1.5 pi a naught. You will put the value of lambda here, right? Then pi will cancel, a naught will cancel. right? And hence the value of n by z is going to be 1.5 by 2. That is going to be 0.75 is going to be your correct answer in the end. Is that clear to everybody? How we are solving? The three important formulas we used here. One is radius, other is this important thing here. This was already given to you, right? So these are very important questions and you should practice these questions. That is why I have specially picked these questions for you. It took a lot of hard work, right, to pick good questions for you, good quality content for you, right? For that, let me see how many likes you have given for the hard work that we do for you, right? I think this should have, let's cross it above 200 likes in next 30 minutes, right, before we complete structure of atom, right? Other questions are based on the quantum numbers, so let us discuss that as well here, right? Okay. Now, quantum numbers. Let me see how many of you like quantum numbers, how many of you don't like quantum numbers. I feel these are the easiest kind of questions in your full chemistry, right? This page is very easy itself, right? It's like a very easy peasy thing, right? So basically quantum numbers, 4 kind of quantum numbers we have. And remember that this spin quantum number is not a solution of Schrödinger wave equation. Rest of principal, azimuthal, magnetic are the solution of Schrödinger wave equation. Directly a statement based question can be there. Now next is, ma'am, n, the value of n that represents shell and orbit, and if n increases, size also increases, energy also increases, right? That value can be from 1 to infinity. Azimuthal quantum number that represents the subshell, that is SPDF, right? That represents the shape. S has spherical shape, P has dumbbell shape, D has double dumbbell shape, right? Then L will be from 0 to n minus 1, right? Okay. Magnetic quantum number is representing the orbitals. Like in D you have 5 orbitals. In F you have 7 orbitals. In S you have 1 orbital. In P you have 3 orbitals. So answer will be m is equals to minus L2 plus L. Spin quantum number only will be either plus half or minus half, right? Now, questions based on the formulas from quantum numbers, okay? First thing is you should remember is, if we are calculating with respect to the value of n, if you calculate the number of subshells, that is going to be n. If you calculate the number of orbitals with respect to n, that is going to be n square. Number of orbitals with respect to L is going to be 2L plus 1, right? That is how you're going to tell it. Now, in one orbital, you can have 2 electrons. That is why number of electron will be 2n square. Number of electron will be 2 into this value. Okay. So, in one orbital, orbitals, you are going to have 2 electrons, right? Angular orbital momentum is under root LL plus 1 h by 2 pi. You might ignore this. You will be like, ma'am, these kind of questions you don't ask, ma'am. This question was there in JEE attempt 2. NTA is the conducting agency, same agency. So same question they can ask you. Literally this question was there. That the L value was 0 and the answer was 0. Okay, so very simple question. Angular spin momentum is under root S plus 1 h by 2 pi. Right? Now, here one more important thing is, if they ask you the value of, let's say, n plus L. Now, let's say if they ask you out of the following, which is the energy level, okay, what is the energy, according to that what you will tell, as n plus L increases, energy also increases, first thing. If by chance n plus L is same, in that case, as n increases, energy also increases. And for hydrogen atom, n increases, energy increases. N same, energy also same. That means for hydrogen atom, 2s, 2p have the same energy. 3s, 3p, 3d have the same energy. This is only applicable to hydrogen atom, right? Okay. Now I'll draw some important shapes for you. P orbital, we know that has dumbbell shape, but D orbital you should know what kind of shapes it has, right? Okay. F orbital has a complicated shape and S has a spherical shape. See, if you have dxy, dyz, dzx, let's say you have dxy, dyz, and you have dzx. Also, that also I'll draw it like this only. This is x, y, right? Okay, wait a minute, dxy, dyz, dzx. I'll draw it like this only. Xy, this is yz, this is zx. This will be, ulta, I have drawn this. Wait a minute. Because x, y, y, z and zx is between the x's, okay? That will be between the x's. So x, y, y, z and zx, that will be between the x's, that is a double double. This is dz square and this is dx square minus z square, okay? So that is how this is xy, this is z, this is, let's say this is xy, this is yz, this is zx. Okay, so this is dxy, dyz, dzx, this is dz square, this is dx square minus y square. Okay, understood? Yes, everybody, is that clear or not? Now let us solve some questions based on this, right? Okay, how many of you know how to write the electronic configuration and the energies? How many of you find it difficult? Then let me know in the comment section. If you want me to write that on, like if you're like, ma'am, no worries, ma'am, we already have learned that thing, then let me know. If you think that, ma'am, can you please tell us some trick for that, then I can also tell you that. Let me know in the comment section if you want that or not. By that time, I'll solve the question here, right? Okay, by that time, I'll solve the question here. And you tell me if you want me to write the energy level diagram, right, based on the n plus L rule. Okay? Yes. Which of the following is not permissible arrangement of electrons in an atom? In an atom, which is not a permissible arrangement. First is N and L can never be equal to each other. N will always be greater than L. Okay, so that is true for all of them, right? So if N is equals to 5, then L will be equals to 0 to N minus 1. That is why N and L cannot be equal. If L is equals to this, M is equals to minus L to plus L. So that will be, this is possible, this is not possible, right? So they are showing which is not a permissible arrangement. We already know this is not a permissible arrangement because here it should be minus 2 to plus 2. So minus 3 is not possible here. So answer will be B is not a permissible arrangement here, right? Okay. Next is, which is the correct order of increasing energy of the listed orbitals in the atom of titanium, right? They are saying that which is the correct order of increasing energy listed. Okay, you don't have to think about titanium. Titanium, you can ignore that as well, right? Okay, but here you can just apply N plus L rule, right? So here, if you see that this is 3s, this is 4s, this is 3p, this is 3d. Okay, so one thing is this is 3 plus 0. See, ma'am, how you calculated 0? SPDF. Here it is 0, 1, 2 and 3. This is the value of L. This is the value of L corresponding to S, P, D and F. So this is 4 plus 0, this is 3 plus 1, this is 3 plus 2. Right, so here it is 3, this is 4, this is 4, this is 5. So maximum is this. Now, out of these two, how we will answer? More is the value of N, more will be the value of energy. So, answer will be, first is 3s, then you will have 3p, then you will have 4s, then you will have 3d. Okay? Increasing order, right? 3s, 3p, 4s, 3p will have less energy because that is less number. Then 4s, then this. So answer is, they are asking you the increasing energy. Increasing energy means 3D is going to be the last one, then 4s, 3p. So answer is going to be D is the correct answer. Okay. Next is the number of radial nodes. Now, ma'am, what is this radial nodes? Ma'am, how to calculate that? Right. Now, let us see. Question. Okay, one more thing, students. I am going to come up with a very short session of 30 minutes, right? 30-40 minutes. That will be based on the graphical questions that they can ask you, right? So, graphs of full chemistry I'll teach you in that session. So, I'm not going to take up radial node graph, all these graphs here, because that I'll teach you. There is no use of repeating the same thing again and again, right? That will waste your time and my time as well. So that's why I decided that I'll take up graphs in just one class that will be of 30-40 minutes, right? So here I'm focusing more on the conceptual and numerical based questions from physical chemistry, right? So here it is, n minus L minus 1 is going to be your radial nodes, okay? And total nodes is going to be L, right? And angular nodes is going to be n minus L. Okay, so here we need to calculate the radial node. So answer will be for 3s. 3s, n is 3, L is 0. Here n is 2, L is 1. So this will be 3 minus 0 minus 1, that is 2. Here it is 2 minus 1 minus 1, that is 0. So answer will be 2 and 0 is the correct answer here. So answer is A is the correct answer. Yes? Very good. Can I see S and P? Very good, very good, very good. Right? Now, I saw some of you were asking that, ma'am, please can you recall the diagram, the trick that you told us. Okay, so I'll just recall the trick, right, for you guys. Let us see that. See, if you already remember the energy level diagram, you can ignore what I am teaching you right now. Okay, you can ignore that part. If you are someone who is like, ma'am, even now I get confused, then this trick will never make you confused, right? So this is SPDF, right? SPDF. Now what you have to do, 2 times S, 2 times PS, 2 times DPS, 2 times FDPS. Okay, so 2 times you have to write all of this. 2 times S, 2 times PS, 2 times PS, 2 times DPS, DPS, 2 times FDPS, FDPS. Okay. Now what I'll do, this will start from 1, this will start from 2, this from 3, this from 4. Right? So it is 1, 2, 3, 4, 5. I'll complete all the S here. 5, 6, then 7, then 8. Then I'll complete P. P will start from 2, 2, 3, 4. This is 5, this is 6, this is 7. Now I'll complete 3, D. This is 3, this is 4, right? This is 5, this is 6. Now F will start from 4, so this is 4, this is 5. And that is your energy level diagram in the increasing order. Okay, that is your energy level diagram in the increasing order. Is that clear to everybody or not? Right? That if you don't remember that, see, this is to fill your electronic configuration. If you don't remember that, then directly what you can do is N plus L rule will be applicable, right? Okay, students, structure of atom done. So if you are like 2 chapters we have completed, students, 2 chapters we have completed, right? Okay, now we will be starting with the next chapter, that is going to be, yes, SOA done, atomic structure done. So everybody write down SOA done. Done. Okay, SOA done. Now we will be starting with the next chapter here, that is thermodynamics, right? Thermodynamics. How many of you are thinking to skip thermodynamics? First of all, let me know that in the comment section. How many of you are scared of thermodynamics? How many of you are thinking of skipping thermodynamics? Right? Because see, this chapter is there in chemistry and physics both, but there is little difference, right? The way they ask questions. Some things are same, some things are different, right? So on the perspective of chemistry, we will understand thermodynamics here, right? Okay. So everybody, thermodynamics. So if you see this thermodynamics here, write down, firstly, spam the chat box with thermodynamics in the chat box. Spam it with thermodynamics in the chat box. Or if you're too lazy to write thermodynamics, write TD. If you're lazy, ma'am, I'm very lazy, ma'am, in typing, ma'am, what to do, ma'am? I'm a lazy person, ma'am, from 9 a.m. I'm sitting here. Okay, then write TD here. Okay, I'll understand your feelings. Okay, TD, let us start. Spam it, TD, in the comment section in the chat box. Right? Okay. In thermodynamics, first law of thermodynamics, you should do direct questions are asked there based on that. Processes, the name of the processes, and the third one is work done. Then there is thermochemistry, right? So this chapter we are going to revise. There is 7:12 on the clock. 7:30 will be done with thermodynamics. That is my idea, but I don't know, right? But that is my like aim to finish it at 7:30 or maybe 7:35, right? Okay. Yes, TD, spam it TD in the chat box, right? No laziness. Ma'am has also given you abbreviations like this TD, SOA, right? Now, let us see. One of the students is saying, ma'am, redox reactions. See, redox reactions, I will not do it today. Right? I'll be very frank with you. There is no benefit of doing redox reactions. It will be better if you do redox reactions with electrochemistry. Right? Even in your NEET syllabus, it is mentioned redox electrochemistry. So that will be a better way of doing redox with electrochemistry. Right? Okay? Understood? Now, let us see. First thing we have is what is the difference in reversible and irreversible processes. So for numerical purpose, you should know that reversible means you just have some small portions, right? That means you are adding small portions means that means you're adding like sand or salt something, right? So that is a multi-step in slow one step in very small steps you are doing that reaction. That is why that is reversible, right? And here they can also write, they will not mention in the numerical that this is reversible. They will mention at variable external pressure. Variable means they are talking about reversible process. Okay. Now, if you have a big block, right, then it will be a one-step reaction. Okay. In that case, it is irreversible, and in that case, it is at constant external pressure. If at constant external pressure is mentioned, that means they are talking about irreversible process, right? Okay. Then what we have is, then we have first law of thermodynamics, that is delta U is equals to Q plus W, where W is nothing but that is equals to minus P delta V. That is your pressure and this is the volume, right? Okay. Q is the heat energy, delta U is the internal energy, W is the work done here, right? Now, don't look into the physics formulas because formulas are different, so is the sign conventions, okay? So, here, work done by the system, whenever system has to do work, system is feeling very negative. When work done is on the system, system is very happy because system is very lazy, okay? Huh? Like you, if I ask you to do full 11 chemistry in 4 hours, you will be like, ma'am, I can't do, you will be under so much stress, right? But right now, you know that ma'am has already done the homework, right? We just have to learn what ma'am is teaching. So now the system is happy because work is done on the system, right? So similarly, if heat is released by the system, if you have to give money, if you have to give notes, then you will feel very negative, right? If I give you money, if I provide you notes, right, this PDF will be provided in the description box, right? So you'll feel very happy, right? Because system has to do nothing, right? System is absorbing the heat, so system is positive, right? Okay, that's how you remember things. Now, next is two very important formulas. If they, what is delta H and what is delta U? Delta H is enthalpy, delta U is internal energy, right? But sometimes they don't give you delta H and delta U. Instead, they give you heat energy at constant pressure, heat energy at constant volume. So, heat energy at constant pressure is delta H, heat energy at constant volume is delta U. This is a very important point, right? Next is these four processes, simple definitions. Isothermal, iso means same. Thermal means temperature is same. So whenever temperature is same, then delta U will also be equals to 0. So that means delta U and delta T both are equals to 0 here. Isobaric means pressure is 0. Isochoric means volume is 0. 0 means the change in volume is 0. I am not saying pressure, I am saying change in pressure, change in volume. It is 0. Adiabatic means heat energy is going to be 0 here, right? Next is to identify the work done here. Okay, so we will discuss the work done. Okay, let's discuss the work done, right? Okay, now, first thing is, I'll tell you, chances are that they will ask you work done in isothermal, reversible and irreversible processes. Okay, so isothermal irreversible, if you remember, we did it here. Isothermal irreversible is what? At constant external pressure, there is one step process. That is why directly work done is minus P delta V. What is P? P external, delta V, ma'am. What you have written here? From the ideal gas equation, PV is equals to nRT. When you put it here, V is equals to nRT by P. Okay. PV is equals to nRT. That means V is equals to nRT by P. P is changing here. So that will be nRT 1 by P1 minus 1 by P2. If in the question volume is given to you, you will use this formula. If pressure is given to you, you will use this formula. Right? Then in most of the cases, even in your previous year question, you will see this question. Instead of writing reversible, they will write at variable external pressure. Here external pressure was constant. Here it is not constant. So that is why it is happening in small steps, and that is why we did integration here. That is why I have written it here. You will use that formula which involves integration. After the integration, what the formula you get is this formula, that is minus 2.303 R nRT log of V2 by V1. Now important point here, everyone look here. If volume is given, it is V2 by V1. If pressure is given, it is P1 by P2. Okay, volume is given, it is V2 by V1. Pressure is given, it is P1 by P2. Okay, that you have to remember. Otherwise, thermodynamics is not difficult. You just need to know which formula to apply where. Otherwise, thermodynamics, very direct question they ask you. They will not, complicate even a bit in thermodynamics, because thermodynamics is a very complicated subject. It's a very complicated chapter if you go in higher studies. But that's why I'm saying they can definitely complicate this in higher level of exams like UGC NET, JEE Advanced, right? But in your NEET exam, they will stick to this part, at least in physical chemistry, okay? So next is this adiabatic process. For work done is going to be, see, work done is equals to NCV delta T. Okay, work done is equals to NCV delta T. Directly you remember the work done. What is, ma'am, this? Just give me 2 minutes, I'll come back to this place. Okay, give me 2 minutes, because right now you don't have any idea about what is gamma. Okay, or I'll just tell you that this is the formula you will apply, right? Okay, gamma value, I'll tell you what is that. I'll tell you what CVM is. Okay, just give me 2-3 minutes. Okay, now adiabatic we will do after 3-4 minutes. Okay, isobaric process means you have pressure is constant. Pressure constant means the work done is equals to minus P delta V directly. Isochoric means V is constant. So delta V is 0. That means work done is also going to be 0 here. Right? Cyclic process, very simple. Work done is equals to area enclosed area under the curve. Right? For clockwise, it is going to be negative. For anti-clockwise, it is going to be positive. Right? Open vessel, if they give you, this is a reaction. Very important thing, reaction will be given. Reaction will be given in the question, because, or they will give you some hint about the reaction, that this is combustion of, usually if they give you hint, that this hint is according to the combustion of hydrocarbon or something, right? That is there in your organic chemistry. Okay, so reaction will be given, W is equals to minus delta NgRT. Free expansion, work done is 0. Delta Ng, you will see this from the reaction, that is number of gaseous product minus number of gaseous reactant, RT, right? Free expansion, if they anywhere in the question they give you free expansion, you will say work is 0, delta U is 0, Q is 0. That means all the parameters of first law of thermodynamics are going to be 0 here. Next we have is heat capacity. Heat capacity is Q by T, heat energy that is raised when you heat energy change when you increase the temperature by 1 degree Celsius. That is the heat capacity, right? At constant pressure, that is Qp by delta T. Constant volume, that is Qv by delta T. Qp we already studied, that is nothing but delta H. Qv also we studied, that is nothing but it is delta U. Now very important thing I am telling you, that you might skip when you will study your NCERT, because right now you are doing revision. Okay, in revision you will only go through the formulas of NCERT, isn't it? But you will not go through the lines of NCERT. So in the bracket they will mention that this is n mole or 1 mole, and you will just go through the formula. That is why you will end up learning the wrong formula. Okay, that's why directly you should use this thing, that is Cp is for n mole. N moles, N moles. Both are for N moles. If I am talking about molar heat capacity, I have to divide it by N. That is, I am talking about 1 mole. So in that case, this will be converted to CPM. M means for 1 mole. CVM, that is again for 1 mole. That means you have to divide it by N and N. In that case, you will get very important thing. That is delta H is equals to N CPM delta T. Delta U is equals to N CVM delta T. Okay. That's how you got your answer here. That's how you got your answer here. Got it? Yes, just remember delta U is equal to N CVM delta T, delta H is equal to N CPM delta T. These two are very, very important formulas, right? Next is, what is gamma? Gamma is the ratio, that is CPM divided by CVM, right? CV is nothing but degree of freedom R by 2. CPM, or you can just directly write this thing here. Wait a minute. I'll just directly use this formula here, right? So directly what you can see, that CPM minus CVM is equals to R. That is CP minus CV is equals to NR. In your NCERT, it is written CP minus CV is equals to R. But in the bracket, they have mentioned for 1 mole. For 1 mole. In reality, if you are denoting it CP by not molar heat capacity, then you have to remember that CPM minus CVM is equals to R. Right? CP minus CV is equals to NR. Right? Remember these two formulas. That is going to be very, very beneficial for you. Next is, they will give you some, let's say, monatomic, diatomic, triatomic gases are given to you. Right now, we are not going into how the degree of freedom is this and that, right? Okay. Right now, what you have to remember is, for monatomic, what is the degree of freedom, okay? So, for monatomic gases, degree of freedom is 3. For diatomic gases, like you have H2, O2, N2, right? Or linear polyatomic gases like this, CO2. Degree of freedom is 5. For non-linear polyatomic, non-linear means like you have S double bond O double bond O. That is a non-linear species, right? So for non-linear polyatomic, degree of freedom is 6. When you put this, CVM is going to be F R by 2, that is 3 by 2 R, 5 by 2 R, 3 R. Right? Then CP is equals to, CPM is equals to CVM plus R, that is 5 by 2 R, 7 by 2 R, 4 R. Just calculate this, okay? Next is, gamma is equals to CPM by CVM. See, when you are doing the ratio, either you write CP by CV or you write CPM by CVM. Both are the same things, okay? So, CPM by CVM is equals to 5 by 2R. Just calculate this, and these are the values of gamma that you will get. And gamma is nothing but that is called Poisson's ratio, okay? Now, what they will give you in the question, that for a monatomic gases, what is the value of gamma? For monatomic gases, firstly, directly you can solve this. Okay, that is how the question will be asked. Now, let us move towards the adiabatic where we were, right? Now, work done is equals to, see, very simple. Delta U is equals to Q plus W. Adiabatic process means Q is equals to 0. Do you agree? Q is equals to 0. So, delta U is equals to W. Now, if delta U is W, that means we know that delta U, what we discussed here, what is delta U? What we discussed here? Delta U is nothing, N CVM delta T, right? So you will put the value here. Delta U is equals to N CVM delta T. That is why the formula of work done of adiabatic process is N CVM delta T, right? For irreversible process, this N CVM delta T, now what exactly, ma'am, we are doing here, right? So you know what exactly they do? In case of isothermal processes, they ask you the work done. Mostly what we have seen, what we have analyzed is, in case of adiabatic processes, they ask you temperature T2, right? So if that is a irreversible process, then what they will do, N will be, number of moles will be given to you, CVM will be given to you, or they will give you the value of that this is monatomic, this is diatomic, okay? What if they have given that this is monatomic, this is diatomic? Can you calculate the value of CVM if monatomic, diatomic gases, or let's say the example of the gas is given to you? Let me know in the comment section. If the example of the gas is given to you, can you calculate the value of CVM from there? Either directly they will give you, or you will have to calculate. T1, T2, they will not give you the value of T2. They will give you the value of T1. P external will be given to you. Number of moles, it can cancel out with each other. R value we already know, right? And T, as I told you, T2 will not be given. P1, P2 will be given to you. T1 will be given to you. From this, they will ask you to calculate the value of T2 directly. Okay? Understood? Understood? Next is the reversible process. PV gamma is equals to constant gamma for monatomic, diatomic, triatomic, all we have solved from the table, right? So, P1 V1 gamma equals to P2 V2 gamma. P1 1 minus gamma T1 gamma is equals to P2 1 minus gamma T2 gamma. Or T1 V1 gamma minus 1 is equals to T2 V2 gamma minus 1. From there, you can calculate the value of P1, P1, P2, whatever they ask you. Right? Okay, so these are the important things here. Right, students, understood how we are going to do this? Next is, let's say, what is the time here? Yes. Enthalpy. Delta H is equals to delta U plus P delta V. See, very simple. If pressure is constant, then this formula will be used. If volume is constant, then this formula will be used. And if pressure and volume, nothing is given in the question, then you will use delta Ng RT. Then you will use delta Ng RT. Understood? Now, delta Ng RT, this you will use if reaction is given. If reaction is given. Reaction will be given. These two you will use if pressure and volume is given. Now they will ask you either delta H or delta U here. Either they can directly ask you what is the value of enthalpy, what is the value of internal energy, or they will complicate it by saying what is the value of heat energy at constant pressure. Now everybody tell me what is the value of heat energy at constant pressure in the chat box. Let me see if you are able to recall that or not. If yes, then let me know in the comment section here. What is the value of heat energy at constant pressure? Right? Okay. Yes. Now, this is Gibbs-Helmholtz equation. From here, a lot of questions are asked. Delta G is equals to delta H minus T delta S. So, delta G negative means it is spontaneous, positive means non-spontaneous, zero means it is at equilibrium. Here, they can ask you temperature, the value of temperature, delta S, delta H, delta G, depending upon the question. Okay? Yes? Yes, students? Next is for entropy, what we have to do. Right? For entropy, what we have to do. So, this is a general. Now, remember from here, very rare questions they have asked in your PYQs of NEET, very rarely. But in the recent times, they have asked. That means in this year also, they can ask you this question. But you know, what is the relaxing part? That here they will not ask you numerical based. Rather, they will ask you direct formula based question here. Right? So here you just have to remember these two questions here, these two formulas here. If let's say this is for irreversible adiabatic, if it is reversible adiabatic, value of Q is 0, that is why delta S is also 0. Right? Now for irreversible adiabatic, you have to solve these two formulas. Let's say it is isothermal. In that case, T1, T2 is equal. So either this will be the answer or this will be the answer depending upon what they have given you in the options, right? If let's say we are talking about isobaric process. So isobaric means these two are going to be 0 because P1, P2 is equal. Then this is going to be the answer for delta S. Let's say they are talking about isochoric. Then V1, V2 is 0. Then this will be the answer for delta S for isochoric process. So directly you just have to learn these two formulas and you can have rest of the three formulas from there. Okay, just two formulas and you will get three formulas from there. Right, students? Okay. Understood? Last is thermochemistry, and that's why, because thermochemistry, there is no formula. Okay. So that's why we have to see the question based on thermochemistry to understand that. Right? So from thermochemistry, one question can be based on Hess's law. Other question can be based on, let's say, mostly it is Hess's law question only. Other question can be, they can give you a hint of, let's say, they will give you bond energies or heat of formation or anything like that. So if bond energy is given to you, you will use reactant minus product. Rest of the things you will always do product minus reactant. Okay, you will always do product minus reactant. But in bond energy, it will be reactant minus product. Okay, let us do some questions based on thermodynamics here. Okay, students, let us do some questions based on, we have 1, 2, okay, good amount of questions we have here, right? So let us solve the questions. Consider the following processes, right? Consider the following processes. This process, this is based on Hess's law, okay? So here it is given. This is the first, second and third equation, and they are asking you about for this equation where you should have B and you should have D. Okay. So how you will solve this? From these three equations. So firstly, this will be divided by 3. That is clear to us that this will be divided by 3. Okay. Then you should have D here. Right. D is possible. D is possible. Wait a minute. There are hit and trial method. First, you have to do this. Right. So I will not waste my time on that. So directly I will tell you what you have to do here. Right. So if you use adding, okay, by adding the three equations only we are getting, right? Okay. So this is A, that is eliminated by this. This is the 2B. So this will be 2D. So this will be 3B plus 2D give rise to, this is 2B plus 2C, and this is plus D plus E. Okay. So what you have to do, this is 3B minus 2B, this will be B. 2D minus D will be D. So these all will be cancelled. This will be 2C plus E. Okay, so that will be the correct answer. Yes, by adding all of these, you are getting the correct answer, right? So in the final answer, you just have to add all of this, right? And then you will get your answer, right? This is what Hess's law says, that if you have, let's say, from A to B you are going, then from B to C you are going, from C to D you are going, right? Here it is 1, this is 2, this is 3, and you have to calculate from D to A. Then this is 4. So the 4 is equals to 1 plus 2 plus 3. This is what Hess's law says. Okay? Understood, everybody? This is what Hess's law says. Next is the question based on, a gas is allowed to expand in a well-insulated container against a constant external pressure. Now everybody tell me, constant external pressure, is this we are talking about? First thing is, it is insulated container. Now I have shown you the formulas, but if you don't know how to apply that in the questions, okay, then what is the use, right? Okay. So insulated container means we are talking about insulation. Whenever there is insulated container, that means we are talking about adiabatic process. Okay. Now against a constant external pressure, is this reversible or is this irreversible? Let me know in the comment section. Is this reversible or irreversible? Of 2 atmospheric from the initial volume of this to this. V1 is given to you. V2 is given to you. Change in internal energy they are asking you. Delta U is equals to Q plus W. We know that adiabatic Q is 0. So delta U is equals to W. Right? What is the work done? See, now here they have not given you anything regarding this CBM, CPM, no monatomic, diatomic. So what you will say, that work done is equals to minus P delta V. Okay, directly from that, this is the pressure, this is the volume, right? They have asked you this in joules, and this answer will be in liter atmospheric. So you have to convert liter atmospheric into joules by multiplying it by 101. Okay, so the answer will be multiplied by 101, and then you will get your answer in joules. Okay, and that W will be equals to delta U only, right? So answer will be, first you have to calculate the value of volume, work done in atmospheric, liter atmospheric, then you have to convert this into joules here, right, by multiplying by 101.325 if you have to do like very specific. Otherwise, if you don't remember that, directly you can choose 101 also. You have to see if the options are, the options are very near to each other. So I'll rather choose 101.325. Okay. Now delta U is W. So that's why that is the same answer for this. Okay. Yes. Next is, okay. Now, two important questions, theoretical questions from this chapter, right? The topics that I skipped is, right, that is why I kept a question here for that. That is your extensive and intensive property. So remember that intensive property, everybody let me know, intensive property, they are independent. They are independent of the work done, independent of the mass, right? And extensive property, extensive are dependent, okay? They are dependent, right? Now here they have asked you, out of the following specific volume, see, whenever you have something specific, here that is not dependent on the mass because you have specified the mass here. If you have something like molar, here also you have specified the mass. So that is not dependent. That automatically will be intensive property. Okay, if you have anything see, heat capacity is dependent on the mass, right? So that means heat capacity is extensive property, right? Okay, volume is also dependent, right? Wait a minute, heat capacity, this, what is third then? Fourth extensive property. What is fourth? Out of, okay, this is first. I'm so sorry, this is the first. If you have molar, if you have specific, that will turn out to be intensive. This is also intensive, this will be extensive, this will be extensive. So answer will be third and fourth. Yes, D is the correct answer. Okay, so what you have to remember, heat capacity, that is independent. That is dependent. But if you have anything which is, let's say, which is using specific or molar, heat capacity is extensive because it is dependent. But if you specify the grams, if you specify the moles, that means now this is not dependent. You have specified something, right? That is why that becomes intensive property. This is a very important point, right? Okay. And one more important thing is density is equals to mass by volume. Now, if you see, volume is the extensive property. Mass is also the extensive property, right? Mass will depend on what amount of mass you will take. Density is the intensive property here, right? Okay. Density is the intensive. That means the ratio of two extensive is going to be the intensive property, right? Okay. Yes, everybody, right? Okay. Next is, which of the following quantities is not a state function? What is the state function, everybody? What is the state function? State function is that depends on the path. State function is that does not depend on the path, right? So delta G, delta U, entropy and enthalpy, all of them are the state functions. Okay, all of them are the state functions. If you say they will not depend on the path, that's why we calculate delta G, delta S, delta U directly. If you talk about work done, if you talk about Q, both are the path functions. Okay, both are the path functions. So if you see this here, which of the following is not a state function, that means they are asking you path function, right? So path function is work done is the path function. Okay, so answer will be D is the correct answer. Is that clear to everybody or not? Right? Next chapter we have is equilibrium. Right? Okay. Yes, everybody. Ready for equilibrium? Firstly, I want you guys to spam it in the chat box. That is TD is also done. TD is also done. Third chapter is done. Okay. Next chapter is equilibrium. Equilibrium. Okay. Yes, everybody, equilibrium. Break, ma'am. After equilibrium, I'll definitely give you the break. Okay? After equilibrium, I'll definitely give you the break. First, you have to study equilibrium. Okay? Break will not be that much long. Break will be around 2-3 minutes. Okay? I'll give you just 2 minutes of short break or maybe 5 minutes of short break. Okay? Yes? Now, TD done. Spam it in the chat box. Now we have equilibrium. Right? Write down CE. CE, spam CE and IE in the chat box. Spam CE and IE, chemical equilibrium and ionic equilibrium in the chat box. First, we will start with the chemical equilibrium, then we will start with the ionic equilibrium. Now you can spam CE in the chat box, that is chemical equilibrium. Chemical equilibrium, right? Okay, chemical equilibrium. Let us start that. First is, you have, let's say this is the reaction that is given to you, right? You have Kc, Kp and Kx. That will always be product raised to power stoichiometry divided by reactant raised to power stoichiometry. If you're talking about concentration or pressure or mole fraction, that will be that term raised to power the stoichiometry. For example, in Kc, it is concentration of C raised to power stoichiometry, of concentration of D raised to power stoichiometry divided by concentration of A raised to power stoichiometry, concentration of B raised to power stoichiometry, right? Okay, next is that units of Kc is mole per liter delta Ng. Delta Ng is the number of gaseous product minus number of gaseous reactants. Units of Kp is atmospheric raised to power delta Ng. Now the relation between Kp and Kc is Kp is equals to Kc RT delta Ng, right? And Kp, this is a very important relation. Kp is equals to Kc RT raised to power delta Ng. This is not an important relation, right? This you can skip also, but yes, if you want to be totally risk-free, till now they have not asked this, but what if they ask you right now, what if this is the first time they will, at least 1-2 questions will be new, right? Right, I would say at least 3, 4, 5, 6, on average, maybe 5 questions can be completely new for you. Out of that, 2, 3 concepts can be completely new for you, right? So this might be that. Otherwise, the questions that they ask new are usually not very dramatic questions, very difficult questions. There will be some from very small topic of your chapter. So Kp is equals to Qx P raised to power delta Ng, right? Now, remember that whenever we are using, now in this full, what R value you will use? That is a major part. Ma'am, we have done so many chapters. See, R will be 8.314, that is 25 by 3. If we are talking about energies, joules and all that. If you are talking about liter atmospheric volume pressure, then you will use 0.0821, that is approximately 1 by 12. You can use 1 by 12 to ease your calculations here, right? Okay. Now, next thing is that if you see, whenever you are using Kp, Kp can only be written if at least one of the values, one of the reactant or product is gaseous, has the gaseous phase, important point. Then concentration of pure liquid and pure solid is always going to be 1 when you're writing this value, that is the concentration. So pure liquid, out of this, you will not write the concentration of pure solid or pure liquid, right? That will be equals to unity, right? Next is a question based on the reverse. This is a very simple kind of question, okay? That is factors on which K depends. So simple is, if you reverse the reaction, the equilibrium constant will be reversed. If you multiply something, if you, let's say you multiply it with 2, 3, 4, whatever, right? That multiplying factor will be on the, that means be in the power, okay? So K2, the new, the equilibrium constant of the new reaction will be the equilibrium constant of the old reaction raised to power the multiplication factor. If you're dividing this, let's say you're dividing by 1 by n, so that will be in the power, okay? If you're adding 2 reactions, their equilibrium constant will be multiplied. If you're dividing, if you're subtracting 2 reactions, their equilibrium constant will be divided with each other. If that is clear to you, then let me know in the comment section. If that is clear, students, then let me know in the comment section. Everybody, right? Next we have is log K2 by K1, okay? It's a very, very important formula, right? They can also ask you this in the form of, let's say, conceptual question, or maybe some question like they will ask you the numerical value, maybe they can ask you the value of delta H or something like that, right? So let's see, this is the formula, that is log K2 by K1 is equals to delta H 2.303 R T2 minus T1 by T1 into T2, right? Now, if this is an exothermic reaction, that means this is delta H is negative. Endothermic means delta H is positive. So if delta H is negative, this value is negative, this whole value is positive because temperature is increasing. If log of anything is negative, that means that anything is less than 1. So K2 will be, that means K2 by K1 is less than 1. That means K2 is less than K1. That means whenever we are increasing the temperature, rate constant is decreasing. That means temperature, not rate constant, equilibrium constant. So equilibrium constant and temperature are inversely proportional to each other, right? Now there is endothermic. That means this is positive. If this is positive, overall answer is positive. If log of anything is positive, that means that anything is greater than 1. That means K2 is greater than K1. Now here temperature is increasing and rate and equilibrium constant is increasing. That means they are directly proportional to each other. Okay, that means they are directly proportional to each other. Is that thing clear to everybody or not? Right? Okay. For endothermic and exothermic, how temperature dependencies vary. Okay. Next is extent of reaction. So very simple thing. If we say K is less than 10 raised to minus 3, so that means it's a very slow reaction. If it is between, that means it's a moderate reaction. If it is fast than 10 raised to 3, then it is extremely fast reaction. Okay. Next we have is QC, that is reaction quotient. The formula is same. It's just that when you are at equilibrium, QC, we call it equilibrium constant, that is Kc, right? Okay. So reaction quotient, how you remember how to solve this? So what they will give you in the question, they will give you QC value is this. They will give you how to solve the value of Kc. Kc you will solve in the numerical. Then you will have to tell whether it's forward or it is backward or it is at equilibrium, what kind of reaction that is. So Kc will always is constant. This is fixed. QC, if it is greater, you will have to go backwards to make it equal, right? If QC is less, you will have to go forward to make it equal. If both are equal, that means it is at equilibrium. So if QC is greater, it is a backward reaction. QC is less, then it is a forward reaction. So answer will be forward, right? That's how you're going to answer this, right? Okay. Now everybody, your full focus should be on the screen because right now I'm telling you degree of dissociation, a very, very, very important thing, right? So I have told you the numerical part, right? Okay. But by just doing the formula, you won't be able to solve the question of Kc and Kp. You need to know some core concept here that I'll tell you here. First is degree of dissociation, that is number of moles dissociated by initial value, right? That is given in the question. Okay. So by that, I want to say either it will be given in the question or you will take the stoichiometry or you will take unity. How? I'll tell you that, right? So here what we have is this equation we have here, because nothing is given in the question, I'll take the initial moles as unity for the reactants. Okay. I'll take this as 1, this as 1. If nothing is given, you can also take stoichiometry as the initial moles. Totally your choice. I'm taking here at unity. 1, 1. So what is the equilibrium moles? Stoichiometry multiplied by x. 1 minus x. 1 minus 2x. And here it is 3x is formed here, right? Now, concentration, that is expressed in terms of molarity, that is number of moles divided by volume. Let's say the volume in that vessel is capital V. So this number of moles by volume is concentration, concentration, concentration. Right? This I am telling you, if they have not given you the value of concentration, you have to solve it like this. There is no formula for this. The formula will vary for each reaction. That's why I am giving you the steps here. Firstly, calculate the moles. Then calculate the value of concentration. Then Kc will be C raised to power 3, B raised to power 2, A raised to power 1. Put the value of C here, that is this, B here, this, and A here, that is this, and you will get your answer. Okay. Similarly, for Kp calculation also, for Kp, what you have to remember that we are using partial pressures, and partial pressure is mole fraction multiplied by total pressure. Total pressure for the vessel, I'll take it as P, that in this vessel, let's say the pressure is capital P, right? Any reaction is given to any random reaction I have taken here. So this is 1, 1, 0. So this will be 1 minus stoichiometry multiplied by x, 1 minus stoichiometry multiplied by x, stoichiometry multiplied by x, that is the answer at equilibrium. Now, firstly, you have to calculate mole fraction. So you have to add all of this. By adding this, you will get the total moles is equals to 2 minus 3x. Now, mole fraction is number of moles of that component by total moles. That's how you got the mole fraction of each of them. Now, partial pressure is mole fraction multiplied by total pressure. So that's why this is the partial pressure. Now we know that what is the value of Kp. Kp is equals to the value from this pressure of B cube divided by pressure of C raised to power 4, pressure of A raised to power 2, right? This is what you have to solve. Then put the values and you will get your answer for Kp here, right? These are the steps that are important for you to note down, right? Okay. Yes, students. Everybody let me know if that is clear to you or not. Everybody let me know. Next is a very important equation, that is delta G is equals to RT ln of KQ. If they ask you the relation of delta G and KQ, direct question they ask you from delta G and KQ. So directly you can apply this formula. Either they will ask you the value of delta G or they will ask you the value of KQ. Now, when Kc, that is equilibrium constant, is greater, then if this is positive, we know that this is going to be negative. That means it is going to be a spontaneous process, right? Okay, that means it is going to be in the forward direction, right? If Kc is negative, then this will be positive. That means it is non-spontaneous process, which does not want to occur. So this will go in the opposite direction. If Kc is equals to 1, that means delta G is 0. That because natural log of 1 is 0, right? That means delta G is 0. That means the process is at equilibrium. So there will be no shift in that reaction. Okay, understood? Next part of this chapter, chemical equilibrium, the last part is Lee-Chartlier's principle. Let us do, right? Okay, let us do the question based on Lee-Chartlier's principle. So Lee-Chartlier principle means always it has to go opposite of what you do. Whatever you do, that will behave the opposite, right? So if you increase the concentration, it will try to decrease the concentration. Let's say I'm increasing the concentration of reactant. This is reactant, this is product. If I increase the concentration of reactant, it will try to decrease the concentration and the reaction will move backwards. Okay. If I, let's say, increase the concentration of products, it will try to decrease the concentration of products and it will try to go in the backward direction, right? Okay. I think initially I told you the wrong way. Okay. So if the reactant concentration is, we are increasing, it will try to decrease it and the reaction will move forward. Okay. Yes, that will try to do the opposite thing. Now here important point is where the previous year question of NEET has been asked, that is no effect of solid component. They will give you some solid component. If you add this, if you add that, there is no effect of any solid component on the reaction, right? Next is pressure. So whenever you increase the pressure, the reaction will shift on that side where number of moles are less. Okay. So whether it's forward side or backward side, that depends. Wherever number of moles are less, it will shift to that direction, right? Volume is opposite of volume. Volume is opposite of pressure. That means when volume increases, it will shift in that side where number of moles are more. Where number of moles are more, it will shift to that side. Okay. Yes. Next we have is temperature. Now for an exothermic process, I told you, here only we have discussed it. For exothermic process, we have discussed it here, right? That for an exothermic process, temperature is inversely proportional to rate constant. For endothermic, it is directly proportional. So what you can write here, that for an exothermic process, if you increase the temperature, the reaction will move backward. For an endothermic process, if you increase the temperature, the reaction will move forward. Okay. This temperature and from pressure, they ask you the questions from temperature and pressure. Inert gas at constant volume, nothing will happen. At constant pressure, it will shift to that direction where number of moles are more. Okay, at constant pressure, if you add the inert gas, then it will shift to that direction where number of moles are more. Right? Okay. Then how to know exothermic? These two reactions are which are very famous are exothermic. Combustion are exothermic reactions. Decomposition reaction and this reaction is endothermic in nature. Some of the important reactions. Okay. Before doing ionic equilibrium, what we will do is the questions of chemical equilibrium. Let's do 2-3 questions of chemical equilibrium. What kind of questions they can ask you, right? Okay. So at 500 Kelvin, for a reaction N2 plus 3H2 give rise to 2NH3, Kp is 0.036 atmospheric. What is Kc value? This is what they are asking you, right? Okay. For this reaction, Kp value is given to you. Kc you have to calculate directly. Kp is equals to Kc RT raised to by delta Ng. This is what you have to solve. Kp is equals to Kc RT delta Ng. Delta Ng is 2 minus 4, that is minus 2. So we'll put the value minus 2 here. It will be here, right? Okay. So Kc is equals to Kp RT delta Ng. Delta Ng is minus 2. Kp value you will put. R value you know that is 1 by 12 or directly you can say 0.082 multiplied by the temperature that is given to you as, where is the temperature? 500 Kelvin. Wait a minute. If this is 500 Kelvin, this should be 500 Kelvin only. I think here it should be degrees Celsius. See, if here it is written 500 degrees Celsius only, then they will put here 773, right? Simple logic, right? So here, that is why after solving answer you will get, right? Next is for a reaction. Now here this question is based on Le-Chatelier principle, right? For a reaction, this is the reaction. This means it is an exothermic reaction. They are saying favorable condition to occur in forward direction. For forward direction, see, very simple. For an exothermic reaction, if you increase the temperature, K will decrease. That means it will go in the backward direction that we don't want. That means we have to lower the temperature so that K should also increase and it will move in the forward direction for an exothermic. That means low temperature, right? Then pressure. Number of moles of reactant is more as compared to product. So that means to make it in the forward direction, we have to increase the pressure, right? So when you increase the pressure, it will go in less number of moles. Less number of moles means less number of moles are there in the product side. That means forward reaction will be there. So answer is B is the correct answer. Is that clear? Right? Okay. Delta Ng, students, very simple. Delta Ng is product minus reactants. Okay. So this is the reaction. This is product side 2 minus reactant is 3 plus 1, that is 4. So delta Ng will be minus 2 is the value of delta Ng. Okay. Next question is, I think that is based on ionic equilibrium. So let us start ionic equilibrium. Let us start ionic equilibrium. Okay, students. Everybody ready for ionic equilibrium? Are you all ready for ionic equilibrium? Right? The biggest part in 11 classes, your physical chemistry has a major role and inorganic chemistry has a major role. Organic is very less, obviously, in 11th class. Tomorrow you will see very less physical chemistry, very less inorganic chemistry. More focus will be on organic chemistry tomorrow. Right? Not tomorrow, that is on Thursday. Right? Okay. So here what you have is ionic product you have. Okay, so what is ionic product? Ionic product is H positive concentration multiplied by OH negative concentration. Now, as you increase the temperature, right? As you increase the temperature, Kw also increases, right? So that is why when temperature is increasing, Kw is also increasing here. But at 25 degrees Celsius, Kw is fixed, that is 10 raised to power minus 14. Okay, it is fixed to 10 raised to power minus 14 in that case. Is that clear to everybody? Next is, ma'am, P of anything. when you have to take pH, pOH, pKw, pKa, pKb, whatever, P of anything is minus log of that anything. That means if I say pH, that will be minus log of H positive concentration. pOH is minus log of OH negative concentration. And pH plus pOH is equals to 14. Okay. Next is H positive and pH are inversely proportional to each other. So obviously this anything and this pH of anything is always inversely proportional. Let's say the value of Ka and pKa is also inversely proportional, right? The value of Kw and pKw is also inversely proportional. Okay. So the value of P of anything and that anything is always inversely proportional to each other, right? Now, first kind of question that is there in ionic equilibrium is based on, they will ask you pH values. Okay. pH value, if they ask you simple, some strong acid is given, directly you will say that will be H positive acid plus 10 raised to minus 7. Right? H positive of acid plus 10 raised to minus 7 is what you have. Right? Now, if I say H positive concentration is greater than 10 raised to minus 6, I have to ignore 10 raised to minus 7 here. If I say that H positive concentration is equal or less than 10 raised to minus 6, then I'll have to take this 10, I have to add 10 raised to minus 7. Same is in the case of base, but here we are talking about which concentration, if it is greater or less, according to that we will ignore 10 raised to minus 7 or not, right? Then if you have two strong acids, that will be N1V1 plus N2V2, V1 plus V2 if both are added. If two strong bases are added, then OH negative concentration will be N1V1 plus N2V2 divided by V1 plus V2. Normality is N factor into molarity. N factor will be dependent on the base or acid what you have. Let's say you have HCl, which is giving you 1 H positive. So here N factor is 1. Let's say you have H2SO4, which is giving you 2 H positive. So here answer will be N factor is 2. If you say that, ma'am, we have two strong acids, no, not two strong acids, one strong acid and one strong base. Now, whether you will calculate the value of pH or pOH, that depends. Okay. So now, what you will do, here this will be either pH or OH negative, depending upon which value is greater. If the value of N1V1, N and V of acid is more, in that case, it will be H positive. If the value of N and V multiplication of normality and volume of base is more, in that case, you are calculating the value of OH negative, right? So it will be mod of N1V1 minus N2V2 or NM1V1 minus MN2V2, okay, right, divided by V1 plus V2. If you have, let's say, weak acids, so for weak acids, directly we solve this thing also, that is CH3COO negative plus H positive. We know that this is C, this is 0, this is 0, this is C minus C alpha, this is C alpha, this is C alpha. That is why the value of K is going to be C square alpha square C1 minus alpha. So that is why it will be C alpha square by 1 minus alpha. Alpha is very small, so you can ignore this. That is how Ka is equals to C alpha square, which is written here. Okay. So this we are talking about weak monoprotic acids, okay, which is only going to give you one proton. Okay, we are talking about those acids, right? Here important part is to remember the value of this pH. That is very, very important. They will ask you the pH value in case of weak acids. Just remember this thing, this you can ignore, this you can ignore, right? But this thing you should remember, and this thing, that is pH is equals to half of pK minus log C is the value of pH here, right? Then buffer solutions also, you have three kind of buffer solution. For, see here the major part is you should remember the formulas, right? It's not difficult to identify which is the formula you should apply. The difficult part is to learn the formula. Okay. So for acidic buffer, pH is pK plus log of salt by acid. For basic buffer, it is pOH is equals to pKb plus log of salt by base. And for salt buffer, it is equals to 7 plus half pKa minus pKb. pK, pKb, everything will be given in the question. The question will be very simple. Okay. Now, next is buffer range, this and that you don't need to do, right? This you can skip, that is not needed, that is not at all needed. Buffer capacity, they will definitely not ask you that, right? This you can still do, this you can do, that is a buffer range will be, for acid it is pK -1 to pK +1, for base it is pKb -1 to pKb +1, okay? Next we have is salt hydrolysis, which is again a very important topic. See, if you have anionic salt hydrolysis, that means you have weak acid and strong base. Cationic, you have strong acid and weak base. For cationic and anionic, you have both weak acid and weak bases, right? Now, we are talking about those cases where one of them is weak. Let's say you have weak acid or you have weak base. Both are not weak, right? So this is the trick that I have formed for you. That is KH is equals to KW by K weak. So KH for weak acid will be KW by Ka. For weak base will be KW by Kb. H is equals to under root KH by C. So H is equals to under root KH by C. You can solve this and you will get this as your answer. This also H is equals to under root KH by C. You will get this as your answer. Okay, understood? Now, for H positive, OH negative, when you're talking about weak acid, you will calculate H positive. That is going to be C into H. H is this, C multiplied by this. You will take under root, this is square. This and this will cancel. So this will be C KW by Ka. You don't have to remember this. Just remember this thing that H positive is C into H. Whatever H value you are getting here. C into H, whatever H value you are getting here. Right? Okay. Now, this formula, I will not advise you to do a derivation in the exam. That I definitely will not advise. Reason being, you find it difficult, ma'am, I am not able to learn these formulas. You have to learn these formulas, right? You have to write it again and again. You still have days. You still have 17, 18 days left. You still can learn these formulas. It's not a big deal to learn these formulas, right? Okay. So, this is the formula when you have weak acid, pH is 7 plus half pKa plus log C. For weak base, pH is equals to 7 minus half pKb plus log of C. That is the formula for weak acid and weak base, right? If you have both weak acid and weak bases, then KH is equals to KW by K weak. That is KH is KW by Ka and Kb, because both are acid and base are weak. H is equals to under root KH, under root KH. H positive concentration here is Ka into H. So this is Ka multiplied by this H. This you can solve this. This will be square under root. This will cancel out. This will be Ka into Kw by Kb. That is the final answer. If they ask you H positive. So I am telling you, they will ask you pH or POH. Definitely they will ask you pH, 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 right? Okay. So the value of pH is 7 plus half pKa minus pKb is the value of pH if you have weak acid and weak base both. Now this is like favorite question of NTA, solubility product, one of the favorite questions right now. I think the examiner is in love with the solubility product, right? So here it is AX, BY, XA and YB. So what you have to do with solubility product, direct trick is X raised to power X, Y raised to power Y, solubility of X plus Y, that is the formula of KSP, right? Okay. But if you have common ion here, let's say you have common ion effect, if you have Na, they have given you some other ionic compound, let's say NaF also they have given this is 0.1, okay. So this is 0.1, 100% dissociation will be there for ionic compound, 0.1 and this is also 0.1. Till now this is 0.1. From here, now you can't use the trick. If this is S, this is 0, this is 0. After the reaction, this is 0, this is S. Because this is 2, so this will be 2S. Now this is 2S here, this is 0.1. So you have to add 2S here. And here you have to add 0.1. Now this whole term is approximately equal to 0.1 because solubility is very less as compared to 0.1. Like we always ignore alpha value, that's how we are ignoring the value of solubility here, right? So KSP is solubility of Ca raised to power 1, solubility of F raised to power 2. So that is how you will get your answer for KSP here, right? So you have to see whether there is common ion effect or not. If they ask you difficult question, they will give you common ion effect. If easy question, then definitely direct question will be there, which you can solve from this direct solubility product trick, right? Okay. Yes, everybody. Now let us see some questions based on ionic product for you. Let us see some questions based on ionic product, right? First is 1 liter of point. This aqueous HCl is mixed with this much liter of this aqueous H2SO4. Assuming complete dissociation, no change in the volume upon mixing. Okay. They are saying there is no change in the volume. So V1 and V2 both are same. Is mixed with 1 liter. Wait a minute. Is mixed with 1 liter of this aqueous this. Okay. Okay. So here what you can do is H positive concentration will be HCl N factor is 1. Okay. So here it is 1. Molality is given to be 0.02 multiplied by volume is 1 plus. Here N factor is 2 because 2 H positive are given here. Right. So N factor is going to be 2. So it will be 2 multiplied by 0.01 multiplied by 1 liter. Divided by 1 plus 1 is 2 liters. So it will be 0.02 plus 0.02 divided by 2, that is 0.04 divided by 2, that is 0.02. Okay. Now what is the pH? pH is equals to minus log of H positive concentration. H positive concentration is going to be 2 into 10 raised to power minus 2, right? So here it is going to be, you can just solve this, minus of log 2. This will be minus of log 10 raised to power minus 2. This will come to this side. This will be 2 here, right? 2 minus 0.301. That will be your answer, right? So it will be, I think, something 1.7. Yes. So answer will be 1.7 because the value of log 2 is 0.301. Right? Okay. Understood? Next is, they have given you one. Achha, this is a question of chemical equilibrium, right? This is a question of chemical equilibrium. We will do that. No worries. We will do that, right? So this is a question of chemical equilibrium. They have given you some reaction here. This is, I think it should be A. Yes, A give rise to B plus half of C. This is the reaction. A give rise to B plus half of C. Okay. So the correct relationship between Kp alpha and equilibrium pressure P. The same thing that I told you while we were doing the derivation. So here they have taken it as 1 and you can also take it as 1. Your choice. If I take this as 1, this will be 0, this will be 0, this will be 1 minus alpha, this will be alpha and this will be alpha by 2, right? So that will be the answer here. And here total number of moles will be alpha will cancel each other. This will be 1 plus alpha by 2 is the total moles. Okay. 1 plus alpha by 2 is the total moles. Now you have to, this is the equilibrium moles, this is the total moles. You will get the mole fraction here, right? So rather than this, I'll just solve it like this. 1 plus alpha by 2 is the total moles. I'll just solve it for you, right? By the same method that we did, right? By the same method that we did, okay? So here it is, mole fraction is what? 1 minus alpha, 1 plus alpha by 2, right? This is alpha by 1 plus alpha by 2. This is alpha by 2 by, or you can also write it as alpha divided by 2, 1 plus alpha by 2. Okay. Now, you have to multiply it by pressure, that is capital P, and this is your partial pressure. This is your partial pressure. Now what you will do, this is the same thing that I have written over there, right? That's the same thing, right? Okay. So now you have partial pressure. You will put all the values here. We know that what is the value of Kp here? Kp is equals to B raised to power pressure of B raised to power 1, pressure of C raised to power half, and pressure of A raised to power 1. So B you will put, pressure of C you will put, pressure of A you will put, and by solving this is the answer that you will get in the end, right? So same derivation we are doing here, right? Okay students, understood or not? Next is for a sparingly soluble salt AB2, the equilibrium concentration of this and this is this, okay, respectively the solubility product of AB2. Now they have given you the concentrations here. So what you will do, rather than applying the trick, you have to solve this with the help of concentrations. So this is AB2, A2 positive and 2B negative. How? Because cross product will be A2 positive and B negative. So here you have 2 of B, that means here you will have 2B negative, right? Okay, so that is how you dissociate this. KSP is concentration of this raised to power 1, concentration of this raised to power 2. Concentration of both are given to you and hence you can solve the value of KSP here. So I have given you 3 methods of solving KSP. One is by concentration, other is by solubility, right? That is direct trick. One is by common ion effect. All 3 we have done. Beyond this, they will not ask you any question of solubility product. Okay, students? Yes, everybody? Yes, everybody? So we have done physical chemistry till now. Now we have, yes, calculation is definitely big, yeah? At least if they will give you simple formula, they will give you calculation, right? Okay. So in organic chemistry, we have exceptions, we have chemical bonding, right? Where we have MOT, we have VSEPR, all these things, right? Okay. So how many of you want break? Let me know in the comment section. Okay. Let me know. Firstly, let me see if the likes are beyond 300, then I'll give you break. No, that is not beyond 300. So why it is not, if you turn it beyond 300 in just 2-3 minutes, then I'll give you break. Right? Okay. Yes. Practice, Sukhmeet, more and more practice. Okay. If you want break, I'll give you break of only 2-3 minutes. Okay. Right? So it is 8:19. Let me see how many likes still here. Right, I told you the target is 300. If you achieve 300 in just 2-3 minutes, only 1 like more increase. Right? Then how you will get the break? Then how will you will get the break? Huh? So I'll just give you break for, let's say this is 8:20. Right? I'll put the timer, right? And you will get by 8:25 I'll be here. Okay? And you have to make the likes of 300 plus by then. Right? Okay. So I'll just give you the break. I had one sweet. Right? What you had in this small break? If you want to have dinner, you can have side by side. You are not going to solve questions. Okay? You can eat and listen to me side by side. Okay? That's how you can have your break. Okay, students? Because after that, Baswa sir is going to join. Right? At 10 p.m. I'll try to cover full chemistry by 10 or 10:15 maximum. Right? After that, Baswa sir is going to join. So you can't say that, okay, ma'am, we'll wait for you to get like this over. What you can do, you can have your dinner side by side. Okay? Yes? I can't eat in between the class like this. Right? I can't do that. Very unprofessional. Now, inorganic chemistry, we are going to start. For inorganic chemistry, some important points that I didn't cover in the exceptions part. I'm not going to repeat things again and again. As I told you, I know your time is very precious. So some parts that I didn't cover in the exception, and exceptions also I'll do, but very important exceptions, right? Okay. So now here is Lothar-Meyer curve. One important thing is, from this curve, what they can ask you, that the group 1 alkali metals are on the crest. As you can see, Lena, Ki, Ruby, say friendship. So it is there on the crest. Okay. So descending portion, that means, or if you see the trough part here, then you have metalloids. Okay. In the trough part, that is over here, you have the metalloids. Okay. Over here, you have the metalloids. These are all the metalloids that you have in the crest part. Right. Okay. In the ascending portion, ascending means this portion. In the ascending portion, you have alkaline earth metals like you have beryllium, right? Okay, sorry, this is in the descending. This is descending, right? Beryllium, magnesium, calcium, strontium, barium. These are in the descending part. Ascending part, you have what? You have halogens. Like this is chlorine. This is, wait a minute, ascending part, no. So this is bromine. This is the ascending part, you have iodine, right? Chlorine, bromine, iodine, you have it on the ascending curve, right? This they can ask you from the Luther-Meyer part. They will not ask you anything regarding this curve except for this thing, right? Okay, they will not ask you to draw the graphs, right? Then one important thing you should know about all the blocks here. What is the configuration, general configuration, right? It is NS 1 to 2, S will be 2, NP can be 1 to 6. In D block, S will be either 1 or 2, and in D you will have either 1 to 10, anything you can have. But the exception is PD, in which you have 5s0 electrons, okay? In which, guys, just give me a minute. Just give me a minute. Okay. Now what we have is the PD, that is 5s0, right? You have 4d10 electrons here. That is the exceptional electronic configuration. Then in F you have n minus 2 anti-penultimate shell, you have 1 to 14. In D you have 0 to 1 electron will be there, and in S you will have 0 electrons, right? Here this is belonging to group 1 or 2. This is from 13 to 18. You have the groups. This is from 3 to 12, you have the groups. And here F block belongs to group number 3, because this start from lanthanum, after lanthanum and after actinium, right? Now, elements here you have 12 plus hydrogen, 37 elements, 40 elements and 28 elements, right? Properties, they are very reactive metals. P block includes metals, non-metals, metalloids, all of them. In D block, you have transition elements, which shows variable oxidation state. This is there in 12th chemistry, so we will do that on Thursday, right? Then F is again on the 12th chemistry, that is your DNF block, that also we will do in detail. Inner transition elements, that is, these are radioactive in nature. The actinoids are very radioactive in nature. Next is the magic number. These are the magic number, that is 2, 8, 8, 18, 18, 32 and 32. These are the magic numbers that you are going to add here, right? So what exactly you will see, that as you add 2 electrons here, you will get to the next species, okay? So this is 2 plus 8 electrons will give you next element in that group. Plus 8 element will give you next element in that group. Plus 18 electrons will give you next element in that group, right? Next is one question from IUPAC naming. For 0, it's nil, 1 and 2 by 3 tri, 4 quad, 5 pent, 6 hex, 7 sept, 8 oct and 9 in, right? In the end, you just have to add IUM here and you will get your answer, right? For example, let's say 106. So it is 1 is un, 0 is nil, 6 is hex, so it is un-nil hexium, right? So that is how you're going to solve this. Only in 2 years till now, they have asked you these common names, right? So common names, if you want to be totally risk-free, if you are aiming from 720 marks, let's say, right? You are aiming from 700 plus marks, I would say. Then you should go and you should you have to cram these names as well. But if you are aiming from something 650 plus or 600 plus, I don't think so you need to have these names, because very less probability we have of they will ask you this question, okay? Not based on the naming, based on the common names, okay? Now let us see the variations here, right? Variations, the trends, how they will ask you the question from the 300 likes accomplished. Very good, very good, very good. Let me see that. Let me see that. Very good, right? Now, variation of atomic radius and size, right? Atomic radius, always remember, atomic radius is decreasing along the period, down the group it is increasing. Ionization enthalpy, electron affinity, and electron negativity all are opposite to atomic radius. Okay, so now here you have directly what is the radius. So this is, we know that noble gases, we know that along the period this is decreasing, atomic radius is decreasing, but noble gases has the maximum radius. Okay, so though it is decreasing, but noble gases will have the maximum radius because they show van der Waals radius, right? Next we have is from groups, right? For S block, down the group we know that radius is increasing. But in 13th group, you will see one exception here. Rest of the things, you will not see any exception anywhere in terms of radius, right? Here the exception is between aluminium and gallium, right? So it should decrease, it is increasing down the group. That means aluminium and then it should be gallium, right? But in reality, what happens? Gallium is less as compared to aluminium. Reason? What is the reason behind that? Reason is that because of the poor shielding effect of d electrons. Mostly the reason will be poor shielding effect of d electrons or f electrons, right? Then you have ionization enthalpy. No, then you have in D block. This we will do in detail as well. But now, for now, what you have to remember that till group third, fourth, fifth, and sixth group, right? Fourth, fifth, and sixth group, it is increasing down the group. But after third group, we have the addition of lanthanoids and actinoids because of the poor shielding effect of 4f electrons and 5f electrons. Very, very important thing. Then fifth and sixth period will have the same radii. That is 4D and 5D series will have the same radii because of lanthanoid contraction. Those who are not able to understand what is lanthanoid contraction, don't worry. I am going to do this again in the Thursday class because we have in detail, we have DNF block, right? We are going to do that again. Don't worry about that. And right now they ask you more questions on DNF block rather than P block and periodic classification. In P block and periodic classification, more questions are on trends and oxides and these kind of questions they ask you more, right? Okay. So 3D, what exactly happens? We know that along the period, the size should decrease. But what exactly happens? The size decreases till manganese, then it remains constant from manganese till nickel. After that, again, the size increases. That is the variation in 3D series. Next is a very, very important question, that is isoelectronic species. Isoelectronic species, directly what you have to remember is size of isoelectronic species is more the negative charge, more is the size, and it is inversely proportional to the positive charge. That means more the positive charge, less will be the size. Isoelectric means like you have Mg2 positive and Na. Which will have more size? Na positive will have more size because the charge is less. Both have 10 electrons. Okay, so that is how you are going to solve the questions based on isoelectronic species. Next is based on, see, from atomic radius, if you talk about P block and periodic classification, either they will ask you question from isoelectronic or they will ask you question from this 30. Okay, I am giving you, in the end I am also giving you from where they will ask you the question. Okay, either this thing they will ask you or this thing they will ask you. This thing, isoelectronic species. Now let us see what are the important trends in ionization enthalpy. For ionization enthalpy, what we have is, it is opposite to radius. That means along the period it is going to increase, right? But here also we will see a weird trend. Then it should be lithium, beryllium, boron. It should be beryllium, then it should be boron. Carbon, nitrogen, oxygen. But it is opposite. Because beryllium, we know that this has 1s2, 2s2, which is fully filled. Nitrogen is having 1s2, 2s2, 2p3, which is half filled electronic configuration, right? So that is the reason, because of the stability, it is difficult to take out electron from beryllium, difficult to take out electron from nitrogen. Hence, this is the correct order. And that is why this becomes the exception, and that is the reason this is your previous year question. Now, important part is this trend they have asked you multiple times in your NEET exam. This trend they have not asked, this trend they have not asked. Reason is same. But the thing is, the students who do only previous year questions, they know only this trend. But students who also know the questions that are around the previous year question, they will also know this trend and this trend. Right? You should also do for NaAlMg, sulfur and phosphorus. Then you have gallium and calcium, and here you have cerium and arsenic. Okay, this also you should, right? Then there is important part is boron family. Ionization enthalpy is very weird, right? That is, you will remember this by this W. This is how you draw the W. Now stretch the W a little bit, right? So this will be this thing. So this is BAlGaintl. So firstly you have boron, then you will have thallium, then gallium, then you have aluminium, then you have indium. Boron, thallium, gallium, aluminium, and then indium. That is 1, 5, 3, 2, 4. Okay, 1, 5, 3, 2, 4. You can also remember this by 1, 5, 3, 2, 4. Totally your choice. It is a very, 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 very important for your NEET exam. This, like, repeatedly they ask this question. Okay, right? So next is your, here also you see one exception, right? Here the exception is between this PB and tin. Till here it is decreasing, right? Down the group it should decrease. Till here it is decreasing, but in case of tin and lead it is interchanged. Okay, that is also very important, right? Next you have electron gain enthalpy. See, electron affinity and electron gain enthalpy will always have the opposite shape, opposite sign. That means electron affinity is the ability that I want, the not the ability, that the want to eat something, right? I want to gain one electron. Affinity, electron gain enthalpy is after gaining the electron, how much heat is being released. If you are very keen to eat something, you are very hungry right now, so your electron affinity is positive, and after eating you will release a lot of happiness, you will be very happy. So that is release, that means negative energy. Okay, so signs will be opposite. Now third period more affinity than second period. Can you tell me why? Third period, see, third period is basically, that is your down the group, right? More affinity than second period. 1, 2, 3. Yes. Okay, that is again because of the smaller size. Yes. So third period have more affinity than the second period, right? Third period wants to gain more electron as compared to the second period, right? Then you have down the group, what you will see, majorly these are not very frequently asked, but still I want to tell you this, that here it will decrease. Aluminium, bal, gaye, Indian, tail, but boron will have the minimum. Ka, Si, Gaye, Sant, Prabhu. Here carbon is on the second position. First element is always changing its position. Boron on the last, carbon on the second, nitrogen on the second number, and fluorine is also on the second number. Kasi, Gaye, Sant, Prabhu, Napi, Aise, Sharab, Bai, fluorine, chlorine, bromine, iodine. So boron is on the last point, and carbon, nitrogen, and fluorine, they are on the second number. Okay, rest of the thing is same. Oxygen family, what you will see, here also oxygen is on the last number. So what you will remember for the exam, students, what you will remember for the exam, boron and oxygen are last. Rest of them are on the second position. Rest of them are on the second position. This is how you will remember the trend of electron gain enthalpy, right? Group number 16 has less as compared to 17. Again, this is because of the stability. That here, what you know, that this is NS2 NP, this is 5. After gaining one electron, it will become 6. That means its affinity is more as compared to group number 16, right? Now, this is a very, very important part, that is your oxides, right? You should remember this, that neutral oxides are CO, NO and N2O. Amphoteric oxides are Al, Zn, V, Cr, Pb, 10. So these are your amphoteric oxides. Basic oxides are these, all the metal oxides are basic. All the non-metal oxides are acidic in nature. Mostly what we get confused is amphoteric oxides and neutral oxides, that you should remember, right? Okay. Next we have for central metal atom. Let's say some central metal atom is given to you, right? For same central metal atom, acidic character is directly proportional to number of oxygen atoms. More the number of oxygen atoms, more is the acidic character. Or you can say more the oxidation state, more is the acidic character, right? Then the exception is for phosphooxo acids, right? Here it is opposite order. More the number of oxygen, less is the acidity. Reason is its structure, because it is P double bond O. This is 1 OH, 2 OH, 3 OH. And here it is P double bond O. This is 1 OH, then H, then OH. It is P double bond O. This is H, H, and H. That is how it is H3PO2. Right? PO2, no. So it should be 2 OH. It should be 3 OH. Yes. Okay. So that is the reason. More the number of hydrogens, more is the acidic character. That is why this has maximum. This has maximum, only hydrogen it has. Maximum acidic character. That is why it has. Right? Okay. So that is the important question. Right? Okay. Yes, everybody. Now let us quickly revise some of the exceptions of P block. Right? But let me be very frank with you. On this channel only, right? Okay, on this channel only, this is Vedantu NEET English and this is the live section here. And here you will see P block and DNF block, right? Okay. So just give me a minute here, right? So in this what you will see, wait a minute. In this what you will see, NEET 2025-020, P block and DNF block. So if you actually want to do all the exceptions, you don't want to lose even 1 marks, then I would suggest you go through this particular explanation. You can skip the question part here, because if you see that this particular session is 3.5 hours, right, approximately, with the break, without the break, it is 3.5 hours. If you skip the question part, it will become hardly 2 hours, right? So you should go through this session as well after I complete 11th and 12th class. Okay, that would be my advice to you, right? Okay, rest is totally your choice, right? This is what I'm teaching you is the most important point. There I have completed almost all the points, right? Now, first is group number 13, that is atomic radii. B, this I told you, that is very important. Ionization enthalpy, again very important. Right here, this is interchanged. Here we have learned it, this is interchanged. Here we have learned it with the help of W. Electronegativity, right, also follows a very weird order here. Boron, then thallium, then indium, then gallium, then you have aluminium. Oxidation state, always remember this is NS2NP, right? Lower oxidation state is only P electrons. Higher oxidation state is S plus P electrons. And down the group, lower oxidation state stability will increase. From this part also, they ask you so many questions from that line, right? Okay. Then metallic character increases down the group. Down the group, always metallic character will increase. Along the period, metallic character will decrease. We are moving towards non-metallic character, right? Melting point, how it varies? Gallium, it will decrease up to Ga and then increases. That means this has the lowest melting point in group number 13. That is also the important point. Boiling point decreases down the group. That is why gallium, it has lowest melting point, but it does not have the lowest boiling point. That is why it is a very useful compound, right? Density, general order, that it is increasing down the group, right? Chemical properties, reactivity with air, right? It forms oxides and nitrides. Crystalline boron is unreactive, amorphous reacts, aluminium forms oxide layer, does not react further. Reaction with acids, boron does not react, aluminium reacts with both acid and alkali to liberate hydrogen gas. Aluminium is passive with concentrated acid, nitric acid. Reactivity with halogens, they form trihalides, except, this exception is important, except for triiodide of thallium, they don't form that, right? Nature of trioxides, this is very, very important, very, very important. Boron forms acidic, aluminium, gallium form amphoteric, indium and thallium form basic oxides, right? Next is, this is I think from carbon family. Wait a minute, I think this page should be here, right? Okay. Here what you have, atomic radii, it decreases, right? There is no, it increases down the group, there is no exception. Ionization enthalpy, you will see the exception here, important. Electronegativity, very, very important, very, very important. This question they have already asked, right, in one of the previous year questions. Not in NEET, but one exam conducted by NTA only. So, carbon, then lead, then silicon, germanium and tin has the same electronegativity. That is important, right? Okay. Oxidation state, we know that the order is NS2NP2. So, higher oxidation state is +4, lower oxidation state is +2. +2 oxidation state will increase down the group, right? Okay. Metallic character increases down the group, right? Next is melting point, very important. Decreases up to tin, then increases, right? Boiling point, it decreases only. Density increases down the group, right? Okay, that is same, that is same, that is same. Reactivity with air, it forms monoxides and dioxides. Reactivity with water, very important point. Only tin reacts with steam. Rest of them do not react with even the steam. Rest of do not react with water in any form. This is the important point. Reactivity with halogens, reacts with halogens to form dihalides and tetrahalides, right? Okay. Now let us do some of the questions based on this, right? Okay. Chalo. Everybody, let us start doing the questions based on this, right? Whatever we have studied till now. The IUPAC name symbol for element with atomic number 119. 119 means UU, 9 means, what is 9? N, right? So it will be, what is the answer? In. So answer is going to be UUE. So answer is going to be what? UUE, that is B is the correct answer. That's how they can ask you question from the IUPAC naming, right? Which of the following pairs will form most stable ionic bond? Now, this is a very, very important question, right? So, these are the questions from Fajan's rule. Now, there will be questions based on, see, chemical bonding has some of the important, because now I'll mix this with chemical bonding also, because there is no point of again asking you the question from the exceptions, right? Because you already have seen the exception. If you know the exception, there is no point of me explaining this, like how this will be asked, right? Okay, so we'll not waste our time on that. Rather, we will see some new kind of questions. Okay, so this is basically Fajan's rule. Okay, so you should also go through Fajan's rule, because Fajan's rule also they ask you the question. What is Fajan's rule? The stability of ionic bond depends upon the lattice energy, which is expected to be more between Mg and F due to +2 charge on Mg atom. So if you see, this is Mg2 positive, this is F negative, right? So if you talk about the ionic character here, Fajan's rule will tell you the covalent character, right? So ionic, the following pair will form the most stable. So here we know that this is Na positive, Cl negative, this is Mg2 positive, F negative, this is Li positive, F negative, this is Na positive, F negative, right? So more is the charge on the cation. We can see the different point is here the charge on the cation is +2. More is the charge on the cation, less is the covalent character, right? Okay, so that is why less covalent character means more ionic character. That is Fajan's rule. So B is going to be the correct answer. Okay. Next is which is going to be the correct order of dipole moment. Dipole moment is also one of the important topics, right? How you will understand dipole moment, very, very important topic. See, for dipole moment, you should know that what is the structure firstly, and then you will be able to solve the dipole moment, right? So firstly, so I'll solve the structures only for you. This I'll come again. So the structures we can do afterwards also, right? Okay, first you will see the dipole moment only. So this structures how you will draw, right? I'll tell you in hybridization. Okay. So this is BF3, this is NF3, this is NH3, this is H2. We know that always dipole moment is from positive to negative, right? That means less electronegative to more electronegative. So this is less to more, less to more, less to more. So they all will cancel each other. That means dipole moment is going to be 0 here, right? So that is minimum. In NF3, positive to negative, positive to negative, positive to negative, right? Okay. And here, when we compare it with the lone pair, it will be atom to lone pair. So atom to lone pair. Now the resultant will be this and this. But the resultant here, this is from atom to lone pair. This is the resultant of NF. They will not be equal. This is BF and the resultant of BF. That is why they will cancelling each other. That is why this will cancel, but that will not be equals to 0. That will be greater than 0. Right? Okay. That will be greater than 0. If you see this here all of them are getting added. Positive to negative, nothing cancel. So this will be much, much, much greater than 0. Right? Because there is no cancellation here. If you see this here, positive to negative, then atom to lone pair, again this will be much, 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 much greater than 0. Now, ma'am, how you identified that this is more as compared to this? See, oxygen has more electronegativity. More is the electronegativity, more will be the dipole moment. That is why maximum dipole moment is of this water. Right? Okay, because more electronegativity difference means more this value will be. That means more the value means more the dipole moment. Right? Okay. So answer will be C is the correct answer. Is that clear to everybody or not? Yes, student, is that clear or not? Right? Okay. Next is the correct order of ionic radii. Now, this is the question from isoelectronic species. As I told you, more is the negative charge, more will be the size. Okay, less is the positive charge, more will be the size. So answer is going to be more is the negative charge, more is the size, less is the positive charge, more is the size. So that is why A is going to be the correct answer. This question is from isoelectronic species. Correct order of electron gain enthalpy. Now this is one of the questions, right? Kind of question that they can ask you. Electron gain enthalpy, as I told you, that electron gain enthalpy will vary, right? Okay, how it will vary? Oxygen will have the least electron gain enthalpy. Can you tell me why? Because oxygen will jump, boron and oxygen will jump to the last position, right? So that is why oxygen is going to have the least. Usually what should happen? Down the group electron gain enthalpy should decrease. So it is decreasing only, but oxygen has the least. So answer will be A is the correct answer. Right? Okay. Right? Okay. Next is ionization enthalpy of elements of group 13. Group 13, ionization enthalpy, as I told you, 1, 5, 3, 2, 4. Directly. 1 is B, this is TL, this is GA, this is AL, this is Indian ion. Right? So answer will be, this is the correct answer. Ionization enthalpy. Right? Okay, that is how you are going to solve this. Right? And hence you will get your answer here as D is the correct answer. Next is the question from hydrides, which they might ask you. All the hydride except one possesses reducing property. This character increases from identify the hydrides. They are saying all the hydrides except one possess reducing property, and this character increases from H2S to H2TE. Identify the hydrides. which possess the reducing property, right? That means they are talking about all the hydride except water possess reducing property. Can you tell me why? Because water has hydrogen bonding. Because of this hydrogen bonding, it does not possess reducing properties. So answer will be H2O is the correct answer. Marked oxide, which is amphoteric in nature. Again, the question from neutral amphoteric oxide. From here, you should know the neutral oxides, amphoteric oxides. So here we know that amphoteric oxide is C, all these. The dioxides, these are acidic, these are amphoteric oxides. Among monoxide, this is neutral, this is distinctly acidic. S and Pb are amphoteric in nature. So answer will be C is the correct answer. Right? Okay. Understood? So exception is exception and P block, block chemistry itself is very big, right? Some of things I have taught you here, but in detail, I would advise you to go through that 3 hours lecture, definitely, if you don't want to skip anything, right? Okay. Now let us start some topics of chemical bonding here on your screen. Are you all ready for that? Yes, students? Ready for chemical bonding or not? Yes, everybody? Ready for chemical bonding? Yes. Everybody in the comment section, if you're ready for chemical bonding, then let me know in the chat box. Yes. And why the energy is so low? Why the energy is so low? Such low energy if you give, then what you expect, students? Then what you expect? Full marks and NEET. Let me see how many of you are awake here. How many of you are awake? Right? If you are awake, then let me know in the chat box. If you are sleepy, then also let me know in the chat box. Right? Because we are just left with few things here. After this, I'm going to start GOC, then hydrocarbons, then we will do qualitative, quantitative analysis, and then you can start with your botany class. Right? Okay. So hybridization, very important. One is you have to calculate sigma plus lone pair here. If sigma plus lone pair is 2, it is sp. It is 3, it is sp2. 4, sp3. 5, sp3d. 6, it is sp3d2. For sp, it is linear geometry. sp2, it is trigonal planar geometry. sp3, it is tetrahedral. sp3d, it is trigonal bipyramidal. sp3d2, it is octahedral geometry. Right? Now, from Vesper, we know that lone pair repulsions are maximum. Then you have lone pair, bond pair. Then you have bond pair repulsions are the minimum. Right? So that means shape is only dependent on the bond pairs. We will not see lone pairs. But geometry, we will see bond pair plus lone pairs both. Okay? Here it is. I'm giving you some examples here. So for example, you have, let's say, AB2 kind of molecule. Right? Let's say you have AB2 kind of molecule, and in this molecule, what you will have, right? In this molecule, what you will have is, let's say you have 0 lone pair, you have 2 bond pair. 0 lone pair, that means you have a compound, let's say this, you have no lone pairs, but you have 2 bond pairs here, right? So that is going to give you this kind of linear shape, right? If you have, let's say, AB kind of molecule, which has 1 lone pair, 1 bond pair, then also it is going to give you linear shape and geometry, right? Next kind of molecule is AB3 kind of molecule, if all of them are bond pairs, okay? If all of them are the bond pairs, okay? So I'll just place 1 here so that we can easily learn this in a fast speed, otherwise things will go over your head. So this is trigonal planar geometry. If you have AB3 kind of molecule, well, all are bond pair, that is trigonal planar, right? If I say that you have 1 lone pair here, then it will be bent V shape. That is why here you have bent V shape, right? Geometry is going to remain the same. Shape is changing because with geometry we are looking for both bond pair as lone pair. If I say this is the lone pair, these two are the bond pair, then the geometry is similar. That is trigonal planar. But the shape, because we have to ignore this lone pair, so that will be bent V, right? If we say that you have 2 lone pairs, then this is going to be a linear geometry, as you can see, a linear shape, as you can see, right? Next is tetrahedral. So everybody, what is tetrahedral? This is how a tetrahedral looks like, right? So in tetrahedral, you have sp3 hybridization, right? This is how it looks like, 109 degrees you have here. If one of them is lone pair, then you'll have to ignore the lone pair. Then this is nothing but it is like a pyramid. Okay, it's like a pyramid. So it is trigonal, pyramidal, or directly pyramidal. If you take out, ma'am, one more, you have two lone pairs here. So two lone pairs, that is nothing but it is bent V shape. That is why you have bent V shape. If you have three lone pairs, take out one more bond pair, that is a linear shape. That is why this is a linear shape here. Right? Okay. Now, next is, wait a minute, next is, okay, next is this one. Okay. Next is this one. I'll just show you. Next is when you have sp3d, that is trigonal bipyramidal. What is trigonal bipyramidal? This is trigonal bipyramidal. Okay. One triangle. This is 1, 2, 3. It is forming a triangle. This is one pyramid above, one pyramid below. Right. So that is trigonal bipyramid. Right. So one thing to remember, this position and this position, this one and this one, they are axial positions. This and this one that is in the triangle, these three positions are equatorial. And whenever you have to put one lone pair, you will prefer lone equatorial position because of less repulsions. Okay, axial will have more repulsions. Okay, that is why we prefer equatorial positions here. So here you have sp3d. That is if you have 5 bonds. If one of them is lone pair, so you will have to put lone pair on the equatorial position. Either this you can choose, either this you can choose, totally your choice. I am choosing this one, right? And this is a nothing but seesaw kind of shape. Seesaw, like that thing that is there in the park, right? So that is the seesaw shape, right? Okay. Now, this is the seesaw shape, right? Then you have, let's say you have two lone pairs. Two lone pair means two equatorial position have the lone pair. This is a T shape. That is why we are written T shape here, right? If you have, let's say, three lone pairs, pick out one more. No, you have to pick out from the equatorial position only, right? So it is going to give you linear shape. So that is why here we have written linear shape. Okay, understood? Next is, if you have sp3d2, last one here, everyone, last one here, sp3d2, anybody? What is the shape? What is the shape for sp3d2? Yes, everyone, what is the shape for sp3d2? What is the shape for sp3d2? Yes, everyone, what is the shape for sp3d2? What is the shape and geometry? That is octahedral, right? The shape and geometry is octahedral, right? As you can see here, right? This is the octahedral geometry. Wait a minute. Yes, this is the octahedral geometry, right? One square, right? And one pyramid above, one pyramid below, that is having 8 phases. That is why it is called octahedral, right? Now, if you have 6 bond pair, that is octahedral. Let's say one lone pair you will have here, right? That will give you one square here and one pyramid above. That is square pyramidal shape. Now, let's say you have 2 lone pairs. So that means one more lone pair. So that means it is square planar shape you will have here. So answer will be square planar. And from here, definitely you will see 1 or 2 questions in your exam, right? That I can guarantee that you will have 1 or 2 questions in your exam based on this concept, right? One question based on this is, let's say you have, which of the following structure is most stable? Most stable structure they are asking you. 2 lone pairs and this is stable, or this is stable. That I have told you already that which one will be more stable. The one, for example, here also I'll teach you how to calculate the shapes, okay, in the question form, right? So this we know that lone pair should be on the equatorial position. So that is why this first is going to be the most stable state. So that is going to be, answer is going to be A is the correct answer. right? Okay. Now, before solving this, let me teach you one more concept here. That is, let us say if they ask you, let us say students, if they ask you to calculate, let's say any shape. Let's say they ask you to calculate the shape of XC SF6. Let's say they ask you SF4. Okay, I'm solving it for SF4 firstly, right? Okay, then I'll solve it for one double bond also, right? Okay, how to answer this? Everybody, how to answer this, right? Because this is one part was that, and one more question that can be asked here is this one, right? I can see your energy is dropping, but my energy is only that much high, right? So why it is so? I am not even leaving one single question, and this is what I like, what I get from you, right? So that is how you show us that, ma'am, you don't have to do anything for us, right? Because we always take you guys for granted, right? Isn't it? So firstly, center metal atom, you will see that is sulfur, right? Then you will see that, okay, I'll just copy paste this thing here as well, right? Okay, so sulfur, you have sulfur. Sulfur belongs to group number 16, means 6 outermost electron. 4 bonds already it is making here. So out of this, you'll have 2 electrons, means 1 lone pair you will have. That is how you will calculate the lone pairs. Then bond pair is 4, lone pair is 1, so answer will be 5. 5 means it is sp3 dehybridization. That means it is going to be, this is S, this is 1, 2, 3, 4, 5, right? Now we know that it has one lone pair. So that is why somewhere you should have the lone pair. So here I'll put the lone pair. This is F, this is F, this is F, this is F. So answer is going to be seesaw shape. That is how you will get your answer, right? Regarding the shapes, right? Let's say they have given you, let's say I am taking one example of XCOF2. Okay, let's take one example of XCOF2, right? So here, why I have taken oxygen? Because you usually get confused when you have oxygen. So oxygen forms double bond. Okay. So here xenon belongs to group number 18. That means 8 outermost electron. Two bond pairs with fluorine, 2 bond pairs with oxygen, because one oxygen will form double bond. That means total 4 electrons are occupied in bonding. That is why 4 electrons you are left with. That is why 2 lone pairs you will have in that. 2 lone pair plus how many bond pairs? 4 bond pair, that is 6. That means it is sp3d2. That means it is octahedral. So it will be Xc, right? Wait a minute. This is wrong. This is wrong. Why? Because here you don't have to calculate the bond pair. You have to calculate. You always put here sigma plus lone pair. So lone pair is 2 and the sigma is 3. So it is 5. That is sp3d2. Because we know that if I draw a rough diagram, double bond with oxygen, 1 single bond with fluorine. Right? So that means sigma bonds are 3. Total bond pairs are 4, but sigma bonds are 3. So it will be 3 plus 2, that is 5. So here it will be Xc 1, 2, 3, 4, 5. Right? So now here we know that we need 2 lone pairs. So lone pair will be on the equatorial position. And here you will have double bond. Oh, this is F, and that is how you will get your answer for XCF2. Got it, students? That is how we will solve the questions of hybridization. Next is MOT, molecular orbital theory. Right? Okay, very good. And now I can see the energies. Now MOT, molecular orbital theory, is also a very, very important concept that will definitely you will see in your exam, right? Okay. Now here what you have to see, molecular orbital theory, atomic orbitals overlap and they give you bonding molecular orbital or anti-bonding molecular orbital. Bonding you will represent by simple, anti-bonding you will represent by this star, right? Okay. Now, remember that when you calculate the number of electrons, if you have less than or equal to 14, you will use 2, 1, 2, 1. 2, 1, 2, 1 means 1, 2, 1, 2, 1. 1, 2, 1, 2 means you will have, 1, 2, 2, 1 means 1, 2, 2, 1. This is what you will use. And before this, you will have kk dash, that is 1s, 1s2, 1s star 2, 2s2, 2s star 2. So here you can write it here that kk dash is going to have 1 sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. So this has total 8 electrons, right? After these 8 electrons, you have 2, 1, 2, 1 and 1, 2, 2, 1, right? What is this 2, 1, 2, 1? 2 represents, you can say 2 represents this 2 orbitals, that is the pi 2px, pi 2py, and 1 represents this orbital sigma 2pz. Okay, 1 represents this orbital, that is sigma 2pz. Why I am telling you in a very simple way, right? So that you don't have to remember that full. After this, it will be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. Then if you talk about less than or equal to 14 electron, it will be pi 2px equals to pi 2py. Then you will have sigma 2pz. Then you will have pi 2p star equals to pi 2p y star. Then you will have sigma 2p z star. Okay. In case of this, you will have 1 means sigma, and these two are anti-bonding. These two are anti-bonding. Last two are anti-bonding. Okay. So 1 means sigma 2pz. 2 means pi 2px is equals to pi 2py. 2 means pi 2px star is equals to pi 2py star. 1 means sigma 2pz. Okay, this is what you have to remember. Right? Is this page clear to everybody or not? Are you able to understand? Right? Now we will do some simple tricks here, right, when we are doing the questions. Okay. While doing the questions only, I'll tell you the tricks. Okay. So first is, according to the molecular orbital theory, which of the following statement about the magnetic character and bond order is correct regarding O2 positive, right? So let us see that. Okay. So firstly, we have to see it for O2. So students, one thing you should remember here is that one trick is that I'll write here only. The trick I'll write where? Here I'll write the trick. Okay, here I'll write the trick. So 14 means 3. Now whenever the number of electrons are increasing, let's say 15, 16, 17, 18, or it is decreasing, let's say 13, 12, 11, 10. So what you will do here, right? What you will do here. So this is going to be 2.5 to 1.51. Again, it is 2.5. Decrease it by 0.5. 2, 1.5, then 1. Okay. Decrease by 0.5 down. Decrease by 0.5 when you're going up. Okay. So that is how you will solve the bond order. Right. Now, if you see O2. So I'll solve this here for O2 and O2 positive both. See, O2 positive, in the end I'll also tell you one trick here. O2, right? If you see O2, this total has how many electrons? 8 electrons, 8 into 2, 16 electrons, minus 1 means it has 15 electrons. Now we know that this has 15, this has 16 electrons. Now students, see one thing, 8 electrons will be there in kk star always. So 8 electrons will be taken out. That will be minus 8, 5, 6, 7, 8. That will be 7 electrons. Minus 8. That will be 8 electrons. Right? Now here you have 7 electrons that you need to fill. Here you have 8 electrons. Here, see, whenever you're talking about cation or anion, you don't have to see the total electron. You don't see the electrons. According to that, don't judge whether it's 2, 1, 2, 1 or 1, 2, 2, 1. You have to judge by the neutral species. The neutral species of O2 positive is O2, which has 16 electrons, which is greater than 14. That means in 14, what you will have here? Greater than 14, 1, 2, 2, 1. So here answer will be 1, 2, 2, 1. Okay. Here O2 is neutral only. So this is 1, 2, 2, 1. So that is why here you will fill it 7 electrons, 1, 2, 3, 4, 5, 6 and 7. Here you will fill 1, 2, 3, 4, 5, 6, 7, 8. Here you have 1 unpaired electron, here you have 2 unpaired electrons, right? So according to the molecular orbital theory, which of the following statement is true? Paramagnetic, bond order is correct regarding O2. It is definitely paramagnetic in nature, first thing. Next is its bond order. So if you see the bond order here, bond order of this is bond order is 7. You have total 15 electrons. So 15 means it is 2.5. So bond order is 2.5. Here bond order is what? Here it is 16. Bond order is 2. Right? So bond order is 2. So we can say the bond order is greater. So answer will be B is the correct answer. Bond order of O2 positive is greater. Okay, now what is the exact formula of bond order? Bond order is equals to number of bonding minus number of anti-bonding divided by 2. I have given you the trick here, but you can also solve it with this formula. Right? Okay, students? Understood or not, everybody? Now, I'm not ending this lecture here. Firstly, I'm just here to tell you one thing, that totally free of cost, in the description box, you will see free NEET study material with NEETpedia. Okay? NEETpedia, most important NEET previous year question, NEET question papers from 2022, 2024 you will have here. Let me just show you, right? Okay, in the description box here, let me just show you that, right? We are live here, right? Okay, we are live here, ma'am, right? So here in the description box, what you will see, wait a minute, NEETpedia, let me see if it is there. It should be there, right? So here it is, right? Over here you have NEETpedia, right? Click on this and you will get, you just have to fill your details here, your email or your number, right? And you will get the full access to NEETpedia here, totally free of cost it is, right? Okay, so that was just because, you know, you guys are like, ma'am, we want to run. So that's why I'm telling you in between that this is how you will get that, right? Now, we'll start with GOC. Okay, so everybody ready for GOC? Everybody in the chat box ready for GOC or not? Right? Okay. Ready for GOC? We are almost towards the end of the lecture, right? Lecture means end of the chemistry section. GOC, I'll just explain it quickly to you. So in GOC, important thing is you have to see this thing whenever they ask you BARHI, whenever they ask you stability of intermediate, you should know this thing. That is, maximum is back bonding. First, you have to see if there is any back bonding. Then you have to check aromaticity. Then you have to check resonance. Then hyperconjugation. Then inductive effect. That is why I'll just quickly recap all the things for you, all the concepts for you. Okay. So now, if you see the back bonding, if you see the inductive effect, firstly, inductive effect depends on the electron negativity, right? Okay. So this is the plus I series. Yes, you have to remember this. So plus I means the electron donation. If something is having negative charge, that will have more electron donation, right? Okay. So here, if you talk about the alkyl groups, more is the number of alkyl chains. That means 3 degree. More branched means more plus I effect it will have, right? So 3 degree, then 2 degree, then you have 1 degree. And here also, if you have the same degree, both are primary, more the number of carbon atoms, more is the plus I effect. And if you in case of isotope, first is isotopes, you have tritium, then deuterium, then you have hydrogen. Okay, understood? Right? Okay. Now, next is minus I effect. Next is minus I effect here. Let's say you have NF3. This is a full chart of minus I effect here. Right? Okay. This is the full chart of minus I effect here. That is NF3 positive, NR3 positive, NH3 positive, NO2, SO3, H, CN, CHO, COHS fluoride, then you have halogens, then all this chart is there, right? Okay. Next we have, mostly they will not ask you direct questions from these charts, right? Okay, just give me, okay, yes. So here we have, very important, some exceptions, right? So if you have to choose, let's say first thing is, ma'am, how will we choose carbocation and carbanion? So one thing you should know is that whenever you have a carbocation, right, positive, means carbocation needs someone who is donating the electron, right? That is how it will get the stability. And if you have a carbocation, negative will need someone who is negative. Negative means someone who is taking out the electron. Okay. So positive carbocation needs someone who is donating the electron. Carbanion needs someone who is taking away the electron. Right? Okay. That is how they will be more stable. So now if you see this carbocation here, right here you have Cl. You are withdrawing the electron. Here also you have fluorine which is withdrawing the electron. Two cases we have here. In this case, distance is less. In this case, distance is more. Right? Here it is not that much. It has less electron withdrawing effect as compared to fluorine. So in this case, distance will dominate. Right? If you have to choose between this, distance will dominate. That means this is closer, but this is weak, doesn't matter. But this will have more effect. It will be able to withdraw the electrons, and hence positive does not need someone who is withdrawing the electron. That is why this will be less acidic or less stable as compared to this. Right? Okay. Next is you have again this compound where you have fluorine and here you have 2Cl. Here the competition is, here you have a weak electron withdrawing group, but this is more in number. This is more in number. So here which will dominate? Multiple group will dominate. That means the number will dominate over the strength of the electron withdrawing or electron donating effect. Right? So that is why this will have more minus I effect, and hence this will be less acidic as compared to A. Right? Okay. Next question is, this we have done, weak multiple or weak group with less distance is, wait a minute, weak multiple group or weak group with less, yes, this is the conclusion part. If you have weak group but that is too many groups you have, or you have weak group but it is having less distance, so that will be more dominating, that will be more strong. Okay. Now let us talk about the resonance here, right? Next effect is resonance effect, what you have to do. So resonance is basically three kinds of resonance you have. One is double bond, single bond, and p orbital. Okay. Now this p orbital can be carbocation, this p orbital can be carbanion, this can be free radical, this can be lone pair. Right. So we will discuss all of them, how to do the resonance. Okay. So if you have double bond, single bond, and lone pair is shifted to bond pair, and bond pair is shifted to negative charge, and this is the answer that you will get. Right? If you have double bond, single bond, negative charge, in that case, negative charge to bond pair to negative charge to bond pair to negative charge, and this is the answer that you will get here. Right? Remember, the sigma electrons will not shift, right? And the overall species, this is totally negative, this also will be negative. If this was electrically neutral, normal, neutral, so this will also be negative, positive, that means it will also be neutral. Okay. Next is, if you have double bond, single bond, positive, double bond will shift here, and here you will have a double bond, and this will be positive, right? So hence, similar is in case of carbocation and free radical are similar only, right? So here it is double bond, single bond, free radical. So homolytic cleavage, this one bond will cleave, right? So this will jump here, it will form the double bond, and this electron will jump here, it will form the free radical here, right? That is how the resonating structures are, right? Now, if you have alternate double bond, second category is alternate double bond, single bond. So in this case, bond pair is converted to bond pair is converted to the next shift position, and this bond pair is converted to negative charge. Because here you have taken out the bond pair, so it will be positive. Here you are giving the bond pair, this will be negative, and overall this will be a neutral species, right? Then last one is the kind of resonance that is back bonding, that had the maximum power, right? So in back bonding, what you should remember that here you have there should be one should be electron rich, other should be electron deficient. Okay, so this is electron rich and this is electron deficient. So lone pair will jump here and you will create a double bond and this will be positive. That is back bonding, right? One is electron rich, other is electron deficient. Okay, that is back bonding, that has Barhi, back bonding major. If somewhere you will see back bonding, that will provide the maximum stability to the intermediate. Got it? If somewhere you see back bonding, that will provide maximum stability to the intermediate. Right? Now, if you see this here, stability of resonating structure, neutral is greater than charged. Always remember neutral species, right? Neutral species, see, here you have to learn this step by step. You can't say that, okay, firstly, ma'am, I want to choose, ma'am, firstly, I'll see the negative charge. No. Firstly, whenever they are asking you the stability, firstly, you have to see the whether there is any neutral species. Neutral species will be more stable as compared to any charged species. If all of them are charged, then you will say, or neutral, then you will say, more the number of pi bonds, more is the stability. If pi bonds are also same, then you will say negative charge increases, the stability of negative charge increases along the period and down the group also it increases, right? So here what you will say, that if you say oxygen and sulfur, this is more stable. If you say oxygen and fluorine, fluorine is more stable. Here because of size it is increasing, here because of electronegativity. Reason you don't need to know here. For organic, try to focus on the concepts, right? Okay. So along the period and down the group, negative charge stability increases. If that is also same, let's say in both the diagrams you have oxygen is having the negative charge, then you will see the charge separation. Charge separation and stability are inversely proportional. If there is more charge separation is less, stability is more. More charge separation, stability is less, right? Okay, let's say you have positive, negative like this, you have positive, negative like this. So this will be more stable. Less the charge separation, more is the stability. Okay, understood everybody? Okay, now let us see the resonance, what you will use in Thursday's lecture as well, right? So go through these concepts. So firstly, you should know how to draw the resonating structure. What I told you, lone pair to bond pair to negative. Lone pair, now you have negative, negative to bond pair to negative, right? Negative to bond pair to negative, negative to bond pair to negative. That is how you will get 5 resonating structures here, right? Okay. Now, here what you have seen, at ortho and para position, you have negative charge, right? So always, when you have a plus M group, what is, ma'am, plus M group? Plus M group, always remember, when on this, I'll just show you here, what is a plus M effect. What is plus M and what is minus M group, okay? Plus M group is when your ring is attached to, benzene ring is attached to that group that has lone pair of electrons. This, all of them are plus M, right? Okay. When directly the atom has lone pairs. And that atom is not doubly bonded or triply bonded attached to anything else. Here also it is single bonded, here also it is single bonded, here also single, all of them are single bonded. This atom should be in the sp3 hybridization, it should be single bonded, okay? Next is, if benzene ring, if you say benzene ring is attached to a group that is doubly or triply bonded attached to a more electronegative element, then it is showing minus M effect. Like all these are the cases of minus I effect. Okay? Understood? Now, here what you will see, that all the groups that are showing plus M effect, plus M, okay, lone pairs, whatever group is showing plus M effect, that will show. Ortho para will be negative. That means if there is some electrophile, that is electron loving, that will attack on the ortho and para position. So always plus M group is more activating towards ortho-para directing. Okay, so like phenols, then you have anilines, all these are ortho-para directing, that is the reason. Okay, haloarenes are also ortho-para directing. All groups which show plus M are ortho-para directing, right? Then minus M groups, like you have an atom that is attached to more doubly bonded attached to more electronegative elements, so that is minus M. And in minus M you will see you have positive on the ortho-para directing. That means more electron density is on the meta position. That means electrophile will attack on the meta position here. Right, that is the reason electron density is at the meta position, meta directing. Right, so that's why you will see meta directing, that is the electrophile. Okay, now important point here, we have seen that all groups showing minus I are meta directing towards the electrophile. Right, this also we have seen. Now the important point here is, very important point, the groups that are activating. See, plus M is donating the electron, so it is always going to be activating groups, or plus M are activating groups. Minus I, which are taking, minus M, which are taking the electrons from the benzene ring, they are deactivating groups. Okay, we all know that. But this is the exceptional part. I'll just write the exceptional part here. Exception is halogens. Halogens, which shows both minus I and plus M effect. But usually mesomeric is more dominating. In all the cases, mesomeric is more dominating. But in case of halogens, inductive is more dominating. So because it is showing plus M effect, that is why it is ortho-para directing. Ortho-para directing. But because here inductive is more dominating, that is a minus effect, that is why it is deactivating group. That is the exception, and from where the questions are asked. That is why phenol and chlorobenzene both are ortho-para directing. But you will see that phenol is more having fast rate of reaction because it is activating group. Right, so more electron density is this provided. Right, resonance also we have done. Next is aromaticity. From aromaticity, directly they will ask you the question. Okay, from aromaticity, direct questions are asked. So if they say PCC is planar, conjugation and cyclic. Okay, if PCC is followed, then if it is 2n plus 4n plus 2 pi electron, it is aromatic. If it is 4n pi electrons, it is anti-aromatic. If PCC is not followed, let's say it is not cyclic or it is not planar, usually they will, the question will be of planarity. Okay, if it is not planar or it is not conjugated, then it will be non-aromatic. Stability is aromatic, then non-aromatic, then anti-aromatic is the least stable compound in this universe. Right, least stable compound, nobody wants to be anti-aromatic anywhere. Right, whenever you see in any reaction there is formation of anti-aromatic compounds, that reaction will not happen. Right, next is anilines. So anilines, how many of you remember anilines? Anilines is a very, very important thing here, right? But for that, what you should remember, students, everybody see that in the chat box, in the comment, on the screen. Aniline are monocyclic. There is only one cycle which has alternate double single bond. Like benzene is also a aniline, monocyclic, alternate single double bonds. Number of carbon atoms are 1, 2, 3, 4, 5, 6. So it is 6 anilines. So number of carbon atom will tell you how many anilines you have. The number of carbon atoms and the number of pi electrons will be same. For example, in benzene you have 6 pi electrons and 6 carbon atoms. So number of electrons and number of carbon atoms are same in case of anilines. Okay, that is a one important thing. Now, ma'am, how will we answer anilines? Very simple chart there is for you. Very simple chart we have. That is, I am telling you what are planars. 4, 6, 14, 16, 18, all are planar. Non-planar because these are the exceptions. 8 is non-planar, 10 is non-planar, 12 is non-planar. 8 is non-planar because it has stub-like structure. 10 and 12 is non-planar because of hydrogen-hydrogen repulsion set. Right? Okay. Now, that is why these are non-aromatic. Rest of it depends. 4 is belonging to Rest of it will depend on what electron category it is falling into. Let's say 6 is falling into 4n plus 2 pi, that is why it is aromatic. 4 is falling into 4n pi, that is why it is anti-aromatic. So according to that, you will decide whether they are aromatic or anti-aromatic. Okay, understood students, right? Okay. Yes, everybody. Now, let us do some questions based on that. First is, one more part based on this, not based on this. I think that, no, I have not done that. Hyperconjugation. Okay, one more part is hyperconjugation. How many of you remember hyperconjugation? So I'll directly tell you one simple concept of hyperconjugation. Okay, one simple concept of hyperconjugation. What you will see in the hyperconjugation. Anybody in the chat box? Hyperconjugation. Anybody in the chat box? What is hyperconjugation? Right? Hyperconjugation, directly what you will say? Hyperconjugation. Right? Directly what you will say? For hyperconjugation. Very simple part is, for hyperconjugation students, it depends on the number of alpha hydrogens. More the number of alpha hydrogens, more is the hyperconjugating structures. More is the stability. More is the stability. Okay. So, condition is it should have at least one alpha carbon, which is sp3 hybridized, and it should have one alpha hydrogen as well. Only then hyperconjugation is possible. Right? Okay? Understood? Yes. Very good. Now let us see some questions. Compare the stability of following carbocation. So if you see cyclic, you can see here, right? So definitely we can see the aromaticity here. No, here there is no complete conjugation, so this is non-aromatic, right? 1, 2, 3, 4, 4 pi electrons, so it is anti-aromatic. There is planarity, complete conjugation. You have double bond positive, double bond, single bond positive, single bond, double bond, single bond, double bond, right? Here you have these lone pairs and these lone pairs. Now, important parts to, very important part. In calculating the pi electrons, you will only calculate those pi electrons that are involved in the delocalization. So these are involved in delocalization, right? That is why only these are involved. These two lone pair are involved in the hybridization, so they will not be involved. Right? So 1, 2, 3, 4, 5, 6 pi electrons. That means it is aromatic in nature. So answer will be first is third is maximum stable. Then you have first, then you have second, because second is anti-aromatic, that will be least stable. So answer will be C is the correct answer, right? Okay. The correct stability order of carbocation, as I told you, carbocation is their favorite, stability. Whenever stability is there, you have to check for these things. Barhi. Can you see anywhere back bonding? No, ma'am. Can you see aromaticity? No, ma'am. Can you see resonance? No, ma'am. Can you see hyperconjugation? Yes, ma'am. I can see, ma'am. Hyperconjugation? Yes. This is tertiary carbon. You have CH3, CH3, CH3. Here you have 3. That is why one of the questions that was asked in your NEET exam was, the stability order is this due to inductive effect, hyperconjugation effect. Most of the students marked it inductive. Answer was hyperconjugation. Because this is the order. If hyperconjugation applicable, then answer will be according to hyperconjugation, not inductive. Though both are giving the same answer, but we will say we are giving the answer according to hyperconjugation, not according to inductive. Right? So this is having 3, 4, 5, 6, 7, 8, 9, 9 alpha. So this is the maximum. This is having 3. This is basically, this is 1, 2, 3. Wait a minute. This is C, 1, 2, 3. 1, 2, 3. And this is CH. This is positive here. Right? So that is giving you 3, 4, 5, 6 alpha hydrogen. This is 9 alpha hydrogen. This is 3 alpha hydrogen. This is 0 alpha hydrogen. So that is why C is going to be the correct answer. Very good. Right? Next is the correct sequence of acidic strength. Now, whenever they ask you the acidic strength, take out H from there and see the stability of the carbon ion that was there. So here, this is the carbon ion, this is the carbon ion, this is the carbon ion that you have, and this is the carbon ion that you have, right? As you can see, for the stability of carbon ion, again check BARH. Back bonding, I can't see anywhere, right? Okay. Aromaticity, I can't see anywhere. You say, ma'am, why are you wasting your time here? So that you can always use this way of dealing with the questions. If you don't use this way, chances are somewhere you will do some silly mistake. That's why I'm again and again writing this. Resonance, I can't see. Hyperconjugation, in carbon ion, hyperconjugation is not valid, right? Okay, so that is why this is also not there. Inductive, we will see, right? So this is having CH3, CH2, this is CH3, CHA, CH2, CH2, this is only H. We know that more the donation, if something is negative, right, you have to take the electrons to make it stable. So here you are donating, this has a maximum plus I effect. This has less. Maximum plus I means this is going to make it least stable, right? So that is why this will be least acidic in nature. That is why this is least acidic in nature. I think answer should be C. Least acidic. Then because here the plus I order is less than that, so it will be more acidic as compared to this. Plus I effect is less as compared to these two. So acidic character will be more because it is taking the electron but not with that much efficiency. This is HCOH which does not have any plus I effect. That is why this is going to have maximum acidity among them. So answer will be C is the correct answer. Is that clear to everybody or not? Right? Okay. Yes, students, C is the correct answer. Very good. Now, let us start doing the structural isomerism part. Okay. Let us quickly do isomerism part, students. Quickly do isomerism part. Right. Some things I'll teach you, some concept I'll teach you with the help of questions. Some concept I'll teach you directly. So here you have 1, 2, 3, 4, 5 kind of isomerisms here. This I'll teach you in detail. Right. Okay. Chain isomerism, you have to check the parent chain. If the parent chain is different and the molecular formula is same, that means it is chain isomerism. Position means functional group position is different. Functional group is same, but the position is different. In that case, we will say it is position isomer. And always remember, then functional group isomerism is when functional group has changed. That is functional group isomerism. Right? Always remember 1 degree, 2 degree, 3 degree are different. 1 degree, 2 degree, 3 degree amines are different functional group. Okay, so that is why they will possess functional isomerism. Ring chain means you will have a ring and you will have alkene. Okay, when they both have same molecular formula, that is the ring chain isomerism. Metamer means when you have, let's say you have some bridge over here, and here you have R, here you have R dash, right? And here you have also one more compound where you have R double dash, this is R triple dash. If this R and this R dash is different, R dash and this R triple dash is different, then that is called metamer. That means the alkyl chains around that bridging functional group is different, then we can say that is metamer. Tautomerism, we will do that in detail, right? Okay, so let us see what is tautomerism. Right? Tautomerism means what you will have, let's say you have the conversion of this is enol form, double bond OH. So what you will do here, first thing is 1-3 shift. That means this is first position, this is second, this is third. So from third position, you will shift the hydrogen to first position, right? And from 1 and 2 position, you will shift the double bond to 2 and 3 position. That is your keto-enol tautomerism. Right? But sometimes what happens, we have 1-5 shift as well. What is 1-5 shift? See, if your third carbon, if I am saying your third carbon, students, if I am saying your third carbon is sp3 hybridized, you will check whether, one more thing is, what is the condition of tautomerism? Condition is, you should have alpha carbon, that is sp3 hybridized, and you should have at least one alpha hydrogen. These are the two conditions of tautomerism, because sometimes they directly ask you which of the following shows tautomerism. So directly from these two conditions you can tell which of the following shows tautomerism or not, right? Okay, yes. Now if your third carbon is sp3, you will say alpha hydrogen is present or no. Alpha hydrogen is present, then tautomerism exists. If alpha hydrogen is not present, then tautomerism does not exist. Right? Simple. But if your third carbon is sp2 hybridized, then you will not stop there. You will see that whether the fifth carbon is sp3. Whether the fifth carbon is sp3, and if it also has alpha hydrogen, then you will say tautomerism exists. If the fifth carbon is sp3, it does not have alpha hydrogen, then it will not exist. If the fifth carbon is sp2, it will not exist. That means two cases you will have where tautomerism will exist. First is third carbon is sp3 hybridized and it has alpha hydrogen. Other is third carbon is sp2 and fifth carbon is sp3 hybridized and it has alpha hydrogen. Then you can say tautomerism exists in these two cases, right? Okay, understood? Understood, everybody? Now, geometrical isomerism I'll teach you with the help of questions only, right? Optically active and inactive. Firstly, rather than this, let's go and check the question part here, this part, okay? Because we have just done this, right? So, which of the following compound will not undergo tautomerism? That means you have to check the alpha carbon here, right? This will undergo tautomerism. How? This will be hydrogen is shifted here. This is double bond O. This is what you will have. Hydrogen is shifted here, double bond is shifted here, right? This is the alpha carbon, this is the alpha carbon. It has one hydrogen. So they will also show tautomerism. This is the alpha carbon, this is the alpha carbon. This has one hydrogen, this has two hydrogen. So both of them will show tautomerism again. This is the alpha carbon, this is the alpha carbon. Both of them are sp3, but it does not have sp. Both are sp3, but it does not have any alpha hydrogen. So this will not show tautomerism. So answer will be which will not show. This is the correct answer. That is D is the correct answer. Okay, understood? Now let us do the questions of geometrical isomerism. Now students, one very important thing here, right, to note down. I'll just I don't have any blank page, so I have to again draw it black, right, because I don't want to spoil your PPT here. Okay, can you tell me what is the condition of geometrical isomer? Anybody? What is the condition? If a double bond I say it shows geometrical isomerism, what is the condition? Let me see if you guys remember this or not. What is the condition of geometrical isomerism, right? Okay, so the condition of geometrical isomerism is that C double bond C, this is 1, this is 2, this is 3, this is 4. Okay, so what is the condition of geometrical isomerism, everybody? 1 should not be equals to 2 and 3 should not be equals to 4. Only then it will show the geometrical isomerism, otherwise it will not show, right? Now, if I am saying C double bond C, it is showing geometrical isomerism. If same group, let's say A and A, same group are present on the side by side, then that is called cis. If same group is present on the opposite position, that is called trans. That is the first kind of isomerism. That is very, very simple. That is cis and trans, right? Okay, very good. It should have restricted rotation. Very good journey, right? Now, other kind of question that is based on the E and Z, right? So let us try to answer how you will identify E and Z. See, E and Z, if I give you direct formula that this is E, then you won't be able to understand that. That's why I picked the question for E and Z isomer, right? So E and Z isomer, just remember one thing here. E isomer among the following, right? So If on the double bond all the groups are different, then you will see E and Z. And E and Z isomer is according to CIP rule, that is Karl, Ingold and Prelog, right? So now here what you will see that here the E isomer among the following is, right? So here this is carbon, on same side this is Br. This says that more the atomic number, more is the priority. So this has more atomic number, so this has the first priority. This is carbon, this has the second priority. This is chlorine, more atomic number, this has less atomic number, second priority. So that is why 1, 1 means whenever you have E means enemy. Enemy is opposite. E does not mean enemy here. I am just telling you like how to remember. E for enemy, enemy is always opposite. But here it is on the same side. So Z is on the same side. So this will be Z. Okay. So here what you will see, rather than writing it as CHO, I will rather write it as, right? How I will write it? This will be C, double bond O, this is H. This will be C, C2H3, no? So this will be H, this will be H. Right? Now what you will see here, this is also carbon, this is also carbon. So you can't identify which is more priority because both are carbon. So this will be cancelled. Next step is it has one hydrogen. It has one hydrogen, one carbon. It has two oxygens. Double bond O means two oxygen. It has two oxygen and one hydrogen. Hydrogen will be cancelled. Right? Here you have two oxygens. Okay, what you have here is two oxygens. Okay, what you have here is, ma'am, I have two oxygens here. Right? So definitely here you are left with one hydrogen and one carbon. Here you are left with two oxygen. Oxygen has more priority, right? So definitely this will have more priority. So directly I'll write this is 1, this is 2. Here chlorine and carbon, this has more priority 1 and 2. I can see this is opposite. So answer will be B is showing you E, right? So answer will be B is the correct answer. If you want to solve this also, carbon has more priority, then this is the second priority. Whenever you have C double bond, so you can say carbon is attached to one hydrogen. Double bond C means two carbon. Here it is attached to three hydrogens. Carbon will cancel, hydrogen will cancel. Here left with two carbons, two hydrogen. Definitely carbon has more priority. That is why this is 1, this is 2. Ma'am, I find this difficult. Directly you can say that double bond has more priority. First priority is triple bond, then double bond, then single bond. Right? So this is 1, this is 2. Right? Sometimes, why I told you this method as well, because sometimes this thing does not work. So you have to know this method as well. So this is same side, that is Z. Here also, this is first priority, this is second priority. This is carbon, carbon. Both are same. These are not even GI. Not even GI, because both the groups are same, so they are not only geometrical isomers, right? So answer will be B is your E, right? Anybody, any problem here? Are you able to calculate E and Z here, right? Now, next is they are saying which is the metamer of the compound. So this is the compound that is given to you. They are asking you the metamer here, right? Metamer, everybody, if they are asking you the metamer here, what you have to do here is, this is oxygen, that is the bridging, this is one alkyl, this is other alkyl, right? Here you can see which of the compounds is the contour of this. Okay, that means the alkyl part should be different here. Both the alkyl parts should be different. That is in this case. Here it is benzene CH3. Here methyl and methyl are same. So it is not possible. Right? Here it is CH3, CH2, CH3 and this is benzyl. So both the chains are different. Both the alkyl or aryl chains after this bridging compound, bridging functional group is different. So answer will be D is the metamer. Okay? D is going to be the metamer. Now let us see the optical isomers, everyone. Let us see the optical isomers. Here we had optical isomers. So let us see this quickly, how to answer optical isomers directly with the help of one simple trick, that is AAC. If they ask you optically active out of the following, which is optically active isomer, what you have to see? Optically active will be the one which is asymmetrical and which has chiral center. Chiral center means it should be sp3. Chiral center means it should be sp3 and it should have at least all the 4 groups should be different. That is the chiral center, right? If it has chiral center and it is asymmetrical, that means there is no plane of symmetry, center of symmetry, then we can say it is optically active. Otherwise, it will be, if any of the conditions is followed, then it will be optically inactive, right? Okay. So directly also we can say optically active compound have non-superimposable mirror image. Okay. Next is, if they talk about, let's say, if they talk about when you have all the double bonds next to each other, right? Okay, that is allenes, or you have spiro compounds, or you have biphenyl. Any of this is given to you, what you will say? If you have even number of carbon atoms, then it will be, and you have, let's say you have odd number, then that is going to be inactive. If you have even number, then if you have same group on different carbon, then it is optically active. If you have same group on same carbon, same group on different carbons, same group on different carbons. Okay, wait a minute. It should not be like this. It should be like this. Let me just rewrite it for you, right? How it should be. It should be different group on same carbon, same group on same carbon. Then it is optically inactive. Okay, so you have to find the even number which is having the different group on the same carbon, then only it will be optically active in nature, right? Okay, understood? Now, next is how to calculate the number of GI, all of these cases. So directly how you will answer that. See, I'll tell you one simple thing. If you're thinking that, ma'am, these are very, very difficult, trust me on that, they will not ask you this, right? Here I have written for those students who don't want to take any risk, who feel that, okay, even if difficult question they ask, we will answer. We have a aim of getting 710 plus 700 plus we want to get, right? We want to get 180 out of 180 in chemistry. Then you have to do these questions also, these formulas also. You can't take any risk. But if you want to play safe, right, then just remember 2 raised to power n. Because most probably 99.999% they will ask, if they ask you a question based on calculations, they will give you a symmetrical molecule, most of the cases, right? But if they are in the revenge mode, they can also ask you this. So this is nothing but the game of, if you have symmetrical, this is 2 raised to power n minus 1, 2 raised to power p minus 1, n is n, p is equals to n by 2, p is equals to n plus 1 by 2, totally formula based. What is understanding based? Ma'am, what is the value of n? So whenever you are calculating geometrical isomer, n is the number of double bonds showing GI. Number of double bond that are showing the geometrical isomer, that is n. Optical isomer, again, if you talk about unsymmetrical, the answer will be 2 raised to power n. Other things it may differ. So I'll talk about only symmetrical. For symmetrical, it is just a game of formulas, right? So what is n? N is the number of chiral centers. That will tell you the optical isomer. And if you want to calculate the stereoisomers here, stereoisomer will be again 2 raised to power n, where n is the number of chiral centers plus the number of double bonds showing geometrical isomer. Okay, so I'll just calculate this for you. Like, let us do one question based on this. There is one question. After that, we'll do confirmers, right? There is one question based on the calculations. Okay, how they can ask you. right? Here, so they have not given us any option, right? I'm just telling you how they will ask you, what kind of question they can ask you. So this is the question, as you can see here, right? As you can see here, you have to tell me, there is no, even if let's say not optical, they are asking you stereo, right? So n is equals to number of geometrical centers, geometrical isomerism site. There is no double bond. That means there is no geometrical isomerism site. And double bond also should be that double bond which is having 1 and 2, 3 and 4, where 1 and 2 is different, 3 and 4 is different. Only that double bond will be calculated, right? Okay. So n is equals to 0, that is number of double bond is 0, that are showing geometrical isomerism. Chiral center is, this is the chiral center, this is the chiral center, this is also the chiral center, this is also the chiral center, this is also the chiral center, right? So 1, 2, 3, 4, 5 chiral centers you have. How I identified the chiral centers? Group different, this is whole different, this is different, and this hydrogen is also, this is not even hydrogen, this group is also different. Here you have, this whole group is different, this whole group is different, this group is different, and one hydrogen is different. In this case, all the 3 groups are different, one hydrogen is different. All the 3 groups are different, one hydrogen is different. All the 3 groups are different, one hydrogen is different. That is why number of chiral carbons are 5. So answer will be 5. It is asymmetrical. It is 2 raised to power n, 2 raised to power 5. And that is going to be your answer here. Right? So calculations, usually students skip calculations, but that is not a very difficult part. Okay? Very simple questions are asked based on the calculations. Okay? Now we will do confirmation. Okay? Right? Yes, everybody, let us do that. If you see conformers, right? So conformers, direct thing is, if you talk about the conformers of ethane, right? There are 2 things. The angle, dihedral angle is changing. If you see, they are overlapping each other, that is called eclipsed. If you see, they have an angle of 60 degrees, that is called staggered. Because here you have less repulsion, here you have more repulsion, that is why staggered is more stable as compared to eclipsed. Okay, that is why staggered is more stable as compared to eclipsed. Now we will see propane, right? In propane also we have CH3 here, CH3 here. Now if they are overlapping each other, that is called eclipsed. If they have an angle of 60, that is called staggered. Again, staggered is more stable as compared to eclipsed, right? Here in the eclipsed conformation of propanone, will be even more unstable. Why? What is the reason? Because here the repulsions are between methyl and hydrogen, which are more than repulsions between hydrogen and hydrogen. Then very important part is conformers of butane. See, if angle of methyl is 0, it is this. Now you don't have to look for the names here. Just see what we are doing. Angle is 60, then this diagram, angle is 60 plus 60, 120. Angle is 60 plus 60 plus 60, that is 180. Right? If methyl and methyl, if they are overlapping, and here also overlapping is there, both are eclipsed. Because here the same group is overlapping, that is called fully eclipsed. Here 2 different groups are overlapping. Here CH3 is overlapping with hydrogen, CH3 is overlapping with hydrogen, that is partially eclipsed. Okay. When CH3 are at 60 degree, that is gauche. And when CH3 are opposite position, that is called anti-conformer. Okay. Generally, the stability order is anti, gauche, partially eclipsed, then you have fully eclipsed. Very, very important. Very, very important. Right. Now we have gauche effect. This is what is the question that they will ask if they want to ask something very interesting. Right. So gauche effect. Gauche effect is simple. You have ethane here, right? This is CH3. Instead of HH, you have OH. So instead of HH, you have OH. So we will have 2 positions here. Either one can be anti, one can be gauche. This is gauche, this is anti. Because in gauche, usually anti is more stable. But here in gauche, you have hydrogen bonding in this case. You have hydrogen bonding, that is why gauche will become more stable, and that is called gauche effect. When because of hydrogen bonding gauche become more stable, right? Okay, then that is gauche effect, that is called that is when gauche become more stable in case of hydrogen bonding, that is called gauche effect, right? Now let us see in cyclohexane, right? We have 4 conformers. One is chair. It's like a chair when you sit on a chair. This is like 2 kites, right? Basically, it is twisted boat. This is a boat structure, and this is the sofa kind of structure, that is half chair, right? This is fully chair, full chair. Chair is like this, na? Chair is like this. This is how chair is. How is sofa? Sofa is like this, right? How is sofa? Or bed? Bed is like this. Okay, let's take it as this is bed. Okay, half chair. That does not look like bed. That does not look like chair, right? So stability order is CTBH. CTBH. That is chair. Then you have twisted boat. Then you have half chair. That is CTBH is the stability order here. Right, everybody? Okay. Now let us do one question based on this. That is, in which of the following molecules gauche form is more stable than their anti-form? Gauche form is more stable than their anti-form. So answer is going to be C. I'll just show you directly here, because in all the cases you have hydrogen bonding. If you see, the first is also you have hydrogen bonding. Here also you have hydrogen bonding. Here also you have hydrogen bonding. That is why in all the cases gauche effect is going to be more stable. So answer will be all of them. You can make the structure and then you yourself will see that all of them has the hydrogen bonding, right? Okay. Then the next concept is based on purification, qualitative, quantitative analysis. So directly let's do this. So guys, this is a table, right, that I have prepared, that I have specially made for you guys for the recap. Carbon, how do we, basically this is a question based on like how you identify these compounds. Carbon plus CO, it will give you CO2. For hydrogen, it will give you water. For nitrogen, you will have NaCN, which further, see, this is the first compound that you will have, and this is the detection compound that you will have. Detection means which will give you some color or some smell, which will help you identify which is the compound that you have. So directly for carbon, you have CaCO3. For hydrogen, you have elimination of like anhydrous CuSO4 is converted to hydrous, hydrated CuSO4. So blue color is obtained here, right? With nitrogen, you have NaCN, which is further converted to Prussian blue. That is why you have the identification of nitrogen. For sulfur, you have 2 ways. Firstly, you make this is basically a Lissagany's test, okay, where you make this fusion tube, okay, fusion tube you make that with sodium fusion tube you make, that is Na2S. With the Pb, it is going to give you PbS. Then this thing, if you react this with Na2FeCN5NO, this will give you violet color of this compound, where this is Na2 is converted to Na4 and NO is converted to NOS. From here also, very important questions are asked. Okay, this I'll do in practical chemistry as well. Don't worry. This I'll rather than skip this and we'll do this in practical chemistry. Okay, so I'll write it practical chemistry, because I am going to take this lecture on Friday. So there is no way in rushing this thing, because this thing will be, you can only understand this thing if you have like full knowledge of this practical chemistry as well, right? But yes, we can brush up our concepts here, right? Now here, if N and S you have, then you will have the formation of FeCN3, that is blood red precipitates. With halogen, you react this with AgNO3, you have the formation of AgCl, AgBr and AgI. This is white, this is pale yellow, this is dark yellow in color. With phosphorus, you have the formation of Na4 thrice PO4.12 MoO3, that is yellow in color. So all these compounds, this is the direct chart, right? If you have ever gone through these reactions, then you will be easily able to understand what I am telling you. If you have never gone through these things, then you will definitely find this stuff. But for that, I am taking up one lecture of practical chemistry this Friday or Saturday. I'll take up. For that, I'll clarify this thing there. Right now, why I have told you this thing here? Because of this question that they are asking again and again. NTA is asking this question in all the shifts of JE. That means they will definitely high chances that they will ask the same kind of question in your NEET exam, right? So, general formula I have prepared for you. Percentage of element is molar mass of element in detection compound multiplied by mass of compound multiplied by 100 divided by molar mass of detection compound multiplied by mass of organic compound taken, right? So, how you will use this formula? Let's say you have percentage of element. This is the general formula that I have given you. Let's say for halogen, molar mass of element in the detection compound, that is molar mass of halogen. This is molar mass of detection compound, that is mass of detection compound that is given in the question, right? Here it is molar mass of detection compound, that is 108, because the detection compound is nothing but it is AgX. This is the detection compound, right? So this will be 108 plus molar mass of X, right? W is the mass of organic compound. Now I'll tell you how they will ask you. Let's say percentage of chlorine. Chlorine is 35.5. So this you will add 35.5 and this is the formula that you will get. For bromine, you will add 80 here and this is the formula that you will get. For iodine, you will add 127 and this is the formula that you will get. It's totally your choice if you want to remember these all formulas or you directly want to remember just this one thing and the molar masses here, right? I would suggest you this thing because this will help you, to learn the formulas, right? Because otherwise, so there are too many formulas. For percentage of sulfur, this question also they have asked in JEE, this attempt only, right? So that also makes it very important. So molar mass of sulfur is 32. Molar mass of BaSO4 is 233 multiplied by mass of the sulfur is will be given to you in the question, and mass of organic compound is also given to you in the question only, right? That's how you will solve the mass of sulfur, right? Next is for phosphorus, this is the detection compound, that is directly I'll just use the detection compound. Percentage of phosphorus is 62 by 222 multiplied by mass of organic compound multiplied by 100. That is the percentage of phosphorus. If you have to check Dumas method, now Dumas method is extremely important for you, right? Dumas method, estimation of nitrogen. So this is the compound plus CuO, N2 plus O2, H2O and this. Now, how do you solve this? Directly I am giving you two steps here. I am also going to solve one question based on Dumas method, okay? So, first you will calculate the mass of nitrogen. Okay, you will calculate the mass of nitrogen here. How you will calculate the mass of nitrogen? That is going to be V2 in milliliter divided by 224 multiplied by 28. That is how you will calculate the mass of nitrogen, right? Okay. Then you will put the mass of nitrogen here, right? And then that is the answer that you will get, right? Okay. Percentage of nitrogen is V2 in milliliter by 22400 multiplied by 28 by W multiplied by 100. That is the answer that you will get here, right? Okay, so I'll just tell you how to solve this with the help of one formula. Jildal method is very simple. Percentage is equals to 1.4 divided by weight of the organic compound multiplied by normality, and this is the volume. Jildal method, they have like not that much interest they have in Jildal method. More interest is towards Dumas method, from where direct question they are asking you, right? Wait a minute. Wait a minute. I think Baswas sir is waiting for our class. Let me just see. I was about to text him only, right? Baswas sir, I just need. Wait a minute. Yes. So, students, I know all my students. Yes, sir is like interacting with you in between. Right, sir, I just need 10 minutes from you now. Right, I'll be done with the chemistry part. Right. So, in Dumas method, the estimation of nitrogen, this much of organic compound, that means W is given to you, gave this much of nitrogen collected at 300 Kelvin temperature. Then you have 715 is the pressure. The percentage composition of nitrogen in the compound would be. See, firstly, what you have to see is PV is equals to nRT, right? So from here, what we will do, we will calculate the number of moles, that is PV divided by RT, right? So how you will use the number of moles? I'll just giving you how to solve this, okay? Directly from this formula, you won't be able to understand. Number of moles of N2. Number of moles of N2 is going to be pressure. First, you have to see the pressure of N2. That is given to you. The pressure is given to you. That is 715. So, you will have to subtract aqueous tension from the pressure. Then divide this by the atmospheric pressure, that is 760. That is going to be the pressure. Now, this pressure is in atmosphere, right? Now you will use PV is equals to nRT, where number of moles of N2 will be equals to this pressure of N2 plus this volume of N2 that is given to you. This is volume of N2 that is given to you, right? I'll just write volume of N2 that is given to you, right? PV divided by PN2, this is V divided by RT. Temperature is given to you, R you already know, right? From here, if you solve the mass of N2 here, mass of N2 is going to be, molar mass of N2, that is 28 multiplied by number of moles of N2. Once you calculate the mass of N2, what you have to do, mass of N2, percentage of nitrogen will be mass of N2 divided by mass of organic compound multiplied by 100. And that is how you will solve this question here. Okay, that is how you are going to solve this question here. Okay, students. So this method you don't need to apply. The method that I told you, solve it by that thing only. That will make it very, very easy for you. And this is a very, very high chances that they will ask you this question in the exam. Right? Okay. So last part of this lecture, that is hydrocarbon. Okay, so let's finish this off. First thing is, I'll tell you the important name reactions here. First is Sabatius-Anderson reaction, where you have double bond and triple bond. With the help of hydrogenation in the presence of a catalyst, you have converted into alkenes, right? Okay. Then there is Reed's reaction, in which you have hydrocarbon. You add sulfuryl chloride, that is SO2Cl2. Then you have the formation of RCl, right? That means you have the formation of CH3Cl here, right? Rest is SO2 and HCl will be vaporized. This is the Reed's reaction, in which you don't use thionyl. This is sulfuryl. This is sulfuryl, not thionyl chloride. This is sulfuryl chloride. Thionyl chloride is there in Darson reaction, where here you have ROH. Okay, so here it is Reed's reaction. Next is you have Wood's reaction. In Wood's reaction, what you have is you have sodium and halogen that will be eliminated, and you will have the double the number of alkane you will get, right? But you will not get any unsymmetrical alkane from here. That is the demerit of this reaction, and it is a free radical mechanism, right? Okay, so rate will depend on the free radical. Wood's fatigue reaction is when you take out halogen and sodium and you have benzene and R over there. But fatigue reaction is when both the halides are aryl halides and you have the formation of biphenyl or diphenyl. That is called fatigue reaction. Next is soda-lime decarboxylation. Important part is in soda-lime decarboxylation, you have the formation of RH from RCOONA, and this intermediate here is carbanion. That is why the dependency of the rate of reaction is on the carbanion, right? Okay. But if you talk about Cole's electrolysis, that is also the same kind of reaction. But here you have RCONA is converted to RR. Okay. In this process, it was converted to RH. Here it is converted to RR. right? So at anode, what you have, this is a free radical mechanism. So this will be dependent upon the free radical here, right? Okay, so you'll have the formation of free radical. One important thing to remember here is, if you have, let's say, ma'am, can I form alkene from here? Yes. Because here, what we have learned is, these two things will be eliminated and this bond will join, right? So that is why you will have double bond. These two things will be eliminated and there will be one bond here. That is why you will have the formation of triple bond here, right? Okay, now one question that they can ask you is, let's say you have something like this. Okay, this is halogen, this is halogen. This is the Woods reaction. I'll tell you two questions here. If you form the free radical, you will have to form the free radical like this and this, right? Then what will happen? This will give rise to intramolecular formation and there will be a double bond here, right? Let's say you have something like this. Let's say you have something like this. You have a double bond here. You have one X and one X here, right? I'm talking about Woods reaction. Woods reaction follows free radical. So you will have to eliminate this halogen here, and here you will have one free radical, one free radical. Again, it will give rise to one double bond here, right? That means, ma'am, this compound should be formed, but I am saying no. This compound will not be formed. Usually it prefers intramolecular, but if you have the formation of anti-aromatic compound, it will not prefer. Rather, you will have two free radicals that will join together to give you this compound, which should not be anti-aromatic. Okay, that is the case, that it should not be anti-aromatic. Okay, next is what? Ma'am, this Cole's electrolysis is also same kind. So instead of halogen, you have COONA. Same thing. Same thing. Instead of halogen, you have CONA. Same thing. Here also you will have the formation of free radical, right? And if you have the formation of this, once you have reached this condition, Woods and Cole's electrolysis are the same only, right? So here you will have halogen in case of in case of Woods, and in case of Cole's electrolysis, you will have COONA. Always remember, when you have formation of inter and intra, it will prefer intra over inter, but no anti-aromatic compound. No anti-aromatic compound should be there, right? Next is Birch and Lindlar's catalyst. Birch reduction, both you have the formation of alkene from alkyne. But in case of Birch reduction, you have trans-alkene. In case of Lindlar's catalyst, you have cis-alkene. Here you have PDBSO4, that is the poison. Here you have sodium lithium in case of liquid ammonia. Right? Then hydration of alkenes, you have three processes. Acidic hydration, you will firstly make carbocation, then rearrange it, then attach OH. Okay, this we will do. We will not do this here. Rather, we will do this in alcohols. Okay, that is not this part. Okay. Then last one is Frank-Land reaction. Right? Frank-Land reaction is just like Woods reaction. Instead of sodium, you have zinc here. You have the formation of RR. Corey-House synthesis. Here, instead of sodium, you are using Gilman's reagent, that is R2CuLi. But in this also you have the formation of alkanes. But in Corey-House synthesis, you can form symmetric. You can also form unsymmetrical alkanes. Okay, that is the important part about Corey-House synthesis. But from these two naming reactions, not many reactions they ask. Usually, they ask on different concepts that I'll show you here. Right? So let us quickly do 5-6 questions here. Everybody, in the given reaction, identify A and B. So as you can see here, this is the Birch reduction. So definitely A and B, they are asking you identify where is A. Where is A? Okay, this is A, right? So in the given reaction, identify A and B. B is, we know that in Birch reduction, you have the formation of trans. And in this case, you will have the alkyne only, because here you have the formation of cis. So here also you will have the alkyne. Okay. So this is Lindlar's catalyst. So this will be pentyne, right? And here you will have the formation of trans. So answer will be A is the correct answer. Next is the final product A formed in the following reaction sequence. So let us directly see what is the reaction sequence here and what is the product that will be formed here. Array, this is also not, I'll just directly show you some questions here, right? Because this is not the question that I wanted to teach you, not even this one, right? Wait a minute. So I'll directly show you what is the kind of question that is important for us, right? Okay, let us see this. The product C in the above mentioned reaction. All these are from haloalkanes, haloarenes, okay? So basically these are mixed questions, okay? So let me just show you here three important things, okay? Three important things. First is ozonolysis. First is ozonolysis. That is important from this chapter. So if you have, let's say, double bond here, right, and any compound is over here, you add ozone, then what will happen here when you add ozone, right? Then what will happen? Break the double bond, attach double bond O on both the sides. Okay. Let's see. I have CH3 here. I have H here. I have CH3 here. I have CH3 here. So this will be CH3. This will be H. This will be CH3. This will be CH3. You will have the formation of these two things, right? This is if I say you have reductive ozonolysis. Let's say you are adding H2O2, you are doing oxidative ozonolysis. Then the hydrogen that is directly attached to the carbonyl carbon, that will be converted to OH here. Rest of things will remain the same. And that is how you will get your answer here of reductive and oxidative ozonolysis. Right? Okay? Yes, everybody? Next is the reactions of Grignard that I will prefer doing that when we will do organic chemistry, that we will do on Thursday, because on Thursday you have full organic chemistry, and organic chemistry questions are obviously interlinked to each other, so that we can do mixed questions are asked there. They will ask you mixed reagents from different chapters. So those questions you can only understand once you have the knowledge of all the reagents and all the naming reactions that are there in the organic chemistry. Okay? Yes, everybody. So that's it for today. We have completed class 11 physical chemistry, and everybody, for all the students who are planning to give their 2026 NEET exam, then you can enroll to the batches where 40% scholarship you will get, right? You can get enrolled to MVSAT and get your scholarships there. Right, offline JEE and NEET repeater batch is going on, and the batch is starting from 25th of April. Right, so definitely with the help of tests you can get the scholarship there. And for all the students, how you will get the scholarship from MVSAT, you can get the scholarship, right? Link is in the description. And free NEET 2025 accelerator program is going on, 3-day last mile strategy workshop. This is very important, right? That is going to day 1 to 17th April. That is timing is this, right? And everything you just have to register yourself. The link is in the description for you, right? Okay. The cities, the link, everything is mentioned in the description. And this is a 3-day last mile strategy workshop. And if you are someone who is like, ma'am, something you can give us online. So in the description box, you will get, this is the firstly that I told you, NEET Accelerator for 3 days, right? This is NEETpedia, where on, like when you add your details here, you will get the previous year questions, right? You will get last 4 years previous year questions, most important previous year questions. You will get the most important topics. Everything will be there in the NEETpedia, right? That is link is over here, right? Okay. And that's it. Now let me see how many likes you have given to us, and let me just call Baswa sir, right, so that he can start with the class, because I think I have already taken a lot of time, right? Baswa sir is going to now do Jagrata, right? Wait a minute, let me just call sir, right? Okay, so are you all ready for bio class, everybody? Let's start, sir. Break, ma'am. We want break. Okay, let's see. I don't think so. Baswa sir will allow you any break now. Right? Hello?
Okay. Okay, students. Okay. I think I'm also set here. I think I'm also set. All of you are also set here. Hello, everyone, students. Students, I hope I'm audible to all of you. Students, quickly tell me in the chat. Students, quickly tell me in the chat right now if I'm audible to all of you. Quickly in the chat, all of you. Quickly in the chat. If I'm audible to all of you. Yes. Yes, 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 students. Oh, 1 second. Done. This is gone. 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 So hello students, welcome back to your own channel Vedantu NEET English. This is Bhattacharya, your biology master teacher. Students, quickly tell me in the chat right now if I'm audible and visible to all of you students. Quickly tell me in the chat right now if I'm audible and visible to each and every one of you students. House full? Yes. Students, again, the flow is very simple. We'll be following your NCERT flow itself. NCERT flow itself. We'll be starting off with the living world. Again, I will not take a lot of time in living world. Then after living world, we'll be starting off with plant kingdom, morphology, anatomy, cell cycle, biomolecule, cell cycle and cell division, plant physiology, which starts with your entire photons in higher plants, respiration in plants, and finally plant growth and development. That is going to be your entire menu, right? Entire menu for today, students. Again, so students, Captain Shreyas is here. I see Gopika ma'am is here. Diksha ma'am is here. So do you realize the entire team is right here with you at exactly 11 p.m. 11 p.m. Yes. So this is how what we really care about you. This shows that all the teachers in your NEET English team, we really care about you, and whatever the time is, whatever the place is, we'll be there to support all of you students. So if you're watching this video for the very first time, students, quickly subscribe to the channel if you're new, and also quickly smash that like button if you're new to this video again, students. Hello everyone. Hello, hello, hello. Okay, students, the session is going to be very simple rule. I have a very simple rule in my class. When I'm teaching you, I'm a living quiz. I will ask you a question randomly from any chapter, anytime. And all of you also know that throughout my teaching, on YouTube, I ask a lot of questions. So if you're in my class, if you know the answer, if you do not know the answer, doesn't matter. It is all about participation. So when I ask you a question, I expect the answer from all of you. And it's a simple rule, right? If you make the mistake right now in my class, you will not make a mistake in examination. Very, very simple rule. So every single time I ask a question, tell the answer in the chat, move ahead. Okay. So students, let's go with the first chapter. Shall we start? Can I get some fire emoji in the chat to know that yes sir, we are ready. We are ready, students. Yes. Students, are we ready? Oh, awesome. Awesome, students. The first chapter in our syllabus is going to be the living world. So what is the weightage here, sir? Weightage is very simple, students. The weightage is generally one question. Students, the board gave up. Weightage is generally one question in general. Once again, students, 1 second. Weightage is not very much here. Weightage is very almost one question or two questions, but generally you cannot expect any question from here. Generally, you cannot expect any question from here because there are only three main topics here. Three main topics. Okay. The first topic is called as binomial nomenclature. Now, the first question for today's menu is going to be, the first question is, students, which scientist gave the binomial nomenclature? Answer in the chat. Which was a great scientist who gave binomial nomenclature? The meaning of binomial means two names. So one scientific name has two parts. Okay. For example, let me give you a quick example, students. The quick example is going to be, students here, Mangifera indica. Now students, Mangifera indica is the scientific name of mango. Now I want everyone to tell me what is the name of mango in your language. For example, in English it's mango, Hindi it's aam, in Kannada it's Mavin Hannu. So in Tamil, Telugu, any your language which you from, wherever you from, right? Every animal or every plant or every fruit has a name in it. Now, there is obviously a difficulty in it. What is the difficulty? Because let's say I am going to America. I am going to America and I'm telling him, students, mangai. Okay. Let's say I'm going to America and I'm like, I want 1 kg mangai. That person will be like, who is this mental person? What is this Marvin Kai? What is Marvin Handu? So there is always a confusion if you have a same name, if you have a different name for same fruit. So to solve this issue, we have something called as binomenclature. Binomial nomenclature gives us a name which is universal. This is the scientific name of a mango, and throughout the world it is going to be as such. There cannot be any change. Okay, so even if I go to USA, Europe, Africa, North America, Argentina, Brazil, any part of the world, the scientific name of mango will be Mangifera indica. Done? Okay. So binomial nomenclature are generally in Latin or written in italics. They are italicized or driven from Latin irrespective of the origin. Whatever may be the origin, derivation is from Latin. Agree? Okay. Now, the first word is a biological name, represents what, students? The first name here is going to be genus. So the first word is going to be what, students? It is going to be genus here. The second one is going to be what, students? The second word is going to be specific epithet or species here. Specific epithet or species here. So the first one is genus, second is specific epithet or species here. Okay, done. Now the second rule, this is the first rule right here. This is the first rule, done. Done, first rule. Now what is the second rule here, students? The second rule here is that both the words in biological name, when handwritten, when you are writing in your book, they are supposed to be what? They are supposed to be separately underlined. Separately underlined. But what about if I'm typing it? If I'm typing it, you can make it italic, like Michael Jackson. You can make it like Michael Jackson, italics. Okay, when you're typing it. Now, the first word denotes the genus starting with a capital letter. So always remember, students, the genus will start with the capital letter and species epithet will start with small, cute, small letter here. So capital letter, small letter. And with that, your first topic for today is over. The first topic for today is over. So that is called as rules of binomial nomenclature. To sum it up, students, every word is from italics. It is from Latin here. When you're writing it, underlined separately, the first is called as genus, second is species epithet. It is supposed to be Michael Jackson when you're typing it down. And all the students, here the first letter is going to be capital, second is going to be small. That's all, students. That is called as binomial nomenclature given by Carl Linnaeus. Okay. Now, the second concept is called as taxonomical hierarchy here. So all of you know what is a building? All of you know what is a tall building, students? In every building, there are multiple floors. First floor, second floor, third floor, fourth floor. Similar to, students, how we have first, second, third floor, there is something called as taxonomical hierarchy. Here, students, every single floor is also called as what? It is called as taxa, students. Every single floor here is called as a taxa or rank here. Taxa or rank. See, all of you also might know, in the case of your police force, there is inspector, there is a what is, students? First is constable, head constable, inspector, sub inspector, there is no super inspector, but yeah, then you have commissioner. It goes on, right? So that is also, there is a rank there. Here also we have a rank. Now all of you might know, all of you will know this, but there's one small thing which all of you will miss here. What is that, students? What is that? So I'll ask you one question, students. In examination, if they write ascending order, if they write ascending order, will you write from kingdom to species or species to kingdom? Which one is ascending order, students? Which one is ascending order here? Which one is, students? Which one is going to be ascending order here? Tell me in the chat, students. Which one is ascending? Kingdom to species, species to kingdom. See, all of you know this. All of you know this, students, right? Species, kingdom, class, order, family, genus, species. All of you know that. But if they ask you in examination, ascending order, what will you write? Okay. Christina, Mohanat, all of you. Kavya, Sahara, Aruna, Nitrosomus, Bhavitra, tell me. So always remember, students, always remember, this is given as ascending order. You can see, students, taxonomical category shown in hierarchy in ascending order. So always remember, ascending order is from species to kingdom. Species to kingdom is going to be ascending order, and descending order is going to be ulta. That's all. Topic is done. Topic is done. Now, students, one more thing you have to remember here is that, right? All of you know what is sponges. Can anyone tell me, students, sponges belong to which kingdom? Sponges, the animal sponges. It belongs to kingdom Animalia. It belongs to kingdom Animalia. All of you know that. Humans also belong to kingdom Animalia. So, students, do you think, do we have any similarities with sponges? No. So at kingdom level, students, always remember at kingdom level, I'll erase this all for all of you. At kingdom level, what happens is, at kingdom level, similarities are very less here. But as we go down to the species, similarities will increase. Tell me yes or no. Like your mother will say you look like a donkey. Your mother will say you look like a donkey or donkey. Okay, but all of us know who is our cousin. Our cousin is who, students? Our cousin is monkey. So monkey and us, both of us belong to primata, right? Both of us belong to primata, and we look alike. We are not good with donkey, but yes, I look like a monkey. So similarities will increase as we go down. So here we have more similarities at species level. Students, board is also black magic is doing today. Okay, so at species level, similarities will increase. Is the concept clear, students? Is the concept clear to all of you? Students, tell me in the chat. Is the concept clear to all of you? So at species level, we will have more similarities, and at your kingdom level, similarities very less. With this concept, done. Concept is done here. Okay. Now, the last concept you have to remember is this table right here, and I don't think so you have to worry about this table. Very, very simple. You have learned this table 10,000 times. Okay. So I will give you exactly 30 seconds, and then I'll ask you a question from this table. I can ask you anything. I can ask you biological name. I can ask you genus, order, class, and phylum of only 4 organisms here: man, housefly, mango, wheat. So I'll give you 30 seconds. Then I will ask you a question, students. Ready, all of you? Your 30 seconds starts right now. All of you, I want all of you to stare at this board. Okay, time starts now. Go. Your time is started. Students, your time is started now. You can't tick, go. Board only is not ready, students. How many marks you can get, students? You will know. You will know the preparation I'm going to give you today. Next level preparation I'm going to go today. Once you're done, just say done, sir, in the chat. Once you're done, just say done, sir, in the chat, and then we can go. Growth and metabolism, different chapter. Oh, you want to learn this also? I'll teach you that, student. Don't worry, I'll teach you that also. See, I'll teach you that part, but they generally don't ask question in that. Okay, done, students? Okay, done, all of you? 30 seconds is done. Now the question to all of you students, can anyone tell me what is the family of mango called as? Mango, sweet mango. So I love mangoes, so always ask mango question. So what is the family of mango called as? Any one of you? Mango is Anna something, no? Anna, not Anna. Tell me, students, what is the family of mango called as? Anna what? Anacardaceae. Anacardaceae is the family of your mango. Anacardaceae, not Anna. Anacardaceae. Okay. Students, tell me the order of Musca domestica. Tell me the order of Musca domestica, students. Order of Musca domestica. Quickly, students. Oh, all of you are very smart, I know. All of you will tell me today. Okay. Tell me the family of Musca domestica. You will tell me, sir, Diptera. You will tell me, sir, Diptera is going to be the order of Musca domestica. And Muscidae is the family. Class is Insecta. Arthropoda is going to be division or phylum. Okay, students. Done, students? Done, all of you? Now, here, if you want more details, see, students, after every chapter is done, I will give you a reference video which you can watch for more information also. Right? Every living organism has few things. It has growth, metabolism, consciousness, as is reproduction. Right? So all of this are you have something called as fundamental defining. All that I've taught in this video, that is more important, so watch it here. Okay, students. So first chapter is done. First chapter is done, students. First chapter is done. Done. With that, the first chapter is done. So I hope all of you understood the concept till now. Trust me, students, this is how the entire session is going to be. Very chill, very easy. Okay. Now, shall we start with, students, can we start with plant kingdom now? Shall we start? All of you? Shall we start? So, students, I'm telling you, after every session, after every chapter, I will give you one specific video which you have to watch if you want more information on it. Okay. Done, students. First chapter is done. That's all. That's all is the first chapter, nothing more than that. Okay. Now, all of you drink some water. Students, all of you drink some water. Done. First chapter is done now. Done. Exactly. First chapter, done with that. Okay. Now, shall we start with plant kingdom right now? Plant kingdom. Now, again, students, in plant kingdom, question can come from anywhere. So, I have made the best notes for you, students. And let me tell you, these notes I have never given on YouTube till now. It's a secret notes. These are called as topper secret notes. So all of you ready for that? All of you ready for the secret notes? Tell me, students. Tell me. All of you ready for the secret notes? Here we go, students. So first of all, before we go, students, now there is something called as classification. There are two types of classification in general. There is something called as artificial system of classification. One is called natural system of classification. Now, students, all of you tell me. Now, in movies, what happens? There are two types of movies. Okay. First type of movie is that hero and heroine love at first sight. One more type of movie is what? Heroine will say, I don't want you. Hero will keep going behind heroine, and heroine will always agree later on. Okay. Now, students, the first type of movie is what? The first type of movie is that love at first sight. Now, what is love at first sight here? Love at first sight is looking at the muti here. You look at the face and love at first sight happens here. That is called as artificial system of classification. In artificial system of classification, you're looking at only what? You're looking at external beauty or external morphology. So that is, it was given by Carl Linnaeus. Consider only gross superficial morphological characteristics. Only from the outside. Like, you don't look at a person's heart. You do not care what they're, how much they're earning, how much their family property is, nothing you think. Okay, I'm telling the reality. You don't see how pure the heart is in starting. Okay, this is your artificial love. This is your artificial love right here. Okay. Now, what is your natural love? Natural love is going to be, you do not look at the morphology here. You look at the internal beauty. It means you look at the heart. Love is happening or not. Okay, so natural system of classification was, students, given by George Bentham and Hooker here. Now, consider internal features like ultrastructure, anatomy, embryology, and phytochemistry. This is called as natural system, artificial system. Concept done, next concept right now. Next concept. Now, students, these are my notes. You have to learn from these notes, students. Beautiful notes. These are, you will fall in love with these notes. That's how amazing these notes are. Okay. Now, students, all of you know my Telegram, right? This is my Telegram. This is my Telegram right here. Basavaraj Sir Biology. Okay. This is my Telegram right here. You can join Telegram. You'll get all the notes also. Okay. Now, students, understand here. Various classifications were given to classify angiosperms such as artificial and your natural. There is also phylogenetic is also there. Okay. So at present, phylogenetic classification based on evolutionary relationship among the various organisms is most accepted one. So phylogenetic is mainly evolution consideration. Now, what is numerical taxonomy? Understand, students. Usually, tell me, students. Usually, how do we find the evolution? When you want to find the evolution, you look at the fossils. Tell me yes or no, students. Tell me yes or no. If you want to see the evolutionary, you look at the fossils, plant fossils. Now, what if fossil is not available? When the fossil is not available, then you go for numerical cytotaxonomy. Now, what is numerical taxonomy? In numerical taxonomy is carried out using computer and is based on all observable characteristics. For example, let's take Harini. I will tell Harini and Harshin. Okay, Harshini. Harini and Harshini are sisters. Let's consider. Okay. Let's take or Tarun. Okay, let's take Tarun and Harshini, brother and sister. Sorry, okay. So Harini and students, I forgot the names only. Students, let's say A and B are brother and sister. Okay, A and B are brother and sister. Now, how do I know they're brother and sister? I can find, how do I know? We look at the features of A, we look at the features of B. Okay, then we compare the features. We will give one feature as one number, one more feature, one more number, and then we compare them. Okay. That is numerical taxonomy. Okay. Now, what is cytotaxonomy? It is based on cytological information. Like what? Chromosome number, chromosome behavior, chromosome number, chromosome behavior, and everything. Okay. That is called cytotaxonomy. Okay, students. Now, that is very important. Now we come to algae. So, in plant kingdom, we have mainly something called as algae. Then we have bryophytes, pteridophytes, gymnosperms. I'll repeat again, students. In the case of your plant kingdom, we have algae, bryophytes, pteridophytes, and gymnosperms. These four things you have to remember. Now, students, shall we start with algae right now? Shall we start? Yes. So take plant and plant B. Okay. Plant A. No. We will take person A, person B only. Okay. Now, students, shall we start with algae right now? Okay. Now, students, when you think of algae, what comes to your mind? Tell me, students. All of you in the chat, tell me. When you think of algae, what is coming to your mind right now? If I think of algae, some green color, some rotting thing is coming to my mind. True. Okay. Now, when I think about a plant, what comes to your mind? When I think of a plant, root comes into my mind, shoot comes to my mind, flower, fruit, branches, leaf comes to my mind. So even though algae, it doesn't look like a plant, but still algae is a plant. Why, students? Because algae has a pigment called as chlorophyll A. So every single plant from your plant kingdom, they will have chlorophyll A. They will have chlorophyll A, students. Okay. Now, so I told you an algae does not have root, does not have shoot, right? Does not have leaf, does not have flower at all. So such a organism, such a plant body, which does not have anything, it is called as thalloid plant body. What is it called, students? It is called as thalloid plant body. Okay. So algae are chlorophyll bearing. They have chlorophyll. Simple thalloid. The meaning of thalloid, what, students? Thalloid meaning is that they do not have root. So they do not have no root. Students, I will erase my name here, but you remember. Okay, you remember all of you. Join my telegram. Okay. So there is no root, no shoot, and no leaf only. No leaf. Okay, no leaf also. No leaf. Okay, no leaf. That is thalloid. It is autotrophic in nature, meaning it can prepare their own food, and largely aquatic in nature. Now that is your biodata of your algae in starting. Biodata of your algae in starting. Now students, understand here. In algae, asexual reproduction is by production of different kinds of spores here. So there are different kinds of spores production here. For example, there is most common being zoospores is the most common type of spore here. Now what happens in sexual reproduction? In sexual reproduction, there is something called as fusion of gametes here. Now there are three categories here: isogamy, anisogamy, and oogamy. Can anyone tell me, students, what is isogamy? Isogamy means what? Iso means what, students? Tell me. Iso means what? ISO means same to same. So in isogamy, what happens is the two gametes are same to same. That's all. Okay. So fusion of two gametes dissimilar, as in some species called Eudorina, that is called as anisogamy. This is going to be anisogamy. Okay. Now, two fusing gametes can be flagellated and similar in size. So this is called as isogamy here. This is your isogamy means what? It can be flagellated and same in size. That example is Eulothrix here. Or non-flagellated, non-motile, that is Spirogyra. So students, all of you should remember this. All of you should remember, students, in your isogamous type, there can be two categories. One can be motile, one can be non-motile. This is very important to remember. Now, for motile, what is the example? We have Eulothrix here. And for non-motile, students, what do we have example? We have the Spirogyra. So all of you will remember, students. All of you will remember this Spirogyra. That is under isogamy. Anisogamy is Eudorina. Now, other one is called, students, what? Other one is called as oogamy. In oogamy, what happens? Oogamy, we have one large, one small. So, okay. So, fusion between one large non-motile female gamete and a small motile gamete, male gamete is termed as oogamy. So, students, remember, oogamy is similar to humans. Large egg, cutie sperm. Okay. Large egg, cutie sperm, that is the same reality happening in oogamous type also. So, three types: iso, aniso, oogamy. Done, students. Done. Okay. Now, there is something called as hydrocolloid substance. Okay, students, all of you tell me in the chat, when you go outside in the sun, do you apply sunscreen? Tell me, students, all the boys. I know you can't relate to this, but other students, okay, other girls, especially boys, we don't care. Boys are like, well, what sunscreen, what sun is, sun will fight me. We are like, we don't care. We people don't care if there is sun or not. Okay. For girls, like they'll oh, sunscreen here, oh, sunscreen, they'll apply. So algae here is also very sensitive. Algae will also apply sunscreen. It will apply moisturizer also. It will apply moisturizer. Now moisturizer here is called as hydrocolloid. Hydrocolloid. Now what is hydrocolloid? Understand. Now imagine one algae. Algae in a beach, it is chilling. It is chilling. Sunscreen, it is chilling. Algae is chilling somewhere. It has high tide. Is there? It is fine. But as soon as it becomes low tide, as soon as it becomes low tide, what happens, students? As soon as it becomes low tide, algae is exposed now. Algae is like, oh shit, oh my god, what is happening here? So algae will do what? Algae will apply moisturizer all in the body. Okay. The moisturizer here is called as hydrocolloid. Hydrocolloid is the hydrocolloid substance is called as moisturizer. And this hydrocolloid will prevent the algae from becoming dry, basically becoming dry. Okay, so algene is obtained from brown algae. So remember this, students. Algene is obtained from brown algae and carrageen is obtained from your red algae. Red algae. Okay. Now, what is red algae called as, students? Can anyone tell me what is red algae called as? Rhodophyceae, and your brown algae is called as Phaeophyceae. Done, students? Done? Done. Exactly. What is sunscreen? Exactly. What is the sunscreen? I don't know what is sunscreen. Okay, students. Then, at least this is called as economic importance. You have to remember this. Okay. At least half, students. How many of you seen that meme? Students, how many of you seen that meme here? Students, this is my Telegram. I will show this meme. I love this meme. Okay. I love this meme. Let me show you that meme, student. I love this meme and I cannot get over it. So I hope you can remember this. I hope you can remember, students. I hope you can remember this meme which I showed in my Telegram long back. Students, how many of you remember this meme? Students, how many of you remember this meme? Tell me in the chat. Students, how many of you remember this meme? If you remember, tell me in the chat quickly, students. How many of you remember this? Right? Trees getting all the credit. Algae, which is producing 60% of oxygen. So in reality, what is happening? In reality, algae is producing 60% of oxygen in the earth. And we are people, we don't care. We don't even put any effort to your algae. But look at the plants. Look at the plants. Even though it is producing only so much, it is full on effect. I don't know why. So remember, students, always remember, please put some effort, right? Please put some, some love towards algae also. Okay, please put some. There's one more meme also. One more meme. I'll show you. Wait. I don't know why this people. I don't know. Algae doesn't. Students, algae doesn't get a lot of love. I don't know why. Algae should get a more love. Okay, students. Okay, it's missing in the chat, so I'll just show you some other time. Okay. So remember, students, at least half of the total carbon dioxide is fixed on Earth is carried by algae only through photosynthesis. So all of you remember algae next time. What is the importance of algae? Now, what is agar-agar, students? Agar-agar is all of you jellies, ice cream and all. So in jelly and ice cream, we had agar-agar here. And also, students, in the case of your, what is that? I forgot. In microbiology, you also use agar-agar. So agar-agar is obtained from your Gelidium and Gracilaria, which are type of your red algae. Okay. So the commercially products obtained from Gelidium and Gracilaria, which are used to grow microbes in preparation of ice cream and jellies also, agar-agar can be used. Done, friends, done. Now, chlorella is unicellular algae rich in protein used for food supplement to space travelers. What is pyro, students? Pyroids contain proteins. So, pyroids are small structure in your green algae. They contain protein here. Students, any doubt till now, students? Any doubt till now? All of you? Students, tell me. Yeah, students, algae can be kept as a pet. Algae can be kept as I have algae as a pet. Students, I have a pond in my house. Not a pond. This much I have a water body in which I am growing algae. And on top of the mooring, I can see there's so many oxygen bubbles there. I am keeping algae as a pet also. Okay, students. Now, can we come to the green algae, students? Can we come to the green algae right now? All clear till now? Green algae now. Okay. Now, green algae usually have a rigid cell wall made up of inner layer called as cellulose and outer layer made up of pectose. So, in the case of green algae, inner is cellulose, outer is pectose. Done. Green algae contains chlorophyll A, chlorophyll B and starch as food resource here. Okay. They form zoospores with 2 to 8 flagella. Friends, this I can just teach you this part here. For this, we can just go right here. Where is it? Magic, where is the magic? Right here, students. All of you can remember this. This is the chart all of you should know. This is the table all of you should know. Green algae, brown algae, red algae. This is the major pigments, chlorophyll A, chlorophyll B. See, A is common. B, C, D. That's all. See, A, B, C, D. A, B, C, D. Done. Now, stored material, starch, mantle, laminar in the case of brown algae, Floridian starch in the case of red algae. Cell wall, cellulose and pectose. Algene here. Here we have something called as polysulfate esters. Here, students, okay, I will give you 30 seconds. All of you ready? I will give you again 30 seconds to remember this table and then I ask you a question. The 30 seconds time starts now, student. 30 seconds time starts now. I'll give you 30 seconds, then I'll ask you a question. Ready, all of you? Ready? Time starts now. Students, time starts now. Quickly go. Students, how many of you go to gym? Gym is fun. Once you're done, just say done, sir, in the chat. Once you're done, just say done, sir, in the chat. Done, students? Learned already. What are you, supersonic train or what? Already done. Aditi, you should focus on examples. You should focus on this class right now. You will know where you can make mistake. Okay. Students, tell me which type of flagella do you find in red algae? Which type of flagella do you find in red algae, students? Who can tell me? Which type of flagella do you find in red algae? Flagella in red algae. Quick. Flagella in red algae. Flagella, red algae. Students, remember, in the case of red algae, the flagella is completely absent here. Flagella is completely absent here. Okay, students. Can anyone tell me what is the food storage in the case of red algae? Food storage in the case of red algae. Quickly, students. You will tell me, sir, food storage in the case of red algae is Floridian starch. It is going to be what, students? Floridian starch here. So all of you can remember these points. Students, I'll just show you some points which I've written here, which can help you in long run. Okay, let me just show you. Okay, let's remember this, students. Let's remember this. These are the examples you have to remember for your green algae. You have to remember green algae. Now, brown algae, students, what is happening? In brown algae, what is happening, students? Fucosanthin is the pigment here. Now, amount of fucosanthin can vary. So, if there is less fucosanthin, it is olive green color. More fucosanthin, more brown color. Simple rule. If you go in the sun for some time, brown color. If you go in the sun for very long time, you will become crow. You'll become, we say kage, right? We say kage in Kannada. So, you'll become one black crow, you'll become. So, based on how long you're in the sun, you will show tanning that much. Okay. Now, here also happens here. Same thing happens in brown algae also. Okay. Now, students, one thing which I want to tell you here is, this point here. In brown algae, the plant body is usually attached to the substratum by holdfast, stalk, and stipe, like that is called as your frond here, leaf-like frond here. Let me show you the diagram, students. Let me show you the diagram here. Can all please see this diagram, students? Is the diagram visible to all of you? Here. See here, students. You can see in the case of brown algae, this is called as holdfast, which attachment to the substratum. We have a long stalk structure called as stipe and long leaf-like structure called as frond here. This is the structure of your entire brown algae. You have to remember. Okay, brown algae you have to remember, students. Okay. Now, what do we have? Asexual reproduction is mostly in brown algae by biflagellated zoospores. Done. Now, students, in the case of red algae, we have Floridian starch is the food storage here. That point is given. Is the point given, students? Is the point given? Not given. Okay, I'll tell you, students. The Floridian starch it is very similar to which structure, students? Floridian starch is very similar to myelopectin and glycogen. A myelopectin and glycogen, Floridian starch is very similar in structure to that. Okay. Now, red algae is chlorophyll A, chlorophyll D, and phycoerythrin is the pigment here. Okay. Examples you have to remember again. Examples you have to remember. Okay. So, red algae lacks motile structure because flagella is absent here. The main plant body in the case of your students, the main plant body in the case of your algae is going to be what, students? In the main plant body in the case of algae is going to be gametophyte. It is going to be gametophyte, and gametophyte is always haploid in nature. It is always haploid in nature, students. Done, students? Done? All of you done, students? Okay. Okay. Done. It is going to be haploid in nature. Now, students, with that, can we come to bryophytes now, students? Can we come to bryophytes? Tell me yes or no? Okay. Now, again, let me just show you that table where I have written for that. One small table I have made for all of you. Is a table missing? Here it is there, students. See, algae main plant body is gametophyte. It is going to be haploid in nature. The same goes for bryophytes also. In the case of bryophytes also, main plant body is gametophyte and haploid. Pteridophytes, gymnosperms, angiosperms. In all of them, main plant body is going to be sporophyte in nature. Sporophyte in nature. And remember, students, sporophyte is always diploid in nature. Sporophyte is always diploid in nature. Diploid means 2n. Okay. Diploid means 2n, all of you. Okay. Now, students, let's come to bryophytes. Let's come to bryophytes right now. First of all, what do you need to know about bryophytes? In the case of bryophytes, the main plant body of the bryophyte is gametophyte. Point clear to all of you. Point clear to all of you, students. Now, understand here, the sex organ in bryophyte are multicellular and jacketed. What do you mean by jacket, students? Imagine, every single sex organ here will have a separate layer around them. They will have what? Separate layer around them, and they're wearing a jacket here. Like, you know, they're ready to fight. I don't know whom they're fighting here. I don't know who they're fighting here, but they're wearing a jacket around them, ready to fight. Okay. Now, students, in bryophytes, the female sex organ is called as archegonium, which is a flask-shaped structure here and produces a single egg. Okay. And what about the male? Male is called as antheridium. Now, students, I'll clear a small confusion for all of you students. The small confusion is generally is that, can anyone tell me, students, this archegoniophore and this antheridiophore, are they the sex organs? Are they the sex organs, students? Can anyone tell me in the chat? Are they the sex organs? Tell me yes or no. All of you. Tell no. Tell first. Are they the sex organs? Tell me yes or no in the chat. You will tell me no, sir. They are not the sex organs. Like how a flower has a stalk, that is called as a pedicel. So flower has a stalk, right? This right here, this archegoniophore and antheridiophore are not the sex organs. Nope, rejected. They are called the stalk here. They are the stalk here. So here, what is the archegoniophore here? Archegoniophore and antheridiophore are these structures here. These are the sex organs. I do not know why NCERT is not labeling that. So NCERT is supposed to label that. No. So all of you, NCERT 0, we are 1 point ahead now. Okay, we are 1 point ahead. So this is the archegonium and antheridium, the sex organs here. Okay. Now here we can have a flask-shaped structure here with a single egg cell in the middle. We'll find here. Here we can find from this antheridium, we can find the biflagellated anthropoids can come from here. Okay. Now, see this here. Now, students. Now, here main point here is going to be the species of sphagnum here. Sphagnum is a moss, you have to remember always, provides peat moss that have long as being for fuel and packaging material. So, peat moss and sphagnum, you have to remember all of them. Now, what about mosses? Mosses along with lichens are the first organisms to colonize rock. So, this point can also be asked for all of you in ecological importance for bryophytes. So, mosses are very important also. Okay, students? Now, asexual reproduction in liverworts, there are two things, liverworts and mosses. I will teach you life cycle, learn the life cycle also. Asexual reproduction in liverworts takes place by fragmentation of thallus or by formation of specialized structure called as gemme. Now, students, here you might have seen something called as gemme cup. Here, this is a Markantia. This is a Markantia liverwort. On this Markantia liverwort, we can see a small gemme cup here. Gemme cup. Now, students, remember this gemme cup is actually part of asexual reproduction. This gemme cup here, students, will produce something called as spores or buds here, and that will develop into a new plant body. So, gemme cup is asexual in nature, and it is found in the case of liverworts. In the case of liverworts here. Okay. So, what is gemme, students? They are green multicellular asexual buds. What are gemme, students? Gemme are nothing but green multicellular asexual buds which develop in small receptacle called as gemme cup. Gemme cup, students. These are gemme cup here. Now, students, let's look at the life cycle. Shall we start? Students, can we start? Students, who is this new sir? Yeah, I'm new sir only, students. I'm new sir only. Students, shall we start the life cycle now? Life cycle for liverworts, first of all. Life cycle for liverworts. Okay, shall we start, students? Shall we start? Life cycle. Can we start? Shall we start, students? Life cycle. That is very important. That is very more important here. Now, students, understand here, your liverworts are said to be dioecious. What is the meaning of dioecious? First of all, understand what is the meaning of dioecious. Di means 1 or 2. Tell me, students. Di means 1 or 2. Di means 2. Di means 2. So, in the case of liverworts, what happens is both the sex organs are present on the same plant. So, 2 sex organs are there. Okay, sorry, different plants. Different plants. Different thalli, sorry. Different thalli. 2 different thallus. Okay, so you can see here we have female gametophyte, male gametophyte. So here we have male gametophyte, female gametophyte. Both are being born on different thalli here. Dioecious, different thalli. Okay, different thalli, students. Yeah, I am only new here. Okay, I am only new here. Okay, students. So here we have male gametophyte, female gametophyte. Understand now, understand. Male gametophyte will always produce the antheridium, female will produce archegonium. Antheridium, archegonium. Antheridium will produce what? Biflagellated antherozoids. They will nicely swim in water. They will do some what? Swimming in water, and they will go here. They will reach here. You know what? Imagine students what and all they are doing to find the archegonium. They'll swim in water and go to find archegonium. Now, once they find archegonium, it undergoes fertilization. Once there is fertilization, what happens is there is zygote formation here. Zygote will be diploid here. Zygote is diploid now. Now, this zygote undergoes mitosis now. This zygote undergoes mitosis. Now, students, can anyone tell me, in mitosis, is there a change in ploidy? Can diploid become haploid in mitosis? You're like, no, sir. In mitosis, there is no change in ploidy at all. Diploid will remain diploid. So, students, remember, the zygote is diploid. So, once it undergoes mitosis, it will produce something called a sporophyte. And that is why this entire sporophyte is going to be diploid in nature. Diploid, maintaining this happening. So, that's how we get the sporophyte here. Now, students, remember, this sporophyte here has three parts. Foot, seta, and capsule. Now, this foot, seta, and capsule, this is the top part called as capsule. Now, what happens? Remember, students, gametophyte produces gametes. Gametophyte produces gametes. What do you think sporophyte produces? See, gametophyte will produce gametes. Sporophyte will produce spores. So, what happens, students? Meiosis takes place inside the capsule. Inside the capsule, meiosis takes place and we get the spores and haploid spores. And these haploid spores, after meiosis, right, will undergo mitosis and new plant body, and that is always the life cycle. That is always the life cycle, students. That's all. Done. So, gametophyte, fertilization, gametes, fertilization, zygote, mitosis, sporophyte is diploid in nature. Inside the capsule, meiosis, and we get the spores. Spores develop into gametophyte, haploid, diploid, everything is done. Now, what about monoecious? That is your mosses. In the case of mosses, mono means what? Mono means one, right? One. So, both the 6 organs are present on one plant only here. For example, this is one thalli. In this one thalli, we can have antheridium and archegonium. Both are present here. So, again, what happens? From here to here, fertilization happens. Zygote formation, mitosis again, capsule formation, foot, seta, and capsule. The sporophyte, diploid zygote. What happens? Again, what happens here? Meiosis takes place, spore formation. Now, the difference here is that in the case of mosses, the spores will not become gametophyte directly. Never. What happens is, students, in the case of mosses, there is a leafy stage. Can anyone tell me what is the leafy stage, students? Can anyone tell me what is the leafy stage here? All of you tell me, students, what is the leafy stage here? Can all of you see the board and tell me? See, participation in my class, very simple rule. The more you participate, the more you learn. The more you participate, the more you learn, students. So, your answer is on the board only. Your answer is on the board. In the case of mosses, there is a leafy stage before the formation of main plant body. Before the formation of main plant body, there is a leafy stage. The leafy stage is called as what, students? The leafy stage is called as protonema formation. So, always remember, this protonema formation will always happen where? In the case of mosses. So, if I ask you a question, the protonema is haploid or diploid? What is your answer, students? Protonema is a result of from spore formation. So, it is going to be haploid in nature. That is all the difference between mosses and liverworts. Main difference. Done, students? Done. Okay. So, in liverworts, sporophyte is differentiated into foot, seta, and capsule. Done. The predominant stage of life cycle of moss is gametophyte. First stage is called protonema, which develops directly from the spore. The second stage is the leafy stage, which develops from the secondary protonema in lateral buds. So, this protonema will have something called as lateral buds here. Can all of you see? Lateral buds. This lateral buds will develop into the main plant body. Here. Okay. So, that is the end of bryophytes. Students. Done, students? All of you? Yes. So, that is all your bryophytes. So, in bryophytes, the only thing you have to remember extra is the examples from on your own. So you will learn the example, students. All of you learn the examples. Tell me yes or no. So if you know the life cycle, that is that almost work is done. Now, one more question can come here. What is the question? Can anyone tell me in the chat, in liverworts or mosses, where do we find unisexual rhizoids? Who can tell me, students? Who can tell me? It is so easy. Exactly. It's so easy. That's all is the concept. See, with me, honest students, anyone from my student, anyone who is my student, right? Anyone who is my student will know. Whenever I teach a concept, at the end of it, it looks so easy. You'll be like, what is even there? Okay. Now, students, now we come to your entire pteridophytes, students. Entire pteridophytes. Now, one more thing I forgot to tell you, students. Bryophytes actually, students, bryophyte actually is called as amphibians of plant kingdom. Why? Because bryophytes, they may be on land, but they require water for fertilization. You remember that. Okay. Now, students, can anyone tell me what is a complex tissue? Anyone tell me, students? Mosses, exactly. Who can tell me what is a complex tissue? Complex tissue. What is a complex tissue? You will tell me, sir, complex tissue is a tissue, right, which can be made up of two different types of cells here. Example is xylem and phloem. Xylem and phloem are complex permanent tissues, right? Xylem and phloem. Okay, xylem and phloem. Now, a question arises in examination. Which of the following plants, the first time ever, xylem and phloem formation happened? The answer is supposed to be, students, the answer is supposed to be pteridophytes. So from pteridophytes onwards, the first time ever what happens? The formation of xylem and phloem took place. Okay, so xylem and phloem happens from pteridophytes onwards. So in pteridophytes, the main plant body is sporophyte. So remember again, students, here, main plant body is sporophyte here. Now, can anyone tell me in the chat, the sporophyte rate, right? Sporophyte, haploid or diploid? The sporophyte is going to be what? Diploid in nature. So please remember this also. Sporophyte is going to be diploid in nature. It is going to be what, students? Diploid in nature. Throw it a little bit. Okay. Now, students. Now, this sporophyte, right? This plant body here. The plant body has some root-like structure is there. Stem-like structure is here. And we have leaf-like structure here. What do you think the function of root is? The main function of root is anchorage. Main function of root is anchorage. It helps in holding. Can anyone tell me what is the function of leaf? Again, students, here we can find two types of leaf: macrophyll, microphyll. Macrophyll is big leaf, microphyll is small leaf. But what is the general use of leaf? Anyone in the chat who can tell me? General use of leaf. So you will tell me, sir, general use of leaf is nothing but No, sporophyte is diploid always. General use of leaf is photosynthesis, all of you tell me. Okay. It is going to be photosynthesis, all of you tell me. But what if I tell you? What if I tell you, in the case of pteridophytes, the leaf is very special. In the case of pteridophytes, the leaf is very special and they have something called a sporophyll. So in the case of pteridophytes, students, there is a special leaf. There is a special leaf called a sporophyll, and this special leaf here is fertile leaf. It is going to be, students, black magic on the board. It is called as fertile leaf. Now, if it is called as fertile leaf, the leaf here is responsible for reproduction. Leaf here is responsible for reproduction. Yes. So that is speciality about your sporophyll or pteridophytes. The leaf here is mainly involved in reproduction, and the fertile leaf is called as sporophyll here. Now, what do I mean by that? Understand, all of you, understand. Here we have something called a sporophyll. The sporophyll has something called as sporangia. All of you know what is sporangia, students? Yeah. The chat is very slow for me, I know. So this, students, this sporophyll right here will have something called a sporangia. Students, how many of you have seen this sporangia in real life? How many of you have seen the students? Let me show it to you, students. Let me show it to you. Students, how many of you have seen this in real life? Students, how many of you have seen this? Tell me yes or no in the chat, students, quickly in the chat. See, this is a sporophyll. This right here is a sporophyll. It is a fertile leaf, and this leaf will have sporangia in the back. Now this sporangia is there, right? This sporangia right here. This is involved in reproduction. This is involved in reproduction here. So all of you might have seen right now, this is called as sporangia or sporophyll. Now students, understand here is that when we have multiple sporophyll now, one sporophyll. If multiple sporophyll join together, what do you get? When multiple sporophyll join together, we get something called as, what do we get, students? What do we get? Quickly in the chat. When multiple sporophyll join together, what do we get? We get something called as strobili or cone. And this cone formation happens here. Cone formation can also be seen here, students. So let me show you a diagram, NCRT diagram. Can all of you see here, students? This is called as a cone here. Strobili or cone. So when many sporophyll join together, we get the cone here. We get the cone here, students. Beside my pond, very good. It's called as cone here. So it is seen where? It is seen in, students, which plant? I will tell you one plant, Equisetum. You should tell me one more plant name in the chat. Okay, I will tell you one plant name. It's called Equisetum. Other one you should tell me in the chat. The answer is right here. The answer is right here, students. Okay, I'll tell you Equisetum. Okay, students. Now, students, in the case of pteridophytes, they can produce two types of spores. Okay, so first what happens? Some pteridophytes are homosporous. Teres, they can produce only one type of spore. Some of the organisms are heterosporous. Example is Salaginella salvinia, right? They can produce two types of spores. Done, students? Done here. No. Now, students, can we start the life cycle, all of you? Can we start Salaginella? Absolutely. Nice. All of you telling the answer in the chat. Okay. Now, what is homospory and heterospory? Understand. If this is your homospory life cycle, and this is your heterospory life cycle. Now, what is the difference? All of you understand first of all. In homospory, what happens? All of you know, main plant body is sporophyte, diploid in nature. Now, from this we have root, stem, and frond here. Frond is what, students? Frond is nothing but. No. What is frond? Frond is a leaf here. Now we have special leaf. Special leaf is called as what? Sporophyll. That is also diploid in nature. Now this is called as fertile leaf here. It has sporangia. Sporangia is diploid in nature because sporangia is part of the leaf and leaf is part of sporophyte, diploid in nature. Now what happens? Understand, students. Understand here. Inside the sporangia, what happens? Meiosis inside the sporangia. Now, students, all of you tell me. Gametophyte, gametes. Sporophyte, repeat after me. Gametophyte, gametes, sporophyte, spore formation. From this sporangia, what happens? After meiosis, spore formation happens. Students. Spore formation happens. So here we can see after meiosis, there is a spore formation here. After meiosis. And these are going to be haploid in nature. Now these spores now undergoes mitosis to produce something called as prothallus. So again remember, students, in pteridophytes, after spore, we don't get the plant body directly. We do not get. In the case of pteridophytes, there is something called as prothallus formation. Now students, all of you remember again, this prothallus is very short-lived. It is very short-lived here. This prothallus is very short-lived here. And again, students, this prothallus is actually the gametophyte here. And students, this prothallus is said to be independent. See, green color. It can do photosynthesis. So it is independent. Very independent it is. Doesn't need anyone's money here. Okay. So very independent person here. Prothallus. Now on this prothallus, since it is a gametophyte, on this prothallus we can see antheridium and archegonium. Bifledged anthrozoids, zygote formation, and this zygote here, students, tell me, zygote is going to be diploid in nature. Zygote undergoes mitosis, diploid plant body. That's all. That is all is the entire thing. Students. That's all. See this. Sporophyte, frond, sporophyll, special leaf. Sporangia is a structure here. Inside sporangia, meiosis takes place, we get spores. This spore undergoes mitosis to produce prothallus, haploid, independent, green color, everything. Okay. Now this prothallus now develops here Prothallus will develop something called as archegonia antheridium, zygote formation, zygote is diploid, mitosis, diploid, sporophyte. Boom. That's all. The concept is over. That's all. The concept is over. So that's all. The concept is over. Homospory is over. This is what happens in homospory. So here, all of you need to understand here is that, students, in the case of homospory, gametophyte, sporophyte, first time in history. Repeat after me, students. First time in history of plant life cycle, sporophyte and gametophyte are independent. This board also not writing now. Is independent. Both are independent here. Both are independent. Can you see? Sporophyte, both are independent here. First time ever, students. Both are independent here. Okay, both are independent. Now, what about heterospory? What happens? In the case of heterospory, obviously there are two types of spores. Okay, so there is one small spore, large spore. Small spore will undergo meiosis, large spore undergoes meiosis. Microspore, macrospore. Microspore, male gametophyte. Macrospore, female gametophyte. Male gametophyte, antheridium. Female gametophyte, archegonium. Biflagellated anthrozoids swimming in water, going to the egg and undergoes fertilization. Now, once it undergoes fertilization, understand, students, this sporangia here, what happens here is that, students, the female gametophyte, understand, very important, understand, students, very important, understand, all of you. This is the sporangia. Students, please write. This is the sporangia here. Sporangia. Right? Sporangia here. Sporangia is diploid in nature. Now, inside this sporangia, first time ever, we can see the female gametophyte here, and we can see the archegonia here. Archegonia with in the center we have the zygote here. We have the zygote right here. So, and this time what is happening here? The female gametophyte is retained inside sporophyte. Inside the sporophyte, it is retained inside the sporophyte, and this is the precursor of seed habitat. This is what we call seed habitat. What is the meaning of seed habitat? The meaning of seed habitat is what, students? Meaning of seed habitat is that the gametophyte is dependent on the sporophyte, and this is the initial development of seed formation. But in pteridophytes, we do not see seed. Why? Because there are no integuments here. Integuments are required for seed coat formation. There is no seed coat here, no seed formation. So seed habitat can be seen here, first time ever here. And again, students, first time ever, right? Gametophyte is dependent on the sporophyte. First time ever. This gametophyte is dependent on the sporophyte. First time ever it happens. Okay. Now, students, see this. What have we learned till now? This is what we learned till now, students. In pteridophytes, multicellular free living, mostly photosynthetic thalloid plant is called as your prothallus. Prothallus is going to be very independent here. Very independent. Okay. Students, all of you remember heterospory? Small, large, microspore, macrospore, male gametophyte, female gametophyte, fertilization. This is what happens after fertilization. That's what is heterospory. That is only heterospory is here. Okay. See here. The development of zygote into young embryo takes place within the female gametophyte. Within the gametophyte, this event is precursor or seed habitat, considered as an important step in evolution. Very important step in evolution. This is called a seed habitat. Okay. Now, students, with that, pteridophytes also is over. Now we come to gymnosperm, students. What is gymnosperm, students? Can anyone tell me? In gymnosperms, do we get seeds or not? In gymnosperms, do we get seed? It is independent, exactly. Students, Do we get independent? Yes, gametophyte is dependent on sporophyte, first time ever. Do we get seeds in the case of? It's raining there also, it's raining. Students, it's raining so heavy outside, I can't tell you. Yes, do we find seeds? Yes, we find seeds. But do you think the seeds have seed covering? The seeds have fruit covering, students? Do you think the seeds have fruit covering? Tell me yes or no. Do they have a covering, students? No. They're called naked seeds. They're called as naked. Chichi. They're called as what? Naked seeds. They're called as what, students? Naked seeds. Why? Because there is no ovary formation here. There is no ovary formation. Therefore called naked seeds here. They're called as naked seeds. Okay. No coverage only. Okay. Now, gymnosperms are plants in which ovules are not enclosed by any ovary wall. No ovary wall. And remain exposed. Okay. Before and after fertilization. Now, giant redwood tree is called as Sequoia, right, is one of the tallest gymnosperms here. Gymnosperms generally have taproot here. Okay, taproot here. Students, I want all of you to remember one thing here, students. In the case of your gymnosperms, right, in the case of gymnosperms, very important concept, okay, very, very important concept. Please remember that. In the case of gymnosperms, always remember that, students, naked seeds. And here, two things you have to remember. This is the table of all of you have to remember. We have cycas and pinus. This is what all of you have to remember. Now, what is the difference between cycas and pinus? Cycas, what happens? Stem is unbranched, stem is branched here. Leaf is pinnately compound, needle-like leaf in pinus. Here, in the case of cycas, we have something called as CCC. What is CC? Cycas, colloid roots, and cyanobacteria for nitrogen fixation in your cycas. At the same time, in the case of pinus, what do we have? Your roots have mycorrhiza association. Okay. Here, male and female cones can be found here. Okay. Here we can find only male cone, and they're dithecous, they're monoecious, they're dioecious, they're monoecious in nature. That is the main difference of your both the things. Students, ask your doubts. Students. So this botany trending hacker, who is the hacker here? Okay. Students, this is what you have to remember. All of you will remember this, students? All of you will remember this? Tell me yes or no. All of you will remember? Yes or no, student? Tell me in the chat. This you have to remember for gymnosperms. That's all for gymnosperms, and it's over. That's all, it's over. Okay. So remember colloid root. What is colloid root? It will have cyanobacteria in the roots here. Okay. Apart from students life cycle, they will not ask you, but if they ask you by general, all of you should remember same life cycle happens in the case of your normal also. The only difference is that here is that in the case of your life cycle of your gymnosperms, you will always find haploid endosperm here. We can find embryo here. We can find seed coat here. So one more question I can generally which asked is here: do you find pollen grains in the case of gymnosperms? True or false? Students, they will not ask you this generally, but I'm telling you. Students, tell me, do you find pollen grains in the case of gymnosperms? You're like, yes, sir. In the case of your gymnosperms, you'll find pollen grains. Till when the class is 5 a.m. Class will be till 5 a.m. If you are going to be there awake till students, the best part is no one can come robbing today. Imagine someone planned to rob somewhere and they hear my voice, they'll run away now. Okay. Students, they find pollen grains are found here. That is what thing. Pollen grains are found here. Remember that. We can find pollen grains in the case of gymnosperms. There will be also pollen tube formation also will happen here. Okay. So remember that point also. Students. Okay. And students, with that, plant kingdom is over. So in plant kingdom, all you have to remember is the algae examples, and bryophyte, pteridophytes examples, and gymnosperms. That last table which I showed you, with that it's over. Nothing is in plant kingdom. Okay, nothing is in plant kingdom, students. Okay. Now, students, if you want to solve more questions, if you want more clarity, here you can see a 2.5 hour, 3 hour lecture here, and here also again 2 hour lecture. Both of these videos can be used for plant kingdom also. If you type this in plant kingdom, you can get all the information. You can get all the information, friends. Okay. Exactly. Angiosperms is related. Angiosperms is related. Angiosperms is related, students. Gone. Okay. Okay, students. So, shall we start the next chapter now? Can we start the next chapter now? Can we start the next chapter, all of you? Plant kingdom done. Students, I'm difficulty seeing the chat. All of you drink some water. All of you drink some water now, students. All of you drink some water quickly. Done. Ready, all of you? Yes. Ready? Ready, all of you? Again, students, in morphology, the main part is the examples. Today, again, I'll be teaching you all the tricks. I won't be writing the tricks. I will be orally telling you tricks. So, all of you, if you know my tricks for every single thing, you need to type in the chat. You need to type in the chat, students. Okay. When will be the plant physiology? Plant physiology at the very end. Okay. Okay, students. Trending hacker, what is your question? Bro, what is your question? No rain, students. It's so raining. It's so much of raining here, students. So much of rain here. Yeah. See, students, if I'm ready to teach, all of you ready to listen to me or not? Students, again, I'm telling you, you don't have an option. You do not have an option. This is the class which will make you, the jump in botany will happen to next level. This is a class which is going to be very important for you. If you attend this class, you get a lot of marks. Okay. Now, students, shall we start? All of you in the chat. Shall we start right now? Next concept. I can see students are already dropping. Let's start. Morphology of flowering plants. Again, students, the best notes available on the entire market here. Okay. I've given you all the notes here. Let's read one by one and explain you one by one, students. Understand. Okay. Now, in majority of your dicot plants, the direct elongation of radical leads to the formation of primary root. So, primary root will always result, or tap root develops from your radical directly, which grows inside the soil. Dicot plants have tap root. Okay. At the same time, in monocot plants, the primary root is short-lived. See, they have primary root. In the case of monocot, they have a primary root, but it is very short-lived. And it replaced by a large number of roots called as fibrous root. Now, students, again a question arises. What do you call the roots which are arising from base of stem? For example, this is a stem right here, and here, this is the nodal region here, lowermost node here. From the base of the stem, we can find roots arising. Roots are arising from the base of the stem. Such roots are called as what, students? Such roots are called as what? Fibrous root. They are called as what, students? Fibrous root. Fibrous root develops from the base of the stem. Remember that. Okay. Now, students, in some plants like grasses, monstera or banyan tree, roots arise from part of the plant other than the radical. If there is some root developing, other than the radical, that is called as adventitious roots. So, technically speaking, fibrous root is arising from where? Fibrous root is arising from base of the stem. That is not radical. So, can I tell students, that this adventitious root, fibrous root is actually an example. Fibrous root is actually an example of adventitious roots. So, remember that concept. Adventitious roots is a root which is arising from any part of the plant other than the radical. Okay. Now, students, let me show you a small thing which will give you better clarity. See this here. See this, students. Tap root directly from the radical. Fibrous root developing from the base of the stem. Adventitious roots, root which arise from the any part of the plant other than the radical, that is called as adventitious root. From the leaf, in the case of your bryophyllum, from somewhere here. Now, students, then there is something called as root modification. Understand, students, what is root modification? Now, in taproot we have turnip and carrot for storage. Adventitious roots we have sweet potato. So all of you remember, students, sweet potato is a modification of adventitious roots. All of you remember, students? All of you remember that? Yes? Hello, Janani is doing some next level sorcery in the class, next level magic. Okay? Now, students. Now, what about for support? In the case of banyan tree, students, how many of you seen that? They say no. In banyan tree, there's some ghost will be there. Ghost. You have stories, right? So when I was a kid, every single time I used to see a banyan tree, my main goal in life was to become a Tarzan. My main goal in life was to become a Tarzan. Hold this banyan tree, that thing, and start swinging here and there. Okay. So you might have seen from the banyan trees, some roots will come arising downwards. They are called as prop roots. In the case of sugarcane also you might have seen, in the case of sugarcane, the roots are arising from the stem here, lowermost node here. They are called as stilt roots. Stilt roots in the case of sugarcane, prop roots in the case of banyan tree. Then there is something called as roots which are arising from the soil here. Some roots are arising against the gravity for respiration. Students, how many of you seen cartoon, right? You might have seen in cartoon what happens when the Tom is running behind Jerry. What will do? Jerry will go under the water and it will start to breathe. It will keep a long pipe and it will start to breathe through that. Starting breathing through that. Why is Jerry doing that? Because it can breathe through a small pipe. Same thing is happening here. When the plant does not have a lot of oxygen, no, it will grow small pipe. The pipe will grow out of the soil. Same thing here. Now these roots are called as what, students? These roots are called as what? They are called as pneumatophores. They are called as what, students? Pneumatophores, or also they are called as respiratory roots. They are called as what, students? Respiratory roots here. Respiratory roots. Okay. Now they are, where are they found? They are found in marshy areas or swamp areas or halophytic condition, wherever there is more soil condition. Now why are they growing? They are growing for breathing here. They are growing for breathing. That's all. Okay. Now students. Now see here, students. See here. Now that is the one concept done, students. Now there is something called as root parts. There are three main regions for your root: region of maturation, region of elongation, and region of meristematic activity. Can anyone tell me in the chat, students, in which part here will have dividing cells? Yeah, good morning all of you. Good morning, students. Good morning. Okay, friends, tell me in which part here we can find dividing cells. All the dividing cells will be present in the meristematic region, and this region is there, no, elongation region. This is responsible for the root length increase. Help in root length increase. Now one more question arises, students. From which region we can find root hair arising? Now all of you know, students, all of you seen this old people, babas and everything. Old people have a lot of beard now, or mature people have beard. Again, remember, students. So region of maturation will have a beard here. Region of maturation will have a beard here, and the beard is called as root hair. So if they ask you a question, from which region beard is coming, I mean root hair is coming, you should tell me region of maturation, root hair is coming here. That's all, students. That's all. Region of maturation. Now there is something called as root cap here. What is root cap here? Root cap is protection. It is protecting the plant, protecting the meristematic region here. That is called as root cap. Okay. See here. This point is done. Banyan tree, prop roots, stilt roots, sugarcane and maize. Done, students. Done. Now, next thing. So in some plants, rhizopora done, pneumatophores done. Now, students. Now we come to stem. Students. Okay, beard maturation, exactly. Beard is maturation. It is matured. I am also very matured. All of you are now, students? All of you are right now. You are not meristematic. All of you are elongation right now. All of you are in elongation region. Okay, because all of you are growing right now. Okay. Now, understand, students, what exactly happens in a stem here. Okay. Students, how many of you eat sugarcane recently? Students, thimble-like structure, yes. How many of you ate sugarcane recently? Sankranti was there, right? There was Pongal was there. All of you ate sugarcane. Tell me yes or no. All of you ate sugarcane. No, tell me, students. All of you ate sugarcane. Tell me yes or no. So when you eat sugarcane, there is see, I love eating sugarcane. Okay, very sweet. Okay. So when I'm eating sugarcane, what happens is that there is one soft area which can nicely eat. But suddenly when there's one thick area, I hate that thick area. One thick area will come which I don't like eating only. Thick area comes. So the soft area in a sugarcane is what, students? The soft area in a sugarcane is called as internodal region, soft area. The thick area, what thick area, students? The thick area is called as what? Nodal region. Node is part of thick area. Middle part is called as your internodal region here. Now students, understand the concept here. What happens here? You might have seen on the sugar cane, at the nodal region, do you see a small leaf arising there sometimes? When you're eating sugar cane, students, you can see that small leaf arising there. Yes, you do. So from the nodal region here, from the nodal region, we can see the leaf arising. So if I ask you a question right now, from which region leaf arises? You will tell me, sir, from the nodal region the leaf arising. The leaf is arising from the nodal region right here, nodal region. Okay. Now this is called as leaf axil. This part is called as leaf axil. Now when the shoot is growing, when the apical bud is growing, some cells are left behind here. Some cells are left behind. This region is called as what, students? These cells which are left behind are called as axillary bud here. Axillary bud. And this axillary bud can develop into a flower or a branch. Flower or a branch. Develop into a flower or a branch here. This is the axillary bud here. So all of you remember this much. Done, students? Done. Now see here. This underground region of stem where leaves are born is called as nodes. Okay. Now they have given you certain examples here. Learn the examples here. Underground stem of zamikhand, potato, ginger, turmeric and colocasia are modified for storage. Stem tendrils, very important concept. Students, don't show ghost and all in the chat. Don't show ghost and all in the chat. Otherwise, who knows, something might come. Okay. So stem tendrils which develop from axillary bud are slender, spirally coiled. For example, students, this is the stem here. Okay. Let's draw one stem here. From this stem right here, this is the nodal region. From this nodal region, I can see a leaf arising. Leaf is arising. Now here, let's say I have an axillary bud here. Now, let's say this axillary bud will develop into now tendrils. Will develop into tendrils. So axillary bud will develop into tendrils here. Tendrils. Okay. Now, what is important here? Important here is going to be the examples. Watermelon and cucumber. Watermelon, cucumber, grapevine, all are the examples here. Okay, all the examples. Now, students, understand here. If this axillary bud, if it develops into a spine, like this spine, okay, if it looks like a lipstick right now, lipstick. Okay, if it develops into a spine, the actual name is not spine, the actual name is thorn here. Okay, so if it modifies into thorn, the example is citrus and bougainvillea. Citrus and bougainvillea is the example here. Citrus and bougainvillea is the example here. Okay, citrus and bougainvillea are example for the thorns here. Axillary bud for tendril is going to be watermelon, cucumber and pumpkin is there. Okay, now students. Now the lateral branch with short internode and each node bearing rosette of leaves is called as, with a tuft of root is called as your what? Offset. Offset can be seen in the case of Pistia and Icornia. Pistia and Icornia, we can see offset here. Okay. Now students. Now next concept is called as how are the leaves arranging? When the leaf is developing, how are they arranged? The arrangement is called as your acropetal arrangement. Now understand what is acropetal. Understand students what is acropetal arrangement. Understand what is acropetal arrangement. Students, I can show you one diagram here. Understand what is acropetal arrangement here. Okay. Let's take here, I have a stem here and I can see leaf arrangement here. I will see very young cute leaf here and I can see old leaf at the bottom. Old leaf at the bottom. Young leaf at the top, old leaf at the bottom. This is called as acropetal arrangement. This is called as what, students? This is called as acropetal arrangement right here. So leaves are always born in a acropetal arrangement here. Okay. Now students. Now typical leaf has three parts. A typical leaf has three parts, consists of leaf base, petiole and lamina. A typical leaf has three parts. It has your leaf base, petiole, lamina. Students, can anyone tell me, students, which region here, which part here is responsible for the absorption of lights? Who can tell me, students? Who can tell me which region of this leaf here, your lamina, petiole, or petiole or leaf base, it is responsible for trapping of the light, or which is the much more wide area here? Yes, anyone who can tell me? The wide area is called as lamina here. Wide area is called as lamina, which is responsible for trapping of light. Responsible for the trapping of light. Clear, all of you? Lamina. Very good, Tara. Very good, Akshay. Very good, all of you. Aditi, very good. Yoroshini, very good. Meghana, very good. Right? It is going to be lamina here. So you can see here, this is called as your lamina part. Then we have the leaf base here. This is the leaf base right here. Leaf base. And this is called as petiole. Petiole is the stalk here. Is the stalk right here. Okay. So in the case of monocots, leaf base expands into sheet covering the stem partially or wholly. That is called as, students, in the case of monocots, that is called as what? Leafing sheet base. Like imagine, I'll show you one small diagram. See this. Let's take, this is the stem here. In the case of monocot, what happens is the leaf base is covering the stem only. See, imagine like this. Leaf base is covered now. Leaf base is covered like this. Okay. Partially or wholly. Partially or wholly. Okay. Now, in some this is nice. In some leguminous plants, the leaf base may become swollen. That is called as pulvinous leaf base. So, leaf base can become swollen or it can cover the entire leaf. That is called as your pulvinous leaf base. Okay. Now, students, next thing is called as arrangement. Arrangement of veins and veinlets on lamina is called as venation. We have two types of venation. Friends, can anyone tell me, in the case of dicot, do we have reticulate or parallel? In the case of your dicots, do we have reticulate or do we have parallel venation? Anyone who can tell me? Who can tell me, students? A of B is very easy, students. Tell me quickly in the chat. In the case of dicot, we will have reticulate venation. All of you know that, reticulate venation. Okay. Okay. Reticulate venation can be seen here. Okay. Reticulate venation. So in the case of monocot, we can see parallel venation in the case of monocot. Okay. Now students, understand what is a simple leaf. This is a simple leaf. This is a compound leaf. What is the difference between here? Now students, simple leaf right here, right? It will have something called as incision. This is, can you see the bending inside? Bending inside is called as incision. Now students, all of you tell me in the chat, is the incision touching the midrib here? Tell me yes or no. Students, tell me. All of you are my favorite students. Who is my favorite student? All of you are my favorite student. Nothing is, there is no partiality here. Okay, students, tell me. Here, in the case of simple leaf, is the incision touching the midrib here? No. Because this is the midrib here. This is the incision. It is not touching the midrib. That is called as a simple leaf. So in the case of simple leaf, incision do not touch the midrib. But in the case of compound leaf, the incision will touch the midrib here. It will touch the midrib. And here, the midrib is called as what? The midrib is called as rachis here. That is called as rachis. So rachis is the stalk actually. This entire thing is called as rachis here. Called as rachis. Okay. Now there is something called pinnately compound as well as palmately compound. In pinnately compound, what happens is that, students, understand, all the leaflets are there. Rachis here. Rachis is attached to petiole. Petiole is attached to the node here. Example, neem, pinnately compound leaf. But in the case of palmately compound, what happens? In the case of palmately compound, the entire leaflet are directly attached to the petiole. There is no rachis here. Can you, students? There is no rachis here. Rachis is absent here. Example is silk cotton here. Example is silk cotton here. Okay. That is happens in petiole. So petiole is directly attached to the leaflets here. Here we can see rachis, petiole and node here. Petiole is here. That is palmately compound. It's like a palm. Imagine there's a palm here. All of these are leaflets directly attached. This is my petiole. This is the petiole attachment directly here. That is called as palmately compound leaf. Okay. Next concept is called as phyllotaxy. What is phyllotaxy, students? Phyllotaxy is very simple. Just students, you tell me in the chat right now, you tell me in the chat. At this node, how many leaf do you see? All of it in the chat, students. At each node, how many leaf do you see? Friend. Yeah, I am, students. Students, I am still young to be married and all. What? All of you made me married person already. Tell me, students, tell me in the chat. At one node, how many do you see? Only one. See, at every node, we can see only one here. That is called as alternate phyllotaxy. Now, students, tell me here, how many do you see here at one node? At one node, how many do you see? At one node, you see 2 here. So, every node has 2 of them in an alternate fashion. Okay, 2 here. Now, students, you tell in the chat, all of you, in world phyllotaxy, students, how many do you see here? All of you? Tell me, students. Yeah, I have one, students. Yeah, I look 70. Students, trust me in the... Okay, I'll tell you one small story what happened after this. In world phyllotaxy, we can see at one node, we can see more than 2. More than 2. So here, all of you need to remember the examples. Alastonia for world. China rose, mustard and sunflower for alternate. Opposite, we have guava and calotropis. Okay. Students, what happened was recently when JEE exam happened, first time JEE exam happened, right? I went to give interviews. I went to take interviews. Okay. So I went to the exam center. Okay. And the first thing the examination asked me, you come here, which shift? I'm like, I thought they will not allow me inside. Because generally students are not allowed in, generally other students and parents are not allowed inside generally. So I told him, sir, I've tried first shift. The watchman is like, did you study everything? I'm like, yes, I studied everything. My maths is my favorite subject. And let me tell you, students, the watchman thought I'm a student and I'm going to write an exam, JEE examination. So I'm just going and sitting there. I'm just sitting here in the park and waiting for the students to come out. And that day I realized, if I shave completely and if I go to the examination, if I go sit in a classroom, 99% of the chance, everyone will think I'm a student and not a teacher. God promise, if I come to your school and if I come to your school also, right, your school or college, right, when you were studying, if I shave completely and I just come and sit with you, you will think I'm a new student. And it happens a lot. Oh my God. So very difficult to look young. It's very difficult to look old nowadays. Also, it's a good thing. No, it's a good thing. Oh my God. Now, next thing is called as your inflorescence. Students, what is inflorescence? Students, what is inflorescence? Yes, I'm very young. Exactly. From which angle do I look like a 30-year-old with a kid also? I don't. Okay, students, next concept is called as inflorescence. Understand what is inflorescence. Okay. In inflorescence, what happens is all the flowers are arranged in a group. So basically what is happening is, all of you know what is a gang? All of you are in a gang, students. Students, in your school you have a gang. Tell me, students, yes or no? Kids call you uncle. Dinesh, I'm so sorry. But one day, one kid called me uncle. I was so offended. I'm like, this person, okay, this small kid who is in 10th standard who's calling me uncle. That was very offended. Now, students, tell me in the chat. All of you are in a gang in school. Tell me yes or no. You're in some gang. One small gang will be there. You're in a gang. So, inflorescence is also gang formation. What happens is that all the flowers are present on a stalk here called as your peduncle. There is a gang formation here. That is all is inflorescence. Okay. Now, there's one gang is called as, students, this one gang. Okay. One gang is called as racemose. The second gang is called as cymose. Gang number 1, gang number 2. What is the difference? You understand? Difference is very simple. In this racemose gang, what happens here? They will never stop. What is the meaning here? Here, main axis will keep on growing. But in the case of cymose, this gang is very conservative. Here, main axis terminates with a flower here. Main axis will terminate with a flower here. That is racemose inflorescence. Understood? Understood, students. Now, understand here. Here we can find unlimited growth, limited growth here. Here we can see acropetal arrangement, basipetal arrangement here. Now, students, all of it. Okay. One small question to all of you. Don't laugh. Okay. The small question is that, imagine there is a running race. Running race is that there is, let's say, one 25-year-old adult one side very young person, and one more person is 95 years old. A running race between young person and old person. Who will win? You tell me, students. Who will win? Type in the chat. Who will win? Will the young person win the race or old person will win the race? Tell me in the chat. Tell no. Who will win the race, sir? If you tell old person, brain cell is missing for you. Tell me, students. Yeah, students, I'll come with you only to write your same center. I'll come to the same center and I'll write the exam with you only. But the problem is, I will only write biology and then physics and chemistry. I'm like, Panduranga, I'll just type something. Young person will win the race. Okay. So imagine, students, in racemose inflorescence, it's a race. Racemose inflorescence is a race. Young person is winning the race on the top, old person at the bottom. Concept over. All of it understood the concept? So racemose inflorescence is a race. In a race, young person at the top, old person at the bottom. So this is called as my 2 a.m. What's the time? 12 a.m. theory to only remember. Okay. Now, opposite in the case of your Syllabus here. Opposite in the case of Syllabus. Old person at the top, young person at the bottom. So all of you will ever forget, students. All of you will forget. You will not forget. Done. So Panduranga is God. When students, it's a God thing which I always tell. Okay, Panduranga. Like Ayo, we say no. Okay. So all of you understood, students. All of you understood. Tell me yes or in the chat. All of you understood, students. Got it. Young person winning the race, old person at the bottom. That is called as a inflorescence. Okay. Acropetal, basipetal inflorescence. Done. Examples have to remember. Acropetal done. Syllabus done. Everything is done. Now, students, what do you mean by perianth here? Understand what is the meaning of perianth. Students, understand what is perianth here. We have a petal, we have a sepal. We have a petal, we have a sepal joined together. Petal plus sepal is called as tepal. Nothing fancy in that. Okay, nothing fancy in that. Petal plus sepal is called as tepal. If there is a group of tepals, what do you call it, students? A group of tepal is called as what? Perianth. That's all. Okay. So group of tepal is called as tepal. Not very creativity used here. Group of tepal is called as perianth. Done. Now, students, now we come to something called as. I forgot the name, student. What is the name? Now we come to something called as, what is the name? Sign of old age. Oh my god, I forgot, students. What do you call that? Students, what do we call actinomorphic and zygomorphic as? Think. What do you call actinomorphic and zygomorphic as, students? Symmetry. Now we come to floral symmetry. Students, that word only went away from my head. I'm like, what is the word? Symmetry. Now we come to symmetry. Repeat after me. Symmetry, students. Symmetry. Okay. Symmetry, students. Now there are two types of symmetry. Okay. One is called as actinomorphic. One is called as zygomorphic. Okay. Symmetry. Oof. Brain cell is not there only now. Symmetry. Actinomorphic, zygomorphic. Now, understand what is actinomorphic. If let's say I have one flower here. Okay. I have one flower here. Okay. Now this flower can be divided in multiple planes. This flower can be divided like this, like this, like this, like this. So if a flower can be divided in multiple planes, it is called as actinomorphic. Okay, actinomorphic. So when a flower can be divided into two equal halves in any radial plane, it is called as actinomorphic. Now here a small trick. The small trick is called as what, students? How many of you like McDonald's? How many of you like McDonald's, students? How many of you like McDonald's? Raise your hands. How many of you like McDonald's? See, I love McDonald's. And sometimes I eat, sometimes I don't eat, but I am hungry now, students. Okay. So here the trick is what? MCD, McDonald's. Okay. What is M? M for mustard, C for chili, D for datura. So actinomorphic, you will do acting. In the house, you will do acting to go McDonald's. You like, mommy, I want to eat McDonald's. Okay. So McDonald's is the answer. Okay. The first one is done. Now what is zygomorphic? Zygomorphic is a condition where you can divide the flower into only one plane. For example, let's say one flower here. Let's take one flower here. This flower can be divided into equal halves in only one plane. That is called as zygomorphic. That is called as, students, what? Zygomorphic here. I didn't eat today lunch. Didn't eat the dinner, students. What to do? In my house, I was showing off. In my house, I was like, I will not eat dinner. Now, I thought my mom will be like, no, beta, please eat some dinner. Please eat something before you take a class. Mom is like, okay, fine, I'll go sleep. So as soon as I told I don't want dinner, mom packed everything. She went and she slept off. I'm like, what is this? No concern for your son. Okay. Now, next is called as zygomorphic. Okay, I think zygomorphic here. Okay, students, zygomorphic, what happens? Example, I'll tell you how to remember example in zygomorphic. Okay. Okay, BGP. Okay, what is BGP? It is not BJP. It is not BJP. It is BGP. Okay, that is Bean Gulmohar. Okay, P. Bean Gulmohar and Cassia. So candidate from BGP. Candidate from BGP. Okay, candidate from BGP happens here. Candidate from BGP. Cassia, Bean, Gulmohar and P. That's all for zygomorphic. That's all for zygomorphic. Done? Done, students. BGP. Okay, BGP. BJP party. Okay. Now, one more is called as your asymmetry. What is asymmetry, students? Asymmetry means no shape only. You cannot divide in any plane. Example is Cana. Example is Cana. All of you remember that, students? All of you remember Cana? You can remember Cana. Okay. Now, students. Next concept is called as your arrangement of position of gynoecium based on other worlds. Next is called as hypogynous, epigynous, perigynous. Okay. Understood? Understand? Here we have, students. Here we have. Now the first one is called as hypogynous condition. This is called as hypogynous condition. Hypogynous, who is the queen here, students? Who is the queen here? In hypogynous, the queen is going to be the gynoecium. Gynoecium on the top. On the top here. Gynoecium is superior here. Superior on the top. So queen treatment here. Okay, this is called as queen treatment right here. Queen treatment. Okay. So here, gynoecium is present on the top. Gynoecium is present on the top. Everyone is beneath. Everyone is like, I am the queen of the world. Everyone is below me. That is what is happening here. Okay. So gynoecium on the top, every other wall. It could be androecium, sepals, petals, everything from the bottom. That is what superior ovary. Okay. Now what is the trick here? The trick here to understand the example is hero must have brinjal. Okay. Hero must have brinjal. Hero must have brinjal. Hypogynous condition, mustard, hibiscus and brinjal. Hero must have brinjal, students. Okay, I am queen material, exactly. Queen material. Okay, so hero, repeat after me, students, all of you in the chat. Hero must have brinjal. Hypogynous condition, mustard, hibiscus and brinjal. Done. Now, students, what is going to be next one? Next one is called as perigynous condition. Students, all of you know the trick here? Students, how many of you watch the show called as Phineas and Ferb? How many of you know Phineas and Ferb, students? How many of you know Phineas and Ferb? Students, how many of you know who is Perry the Platypus? Students, how many of you know him? He is one of my favorite cartoons ever. His name is Perry the Platypus, okay? His name is Perry the Platypus. Now understand what is happening. Now how can you remember Perry the Platypus with perigynous condition? Understand. Now Perry the Platypus, right? It is going to be not inferior. It's going to be half inferior. It has dual role. Okay. So perigynous Perry the Platypus it is half inferior. It is not inferior. In front of the Phineas and Ferb, it is like very chotu masum. It is inferior. But in front of that evil scientist, Cap is there ready to fight everywhere. So it is half inferior in nature. Perigynous is half inferior in nature. Okay. Now what is the trick here, students? What is the trick here? The trick here is what, students? People pluck pink roses. The trick here is what, students? People pluck pink roses, students. Half inferior. People pluck pink roses. People pluck pink roses. Perigynous condition, plum, peaches, roses. All of you students? All of you understood? Yes or no, students? Tell me in the chat. People pluck pink roses. I don't know why they only want pink roses. I personally like not pink, white roses are nice. No, white rose is so nice, white rose, right? People pluck pink roses. Okay, so perigynous, plum, peaches, roses. People pluck pink roses. Then all of you, done? Then students, that is called as perigynous condition. Next is called as students. Next is called as, it's missing. Okay, it's missing here. Okay. Next is called as epigynous condition. Students, understand what happens in perigynous condition. All of you understand here. Now, students, all of you know what is the meaning of rim. Students, all of you know what is the meaning of rim. The meaning of rim is the edge here, edge or the corner here. So, if you can notice here in perigynous condition, here the ovary is not superior. It is half inferior and ovary is in the dead center here. It is in the center here. It is in the center here. And all the other floral whorls, where are they arising from? Tell me students, where are they arising from? They are arising from the rim of thalamus. This is called as rim of thalamus. From the rim of thalamus, all the other whorls are coming out. All the other whorls are coming from the rim of thalamus right here. Other whorls. So this is called as your perigynous condition. But in the case of epigynous condition, students, in the case of epigynous condition, sad story. Epigynous condition, sad story is there. In epigynous condition, ovary is completely enclosed. RIP students. Very sad story. Here, ovary is not shown here. Ovary is completely covered here. Ovary is in a completely inside here. Here it was superior, but here it is completely inferior here. The ovary does not have a chance to speak also here. Okay, so complete, it's very sad story, students. Completely sad story. The ovary is completely enclosed here. Enclosed. That is called as epigynous condition. That's called epigynous condition. Now, what is the trick here, students? The trick is very simple here. Epic sunny goes camping. Okay, students. Can anyone tell me the examples here, students? Can anyone tell me the examples? One example I'll tell you. Okay, S for sunflower. S for sunflower, that is ray of flowers of sunflower. S for ray of flowers of sunflower. What is C? What is G? G you will eat nicely. I love eating G part here. Guava. C, what is C, students? C is cucumber. That also is very nice. That also is very nice, students. Okay. Class will go till 3 a.m. What are you telling? Class will go at 3 a.m. or 4 a.m. Who knows? Or 5 a.m. Who knows? Guava and cucumber or cucumber, whatever you call it. Cucumber or cucumber, whatever you call it. Okay, so guava, students. Okay, done. Now, next one is called as estivation. What is estivation, students? Estivation is nothing but arrangement of petal or sepal with respect to each other. That is called as estivation. We have something called as valvate, twisted, imbricate, vexillary. Students, again all of you know the tricks here, students. Can anyone tell me the tricks for? Can anyone tell me the trick for valvate? Valvate chair. C for calotropis. So valvate example is calotropis. Twisted. What is the example, students? For twisted, all of you tell me. Twisted is a lady from China. A lady from China has a twisted cotton. A lady from China has a twisted cotton. What is that meaning here? China is China rose. Lady is lady's finger. Twisted is twisted estivation. Cotton is cotton. So lady from China has a twisted cotton here. Okay. So China rose, lady's finger, cotton. Okay. Now students, next is called as imbricate. What is imbricate? Imbricate is nothing but, understand students, in the case of imbricate, what happens is, here what happens, students, is it is similar to twisted, but the difference here is that this one petal is completely on the outside here, this one petal is completely on the inside here. Remaining all the three are alternating to each other, but here they're all alternating here. So imbricate, what is the example? Imbricate, advocate. Imbricate, advocate. Advocate fights gun cases. Gun cases, G and C, Gulmohar and Cassia. Gulmohar and Cassia are the examples for imbricate. Now, last is called as vexillary estivation. Understand what happens in vexillary. Very simple funda here. In a vexillary estivation, we can have something called as your standard here, standard crackers, Here we have wing, and here we have keel here. Keel here. Standard wing and keel. That is 1 plus 2 plus 2 arrangement can be seen here. Wechsler estimation. Done. Done, students. Okay. B and P. B and P here. Okay. Now, next thing is called, students, what do you mean by epipetalous condition? What do you mean by epipetalous condition? Epipetalous, understand, students. Wife files case on NTA. Will file case on NTA. Okay. I'm like, which wife is filing a case on me? I'm like, whose wife is making a case on me? I was thinking. Okay. Now, what is epipetalous, students? What is epipetalous? In the case of epipetalous, students, it is nothing but stamen plus petal. Very weird combination. Stamen plus petal. Okay, done. Stamen plus petal is the combination. Okay, students. Now, what is epiphyllous condition? Epiphyllous condition is tepal plus stamen plus stamen. That is epiphyllous condition. That is called as epiphyllous condition. Done, students? Done. That is epiphyllous condition, epipetalous condition. Here the example is brinjal. Given, brinjal is the example. Epiphyllous condition is going to be lily. Done, students? Done. You can write tepal or perianth, both make sense, it's fine. Okay. Now, students, there are a lot of stamen. All of you, there are a lot of stamen. If all the stamen are arranged in one bundle, it is called as what, students? It is called as monoadalphous in nature. Monoadalphous example is China rose, one bundle. If they are arranged in two bundles, what do you call them, students? If all the stamen are arranged in two bundles, what do you call them, students? Students, I can't see the chat, so that's a problem. That's why I wear glasses. I'm randomly reading so many things. I'm like, whose wife I'm reading there? Okay, now, this is better now. So, students, tell me in the chat, if all the stamen are arranged in two bundles, what do you call them? This is monoadalphous. That is going to be diadalphous. That is going to be what, students? Diadalphous. And remember, students, diadalphous example is P. P is the example. P. PEAP. Okay. Now, students, if they are arranged in multiple bundles, what do you call them, students? If they are arranged in multiple bundles, it's called as polyadalphous in nature. Now, what is the example for polyadalphous? The example for polyadalphous is going to be what, students? Citrus. It is going to be citrus in nature. Okay, it's going to be citrus in nature. Done, students? Done. Okay. Next concept. Now, what about gynoecium or carpel? Carpel has three parts. All of you know, stigma, cell, and ovary. Three parts are there. Done. Okay. Stigma was the landing platform. Imagine, students, stigma is like one helipad. A helicopter will come. Helicopter will travel. It will come, land there. Helicopter is pollen grain. Landing platform is stigma. Done. It's a stigma. So pollen grains will come and land there. Okay. Now what happens, students? Understand here. Inside, let's say this is one. This is one. Here we have stigma, long style, and then we have the ovary here. RIP diagram. Okay, properly. This is the stigma here. This is the nice style. Students, all of you know my style joke, no? Students, all of you know my style joke, right? All of you know my style joke. Yes or no? Tell me. No. Good. Then there is ovary here. Ovary here. Okay. Ovary is right here. Okay. Now, students, inside the ovary, what do we have? Inside the ovary, here we can see the arrangement of ovules. So inside the ovary, there can be ovules arrangement can be seen here. Now all the ovules are attached to the placenta here. All the ovules are attached to the placenta right here. Attached to the placenta. Okay. Attached to the placenta. Okay. Now that is placenta. Each ovary bears one or many ovules attached to the flattened cushion-like structure called as placenta is present here. Okay. So when more than one carpels are present, it's called as, and the carpels are free, it is called as apocarpus. But if all the carpels are fused, it is called as syncarpus. Carpels are fused is called as syncarpus, free is called as apocarpus. After fertilization, students, ovules will become into seed, ovary will become into fruit. Okay, the arrangement of ovules is called in the ovary is called as placentation. Now students, I want all of you to remember the examples again. I want all of you to remember, students, the examples. Okay, all of you should remember the examples here. Okay, that is for marginal placentation. Can anyone tell me the example? Marginal. All of you love eating with paneer. Paneer, or with paneer you eat it. P. P is the example. P for marginal placentation. Axial placentation, students, tell me in the chat. For axial, what tell me? Tell me, students, axial. What is axial, students? Axial is nothing but allow China to leave. Remove China from India. Okay. That is A for axial, C for China rose, T for tomato, L for lemon. Students, all of you know my lemon story, right? All of you know what is called lemon. All of you know why I call it lemon, right? There was a friend of mine, okay? There was a friend of mine. He's called as Aman, okay? And this person, okay, he could never say lemon. I don't know why, some weird accent he had, okay? So when we were in MSc first year, by mistake in front of us, boys, you know how we are. He's like, boys, all the boys, should we go drink lemon tea? I'm like, what is lemon tea? So this was happening probably 4 years back. From that time to till now, we always tell lemon as lemon. So it is fixed in my head. I don't know why. I can never say lemon now. I don't know why. Lemon, I will force myself to say lemon. But naturally, lemon comes to my mind right now. Lemon. Okay. So lemon is there. Then we have parietal placentation. So understand what happens in parietal. This is called as a parietal placentation, students. Okay. This is axial. We can see in axial, we can see the chambers can be here multilocular. We can see multilocular here, students. Okay. Multilocular, if you can be seen here. Okay. Now here we can see this is called as your parietal placentation. Now students, listen to me very carefully, all of you. Here, this parietal placentation, this parietal placentation is usually initially unilocular. Okay, initially it is unilocular here, unilocular. But later on what happens, understand students, later on what happens is that here we can see a formation of false septum here, false septum. The false septum is called as what? Replum formation can be seen here. So unilocular will become what? Unilocular will become bilocular. Bilocular, done. Replum formation happens, false septum formation happens here. False septum formation. So what is parietal placentation, students? Example, tell me. Parents are masters. Parents are masters. A for argemone, M for mustard. So argemone and mustard for parietal placentation. Okay. Now, next is called as free central. Here you can see free central placentation. Okay, free central placentation. Students, anyone whose name starts from F here? Anyone name starts from F here, students? Anyone's name from the F? No one, nah? No one. No one from F. Okay. Then I will tell you my example only. Fredo, change your DP. Fredo, change your DP here. Okay. So D is what, students? D for dianthus, P for primrose. Fredo, change your DP. DP is nothing but dianthus and primrose here. Now what is basal placentation, students? What is basal? Birds migrate south. Birds migrate south. Mustard and sunflower. Mustard and sunflower here. Mustard and sunflower. Flap duplessis, no? Flap duplessis. We can. Farhan is nice name, students. Franzo. Okay. Far duplessis, exactly. Far duplessis is there. Okay. Students, do you know which is my favorite cricketer? Have I ever told you who is my favorite cricketer? My favorite cricketer, students. Anyone of you know? And tell me, students, who is your favorite cricketer? Also tell me in the chat. Who is your favorite cricketer? See, mine is ABD. My favorite cricketer of all time is ABD. ABD and Sachin. All of you. Who is your favorite cricketer? My favorite cricketer is Mr. 360. Virat. Tala, Dhoni also obviously. Yes. Shreyas sir. Who's doing Shreyas sir? Who's doing Shreyas sir? Okay, not Shreyas sir. Okay. Shreyas Iyer. Shreyas Iyer. Okay, not Shreyas sir. Okay. Hardik Pandya, Shubham Gill, Virat. Crazy. Tala, Dhoni obviously. Someone to Shreyas sir. I'm like Shreyas Iyer. Okay. Okay. Dhoni, Virat sir. Okay. Cool, students. So all of you, I can see majority. I can see students. Majority of you can see, right? Majority I can see. Yeah, Dhoni and Virat Kohli. Yes. Yeah, Shreyas sir. Okay. Now, students, birds migrate south. Okay. So, students, remember, students, in the case of basal placentation, a single ovule is present at the bottom. A single ovule is present at the bottom here. Okay. Now, that is your placentation. That is your placentation. Okay, students. See here, in sunflower and marigold, placentation basal. Placenta develops at the base of the ovule here. Now, what is fruit here, students? Okay. What do you say, sir? Exactly. Okay. Fruit is mature or ripened ovary developed after fertilization. All of you know, fruit will develop into ovary, ovule will develop into seed. Remember that much. Okay. Now, there is something called as parthenocarpic fruit. Parthenocarpic is something what? Formation of fruit without fertilization. One scam is happening. Okay, scam is happening. Now, in mango and coconut, fruit is known as a drupe here, which develops from monocarpillary superior ovary. So remember this, students. Remember this much. Now, students, tell me in the chat. Can I eat the mango endocarp? Yes or no? Tell me, students. Exactly. Captain Shreyas became captain only. Okay, captain for a reason. Exactly. Okay, students, tell me in the chat. Can I eat the endocarp of your mango? Tell me yes or no. Can I eat the endocarp? Tell me yes or no. You're like, no, sir. It is called as stony endocarp. You cannot eat. So what do you eat nicely? We eat the mesocarp. We eat the mesocarp nicely. So coconut is mesocarp is fibrous, but in the case of your coconut, in the case of mango, it is fleshy. Okay. A seed is made up of seed coat. Seed coat has two parts, students. All of you know, testa and tegmen here, and embryo is there. Okay. The seed coat has two parts, testa and tegmen is there. Now, students, can you see here? This is a monocot seed here. In monocot seed, we can see, students, there is a single cotyledon here. There is a single cotyledon called as what? A single cotyledon called as what, students? Scutellum. Scutellum is the single cotyledon here. Scutellum here. And we can see here is the endosperm. This part, endosperm and endosperm in the embryo, they're separated by a protein layer called as aileron layer. And you can see, students, in the case of monocot, seed coat and fruit wall both are joined here. Both are joined or fused here. Okay. Now here, students, plumule has an outer covering or shield is here called as coleoptile. P and P here. Radical is covered by coleorhiza. R and R. Coleorhiza. R is there. Coleorhiza. Okay. Coleorhiza. Okay. Exactly. You get mango thing. Okay, students. All of you understood? So radical is coleorhiza, plumule is coleoptile. All of you remember that much. Remember that much. Okay. Now, in some seeds, such as castor, endosperm is formed as a result of double fertilization, and it is food for storing. Okay. So there is something called as albuminous, exalbuminous. What do you mean by, students? So albuminous means endosperm is present. Exalbuminous, endosperm is absent here. Okay. Students, tell me in the chat right now. Do you find endosperm in the case of dicot true or false? Do you find endosperm in the case of dicots generally true or false? Tell me in the chat. Students, I want to eat snacks now. All of you tempting me also. After this, I'll give you 2 minutes break to eat snacks. Okay. Students, tell me in the chat. In the case of dicots, do you find endosperm? Tell me true or false. Do you find? No. You don't find. Okay. So it is exalbuminous. But in the case of monocot, do you find? Yes. In the case of monocot, we find endosperm. In the case of monocot, we find endosperm is present in the case of monocot. Okay. Done, students. Done. Actually, the chapter is only over, students. Chapter is over actually. You can watch this chapter for morphology. That's only chapter. Nothing is there in morphology. Examples, I gave you tricks. Example, I gave you tricks, lot of tricks I gave you for examples. Remember what is albuminous, exalbuminous, set of examples, and you're good to go. Good to go. Okay. Now, students. Yellow, yellow, yellow. Yeah, all of us are back, I know. All of us are back. Biology, yeah, perfect, students. Yeah, biology, right? Crazy. Physics people, students, physics little, physics a little. We have a lifetime, enemy. Physics is one lifetime enemy for me. I don't know why. Okay, students, shall we start with the entire chapter of your anatomy of flowering plants right now, students? Shall we start? All of you. Can we start, students? Can we start? Yes. Bio and maths. Stay 1 kilometer away from me. Stay 1 kilometer away from me if you like maths. Huh? Physical education, my person. Physical education is the best. Go play football. Best thing in the world. Okay. Shall we start, students? Can we start? Can I get some fire emoji in the chat? Can I get some, who tells maths, students? Maths favorite subject. What is that? Exactly. Go play football. Have fun. Okay, students. Can I get some fire emoji in chat? All of you. I hope Shreyas sir doesn't see students. I have told Shreyas sir also. I have told Shreyas sir, how do you think of physics so much? I'm like, I cannot. Okay. Students, first things first in anatomy of flowering plants is going to be the meristem. It is going to be the entire meristem starting. Okay. So in plants, tissues are classified into two main groups. All of you know plants are divided into two main groups here. Meristematic and permanent. What is the main difference here? Understand, all of you understand, very simple it is. Meristematic tissues can divide, permanent cells cannot divide. In your terms, meristematic students who want to learn a lot, they're eager to learn. Permanent students, they don't want to learn. They're like, I will fail. Okay, so permanent tissues do not divide. Meristematic tissues, they will divide forever. Okay, based on whether their cells formed are capable of dividing or not. Okay, now understand, students, in the case of plant, there is something called as during formation of leaves, elongation, some cells are left behind, that is called as axillary bud. This I taught you in your morphology chapter also. Now, students, the meristem which occurs between mature tissue is called as intercalary meristem. So, students, there are multiple types of meristem also. So, as you can see, there is something called as primary meristem and secondary meristem. Now, students, tell me in the chat, which meristem will present in the young plants? Who can tell me, students, which meristem is found in your young plants? The meristem which is found in young plant is called as primary meristem, present from the beginning, responsible for the primary growth, like height of the plant, not weight, height of a plant to primary growth. Okay, it is present in both monocot and dicot. Now there is something called as secondary meristem. What is secondary meristem? It is formed later in the plant's life cycle, that is called as secondary meristem, responsible for secondary growth. Example, cork cambium and vascular cambium. Okay, it is found only in the case of dicots. If you think monocot has this, you're wrong there. Only in the case of dicot, and it is responsible for the increase in width of the plant. You might know big trunks. That is because of secondary meristem. Students, big trunks. Okay. Now, based on location, you have three types: apical meristem, intercalary, lateral meristem. Apical meristem is present where? Apical meristem is present at the growing tips here. Shoot and root. Present at the growing tips. Now, what is intercalary meristem? Intercalary meristem is present at the growing regions or between mature tissues, between mature permanent tissue. Intercalary meristem. What will you do, students? Intercalary meristem will increase the length of the internode. Now, students, if you were a cow, imagine you are a cow right now. What is your favorite food? Tell me, students, if you are a cow, what is your favorite food? Your favorite food is going to be a grass. So if a cow is eating a lot of grass, right, and you can see within 2 days, the grass is growing back again very fast. Why? Because the grass is able to grow very fast. Because why, students? Because of intercalary meristem. So intercalary meristem increases the internodal length in the case of grasses. Here. Remember that much also. Again, it is a type of primary meristem. Lateral meristem present at the sides here. You see, sides increase in the girth of the plant here. It is a type of your secondary meristem only in dichots. Done. Only in the case of dichots here. Okay. No. Next concept here. Done, 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 done. Okay. Now what about parenchyma here, students? One by one you learn about parenchyma. One by one you learn about parenchyma, students. Okay. Okay, students, tell me which is your favorite? What is your favorite, student? Tell me your favorite is parenchyma, collenchyma, sclerenchyma. Which one is your favorite? Tell me in the chat quickly. See, my favorite is collenchyma. Which one is your favorite? Students, tell me in the chat. Which one is your favorite? See, my favorite is always collenchyma. I'll tell you why also in the chat. Parenchyma is good. Parenchyma is average, but collenchyma superior always. Learn this, students. Learn this. Parenchyma includes isodiametric thin-walled living cells. Living cells without interstellar space here. While your collenchyma, students, collenchyma is also living. Collenchyma is also living. But it also provides, collenchyma also provides, students, collenchyma also provides mechanical strength, full strength it provides. Okay, so it is a layer below the epidermis in dicot plants. It includes thickened cells with depositions of cellulose, semicellulose, and pectin. I think I have a notes for that. Do I have though? Oh yeah, I have it. See here, students. So parenchyma is major component. This is what you have to learn. So in the case of parenchyma, it can help in storage, main function, photosynthetic in nature. That is, it can be called as chlorenchyma. It help in gas exchange, palisade parenchyma, help in buoyancy, that is aerenchyma, or even secondary in nature. This is your parenchyma. Now what about collenchyma, students? Collenchyma is living mechanical tissue. Living mechanical tissue it is. Yes, it is. Interstellar space is completely absent here. Cell wall is pectin deposits here. And again, students, functions you remember here. Functions. Mechanical strength, photosynthesis, elasticity. All the three are the functions here. Now, one thing you have to remember is that it's very selective in nature. Very selective in nature. Collenchyma will not be present everywhere. In fact, collenchyma is completely absent in the case of monocots. At the same time, it is completely absent in the case of roots also. In the case of dicots. So, where do you think we'll find collenchyma? Can anyone tell me? It is absent in monocot, not present in root of dicot. So, what are the locations we can find collenchyma? Anyone? Tell me, students, tell me. Can anyone tell me, students, where do you find collenchyma? Quick. DNA by student, welcome. Sclerenchyma because it's dead. Dark. Tell me, students, in chat. Tell me. See, it is not present in monocot. Okay. It is present in stem and leaf. Very good. It can be present in stem and leaf. See, all of you know petiole, right? Let's say this is one leaf. Leaf will flutter in right. A leaf will flutter right. A leaf will flutter. Why? Because it has petiole, right? Petiole is made of collenchyma. That is why a leaf can flutter in the wind. The young stem is very flexible because of collenchyma. Students. Okay, stem and leaf. Now, what about sclerenchyma, students? Dead person. This is dead person. Okay, so sclerenchyma is simple dead tissue without protoplasm here. Provides mechanical strength, mainly mechanical strength, students. Living depositions can be here. Function, there can be two types, fibers and sclerites. Fibers are much more elongated here. It can have pits here, but sclerites are completely covered here. They're completely covered here. Now, students, understand this sclerites as well as your fibers, right? They will have something called as pits. Can all of you see here, students? If this is your entire deposition, right? Entire deposition in the case of your cell wall here, there are certain small gap here. These gaps are called as what? Pits. Pit stop. They're called as pits. Someone is saying leaf stalker. It's called leaf stalk, not leaf stalker. Okay, I read it wrong. Sorry. I think I read it wrong. Okay, so leaf stalk. Yes, leaf stalk is present. Petiole. Just tell petiole, no, students. Why are you telling me leaf stalker? Just tell petiole. Okay, it's present in petiole. Collenchyma is present in petiole. Okay, these are called as pits here. Now they can ask you a question: where do we find sclerites? Where can we find sclerites here? Understand, students. Understand, all of you. Okay. It can be found in your fruit walls of nuts, fruit pulp, guava, and pear. some seed coats of legumes and tea leaves also. So all of these are locations where you can find sclerets. Remember that much. Okay. Done. Sclerenchyma consists of long, narrow cells with thick and lignified cell walls having few to numerous pits here. Few to numerous pits here. Okay. Now, students, what about complex tissue? Understand what is complex tissue. A complex tissue can have many different types of cells. Give me an example, students. Can anyone give me an example? Can anyone give me an example, students? Can anyone give me an example of a complex tissue? Anyone? Give me an example of complex tissue. You will tell me, sir, complex tissue example, xylem and phloem. Now, all of you know, students, is xylem made up of only one type of tissue? No. You have xylem parenchyma, xylem fibers, tracheids, vessels. There are multiple types. What about phloem, students? Phloem also has something else. Phloem has something called as your phloem fiber, phloem parenchyma. Yes, companion cells, sieve cells. There are multiple there. So, xylem and phloem can have multiple different brother and sister. Okay, different brother and sister. That's called. It's called as complex. That's what's called as complex. Okay. Now, here I have written main points which you have to remember at any cost. Main points is that gymnosperms lack vessels in their xylem. Very important point here. This is a PYQ right here. This is a PYQ here. Okay. The presence of vessel is a characteristics of your angiosperms. Done. In flowering plants, tracheids and vessels are the main water transporting elements. So if they ask you in xylem, what is the main thing? Main thing is going to be tracheids and vessels. The first formed primary xylem element is called as protoxylem. Protoxylem is the first formed. Metaxylem is later formed. Okay, metaxylem is later formed here. Okay. Now, students, in roots, protoxylem lies towards the periphery. Students, I'll tell you a small trick here. Remember, students, I'll tell you a small trick here. Okay. I'll tell you a small trick here for X-arch. X-arch can be remembered by RX bike. All of you know what is RX bike? All of you know what is RX bike, students? Tell me, students. All of you know what is RX bike? Yes or no, student? Tell me. Yes. See, RX here is nothing but R for root here, X for X-arch here. Okay. Now, X-arch is found in your root here. Now, students, you tell me, a person who is X, will they be in your life or out of your life? If they're in your life, that is very toxic again. If they're in your life, it is very toxic. Okay. So, if the X means what? Out of your life. So, remember, students, X is supposed to be outside. So, protoxylem is supposed to be outside here. So, in roots, protoxylem lies towards the periphery. Periphery means outside. Yes, RX100. Very crazy bike it is. Crazy bike. Okay. So, protoxylem lies towards the periphery or outside. So, roots, X-arch on the outside. Okay. Not inside, out of your life. Okay. So, periphery. Metaxylem lies towards the inside. Okay. That is called as X-arch. So, end-arc will be opposite, obviously. End-arc is going to be opposite. In end-arc condition, what happens? In end-arc condition, protoxylem is on the inside, metaxylem on the outside. Simple as that. So, remember X-arch, you can opposite for end-arc. End-arc can be found in your stem here. End-arc can be found in your stem, X-arch, root. All of you remember, students, all of you remember that. Tell me, students, all of you know. All of you remember that, students. All of you remember, right? X-arch in the case of root, protoxylem towards outside, periphery. Done. Here. This was a very important function. Phloem in angiosperms is composed of sieve tubes element, companion cells, phloem parenchyma and phloem fiber. The function of sieve tubes are controlled by companion, see, controlling partner, very controlling partner, because this partner here does not have any brain cell. I mean nucleus is not there. Okay. So this sieve tubes does not have a nucleus. It does not have a nucleus of its own. So what happens? This companion cell, the companion cell will control the function here. All of you got the concept? No? Got the concept here. Okay. The companion cell are specialized parenchyma cells which are closely associated with the sieve tube elements here. Right. The sieve tube elements and companion cells are connected by pit fields present between them. So they have a connection between them. Okay. Now, This is also very important line here. Companion cell help in maintaining the pressure gradient. So I told you, right? Companion cells help in maintaining the pressure gradient in the CO tubes. So this is the function here. This is the function I'm telling you. This is the function I'm telling you right now. Done, students? Now, this also is very important line here, students. Phloem fibers are made up of scleron gameta cells. Okay. Done. I don't think anything is there. Now, they can ask you what is lateral meristem. They can ask you, students, what is lateral meristem? Students, understand. The lateral meristem is nothing but lateral meristem. We have three types. We have interfascicular, and corcamium. Three types of lateral meristem. Done, students? Done. Now we come to the next topic called as your epidermal tissue system. In epidermal tissue system, there are three categories. Outer epidermis, there is something called as guard cells, a part of stomata, and then there is one inner side is called as your, there is also trichomes also there, trichomes is there. Okay, so if you look on the outside of the epidermal, there is something called as epidermal appendages. There is something called as root hair and trichome. Root hair is exogenous unicellular. Trichome is stem hair, multicellular, unicellular, both can be there. Function is what, students? It can be found in the mature region. I told you beard we can find, mature region we can find. Trichomes are, they help in decreasing the water loss. It can be tough and soft, septate, aseptate, or secretory in nature. Now, students, now what about your epidermal cell? This is the outermost cells here, Single layer. Parenchyma in origin. Chloroplast is absent here. Waxy layer, it can have a wax layer on top of it, cuticle. Now, then there is something called as stomata here. Now, students, can anyone tell me? I told you epidermal cell. Do not have any chloroplast. I told you here, students, epidermal cells, chloroplast is absent here, except at one point. In epidermal cell, chloroplast is absent, but except one part, that is called as stomata. So in the stomata, we can find chloroplast. Now, students, in this stomata, we can see there is something called as your large bodyguards here. Who is the bodyguard here? Bodyguard is called as guard cells. Bodyguard is called as what, students? Guard cells here. Okay, guard cells here. Now, students, apart from that, here we have inside we have stomatal pore, also got a stomatal opening here. Now, around the guard cells, we can see, students, there is something called as subsidiary cells. These are called as what? Subsidiary cells here. Now, always remember, students, in the guard cell, what happens is the inner part is what? Inner part is much more thicker. Outer part is going to be very thin. Okay. Now, students, see this. Now, here, this subsidiary cell plus stomatal pore plus the guard cell, stomatal pore as well as the subsidiary cell, all three together is called as stomatal apparatus. It is called as what, students? Stomatal apparatus. It's called stomatal apparatus. Okay, stomatal apparatus, students. I have to slow down a bit. Okay, I'll take a little breathe. Okay, it's called as what? Stomatal apparatus here. Okay, now, students, the main question which they can ask you here is, students, what is the guard cell shape? Okay, what is the guard cell shape? Now, in the case of monocot, what is the guard cell shape? Can anyone tell me? In the case of monocot, what is the guard cell shape? Anyone can tell me? In the case of monocot, it is dumbbell shape. Okay. In the case of dicot, it is bean shape. It is going to be bean shape. Okay. Okay, students. Understood? Yes. Now, then there is something called as vascular tissue system. And this is very small concept. Okay. Very small concept you understand here. Okay. Vascular tissue system can be arranged in two categories. One is called as radial. It's like a pizza only. Radial arrangement, conjoint arrangement. What is radial? In the case of radial arrangement, what happens is that xylem and phloem are present in alternating manner, and xylem and phloem are present in their own radii. That is called as radial arrangement. What is conjoint, students? Conjoint is like a sandwich, which I just ate right now. Okay. What happens in conjoint, students? In the case of conjoint, xylem and phloem are present together. When xylem and phloem are present together, it is called as conjoint here. Now, radial is found in the case of root here. Conjoint is found in the case of leaf and stem here. Now conjoined can be of two types. Bicollateral, you don't have to worry students. Understand what is collateral. In the case of collateral, what happens is that, can you all of you see the xylem here? Students, is the xylem visible? Students, is the xylem visible? Don't tell me in the chat. Now here understand, if xylem is present towards the pith, if xylem is present towards the pith, it is called as collateral. Collateral. Xylem is present towards the pith is called as collateral here. Collateral, students. Okay. Now, what about open and close? Understand, students. What is open? Open and close. If between xylem and phloem, if there is a cambium is present, xylem and phloem, if cambium is present, that is called as open. And if there is a cambium, it can show secondary growth. And it is found only in the case of dicots. Only in the case of dicot. And in dicot also, only in the case of root and stem. Leaf, you cannot show. Now, what is closed here? Means closing the door. Okay. In closed, no cambium, no secondary growth. No cambium, no secondary growth. And at the same time, students, this can be found in the case of leaf and monocot. Leaf and monocot. Done. Leaf and monocot, students. Any doubt here, students? Anyone, any doubt? Let me look at the chat. Let me look at the chat, students. Let me look at the chat. Any doubt here, students? Should I explain anything one more time? Tell me in the chat. Do you need any concept to be explained again? Ask me, students. See, I am a teacher who will never say no. Quick. Any doubt here, students? Radial, same, it has one radii. Conjoint, present together. Collateral, xylem is present towards the pith. Okay. Yeah, closing the door. Clear, students? Clear? No. If you say, students, ask me, it's fine. What is there to be scared? I will not scold you. Noise. Students, I can't believe all of you are awake still now. All of you understood, students? Rain stopped here, students. Rain stopped here. And the worst part is, when the rain stops, right, inside becomes much more hotter. And I feel I'm sitting in an oven right now. I'm becoming one chicken, I'm roasting now. Okay. Now, students, today I won't be teaching you everything in detail for anatomy. In anatomy right now, what I'll be doing is, I have given you important points which you have to remember. See, always how do I teach anatomy is with the help of diagram. But today I'm giving you important points which you have to remember. Okay, students, see these important points right now. Okay. See, from here, all the important points arises, and all of these important points can be asked as a PYQ also. Okay. So, collateral explain again. Understand, Angeline. In collateral, what happens is, understand, students, all of you. In collateral, what is happening is very simple. See, here I told you, students, in conjoint I told you, what did I tell in conjoint? Xylem and phloem are present together. That is conjoint. In collateral, what is happening is, see, all of you can see, xylem and phloem are present together inside. Xylem and phloem are present together. But here what happens is, students, xylem is present towards the center. When xylem is present towards the center, that is called as collateral. See, xylem is present towards the center, phloem is away from the center. That is called as collateral. Okay. Now, students, see, the innermost layer of the cortex is in dicot root is called as endodermis. And endodermis, in the case of dicot root, endodermis is a single layer of barrel-shaped cells without any intercellular space. Barrel-shaped cells. So, if they ask you a question, where do you see a single layer with barrel-shaped cells? Answer should be dicot root. Okay. Now, students, the tangential wall as well as radial wall of endodermis in cortex have deposition of water impermeable substance called as superindeposition. So, if they ask you a question, in which part of the plant root can I see superindeposition? What will be your answer, students? Tell me, students. What will be your answer? Tell me, students, in the chat. Which part of the dicot root has subarine deposition? What is your answer? Answer should be endodermis. Answer should be, students, what? Endodermis. Endodermis has subarine deposition. It has subarine deposition in the form of Casparian strips. So, in the form of Casparian strips, we can find subarine depositions in the endodermis. Okay. Now, in dicot root, the parenchyma cells which lie between the xylem and phloem are conjunctive tissue. So, between the, let's take this is the tissue here. We can see xylem phloem here, xylem phloem. Between xylem and phloem, we can see something called as conjunctive tissue. We can see something called as conjunctive tissue can be found there. Okay. Now, dicot roots have around 2 to 4 xylem bundles here. Only 2 to 4. In the case of dicot, 2 to 4 xylem bundles. Okay. All tissues on the inner side of the endodermis, such as pericycle, vascular bundles, and pith, constitute the stele. They make up the stele here. So, what is stele, students? Stele is nothing but pericycle plus vascular bundles plus pith is called as stele here. Stele here. Now, students, if in the case of, let's say, in your examination, they are asking you to identify the plant part, and if you hear a word called as a polyar condition, what is your answer, students? Tell me in the chat. Trichomen, I'll tell you what is trichomen here. Students, tell me in the chat. Students, can anyone tell me what is the organ which is the part I'm trying to discuss? If I talk about polyar condition, what is your answer, student? Tell me in the chat. Polyar condition can be found where? Anyone? Polyar condition can be found in the case of anyone? Polyar condition. Polyar condition can be found in the case of monocot root. So that is a clue here. So if there are usually more than 6 xylem bundles, that is called as polyarc condition. Polyarc condition can be found in the case of monocot root. This is the main difference. This is the main difference between polyarc is nothing but 2 to 4 xylem bundles in the case of dicot. In the case of dicot, but in the case of monocot, what happens is that I'll show you the NCI diagram. One second, students, give me a minute. I will show you the NCI diagram for this. Students, is the board visible to all of you? Is the board visible to all of you, students? Tell me in the chat quickly. Students, quickly tell me in the chat, is the board visible to all of you? See here. You can clearly see here, students, in the, see, this is your monocot root, dicot root. In the case of dicot, it's a dicot, monocot. Okay. In the case of monocot root, all of you can see this is called as xylem bundles. Xylem bundles. So if there are more than 6 xylem bundles, it is called, students, what? Polyarch condition. See here. Polyarch condition, more than 6. This is the main line where they can trap you. Students. Okay. Okay, students, that is very important here. One more thing which they can ask you here is, in the case of dicot root, they can ask you this pericycle thing. Now, what is the main function of pericycle, students? Main function of pericycle is that initiation of lateral roots and vascular cambium during the secondary growth. That is for pericycle. This you have to remember for pericycle also. In the case of dicot root, you have to remember this pericycle also. Okay. Now, students, now what about your stem right now? What is important in stem? For example, students, all of you tell me in the chat, students, all of you tell me in the chat. In the case of stem, do I find collenchyma? Tell me yes or no in the chat. Do I find collenchyma in the case of stem? Do I find collenchyma? Students, quickly tell me in the chat, in the case of your stem, do I find collenchyma? So what? If it is 130, then so what? Yes, we do. Yes, we do, students. We find collenchyma in the case of your stem. Okay. So outer hypodermis consists of few layers of collenchyma cells just below the hypodermis. Okay. Mechanical strength in young dicot stem, can you see here? Now, I told you in the case of dicot root, suberin deposition in the case of endodermis. Now, what is so special about your dicot stem? This is what? The cells of the endodermis of where? Of the dicot stem right now. Dicot stem will have what? Something called as starch grains, and layer is also referred to as starch sheath. Very important line, very important line. Now students, a large number of vascular bundles are arranged in the ring. So this can also be called as your ring arrangement, is also a characteristic feature of your dicot system. Ring arrangement can be seen here. Okay. Students, apart from this, see students, your anatomy cannot be justified with few lines, students. Students, I will tell you one thing, students. For anatomy, right? For anatomy, I think you should watch this lecture better. For anatomy, you should watch this lecture better because anatomy cannot be taught without diagrams. I forgot to add diagrams. That's why I cannot teach you anatomy right now. I would suggest all of you to watch anatomy, this video here, right here, in 3D, which I've showed here, right? So watch this video for anatomy where I've discussed with help of diagram. Without help of diagram, it becomes very difficult to teach anatomy because you need to know what is happening in every layer. Endodermis, what happens in the case of your leaf, what is palisade, what is spongy, that becomes very difficult. It becomes very difficult. So this you can't do. Okay. So for this, you have to watch this lecture, students, for anatomy. Otherwise, it becomes very difficult to do anatomy. Okay, students, but we'll focus on cell chapter now. Okay, cell chapter is easy right now. Okay, students, I'm not feeling sleepy, you're feeling sleepy. Okay, now students, said you got dandruff. Why will I have dandruff, students? I wash my hair regularly. Why will I get dandruff? Okay, now students, cell unit of life. I will ask all of you some questions. Let's see how many of you can answer. Ready for rapid fire? Students, all of you ready for some rapid fire? All of you ready for rapid fire? Let me teach you some questions with the help of rapid fire now. No, we have to finish now only. Ready for some rapid fire? Okay. Students, who gave cell theory? Quick answers. Who gave cell theory? Scheiden and Swan. Cell theory was given by Scheiden and Swan. Okay. Then came one more scientist who modified the cell theory. Who was the students? Which scientist modified the cell theory? The cell theory was modified by whom? The cell theory is modified by Rudolf Virchow. Rudolf Virchow modified the cell theory. Now students, again, who discovered the living cells? Who first observed the living cells, students? Who first observed the living cells? Quickly, students. Janani, you watched a lecture on anatomy. Okay. Who discovered the living cell? You will tell me, sir. Antony von Leeuwenhoek. Who discovered the dead cell? Who discovered the dead cell, students? Robert Hooke discovered the dead cell. Done. Okay. Who discovered the nucleus? Who discovered the nucleus, students? Quickly in the chat. The nucleus was discovered by whom? The nucleus was discovered by Robert Brown color. Okay. By Robert Brown. Again, students, this chapter is very simple, very easy. Okay. So cell is the fundamental function unit of life. All of you know that. Antony von Leeuwenhoek discovered the first living cell. Robert Brown, nucleus, done. Scheiden and Swan together formed the cell theory. Then came Rudolf Virchow, who told that, wait a minute, I will tell you something special. Rudolf Virchow told us that cells come from the pre-existing cells. That is called as omnicellular unicellular. Now together they gave the cell theory. Together they gave the cell theory. What is cell theory, students? What is cell theory? Cell theory tells you that. Cell theory tells you that animals and plants are made up of cells and product of cells. So understand, cell theory is nothing but animals and plants. Animals and plants are made up of cells and product of cells. This was your main cell theory. This was the main cell theory, students. Okay, this is the main cell theory. Okay, now students, now can anyone tell me which kingdom comes under Protista? Which kingdom comes under Protista? Which kingdom has only prokaryotic cell? Which kingdom has only prokaryotic cell? Anyone in the chat? So all of you know, students, there are two types of cell: prokaryotic, eukaryotic. Prokaryotic cell is very, very primitive, does not have any membrane-bound organelles, does not have a nucleus, does not have mitochondria, nothing, very primitive. While your eukaryotic cell has membrane-bound organelles here, it has nucleus, it is advanced here. Whereas your Prokaryotic cell lacks something called as nucleus and membrane organelles. So here, students, prokaryotic cell can be found in the case of kingdom Monera. Protista, fungi, plantae, animalia, all of them you can found in the case of eukaryotic cell. Eukaryotic cell, students. So again, I have one more question to all of you. In our body, do we have prokaryotic or eukaryotic cell, students? In the chat, who can tell me? In our body, do we have prokaryotic or eukaryotic cell? You tell me, sir. In our body, we have eukaryotic cell. Done, students. Done. Now, students, I told you, in the case of eukaryotic cell, there is membrane bound organelles are present. But is there any exception here, students? Is there any exception that there is one cell, one organelle in the case of in the case of eukaryotes, one organelle in the case of eukaryote which does not have any membrane? Can anyone tell me, students, is there any organelles which does not have any membrane but they are part of eukaryote? There are two of them. Students. One is ribosome, other one is what? Centrosome. Ribosome can be found in your plant cell, animal cell, while centrosome can be found only where? Centrosome can be found only in your animal cell. So ribosomes are non-membrane bound organelles found in all cells, and centrosome can be found only in the case of animal cell. Okay. They can ask you the shape also. They can ask you shape of bacterium, they can ask you shape of mycoplasma, they can ask you shape of your size of mycoplasma, size of RBC, size of your bacteria. Learn that also. Learn the different sizes. Okay. Now, students, see here, eukaryotic cell is around 10 to 20 micron. Virus is around 0.2 to 2 micron. Okay. Now, students, this is your entire prokaryotic cell. Now, students, I want all of you to understand. I want everyone to understand here a very simple fact here. Okay. Now, how many layers do a eukaryotic cell have? So, a prokaryotic cell have. Can anyone tell me in the chat how many layers are present in a prokaryotic cell? So, if you see a typical prokaryotic cell, it has 3 layers. Here, all of you can notice here is that there is the outermost layer here. All of you students who can tell me which is the outermost layer here? The outermost layer here right now here, students. Anyone? The outermost layer is what, students? The outermost layer is the glycocalyx 1. Now, this glycocalyx can be in the form of loose sheet or thick layer. When it is form of loose sheet, it is called as slime layer. When it is thick and tough, it is called as capsule. So, capsule done, loose sheet done. Now, what is the second layer, students? Who can tell me what is the second layer, students? The second layer is what, students? The second layer is called as cell wall here. Now, the cell wall is made up of what? Cell wall is made up of peptidoglycan here. Now, this peptidoglycan, what is it made up of? It is made up of Nag and Nam. Now, students, what is the innermost layer? The innermost layer is called as cell membrane or plasma membrane, which is selectively permeable in nature. Students, I want everyone to keep typing in the chat. Okay, it is going to be cell membrane or plasma membrane, it is given here. Now, students, if the bacteria or this prokaryotic cell, if it has to show motility, students, it needs something, no? What does it need? It needs a tail. The tail here is flagella. So you can see a flagella also here. Flagella can be seen here. It can also have something called as pyleofimbriae, students. Pyleofimbriae main work is attachment here. Okay. Now, students, inside part is called as cytoplasm. In the cytoplasm, students, do you think we have ribosomes here? Yes, we have ribosomes here. Now the question is, students, is the ribosome 70s or 80s or 90s? Students, who can tell me? Here, ribosome is 70s, 80s or 100 years. Let me students in the chat. It is going to be what? 70s ribosome. 70s ribosome can be found here. Okay. Now, students, all of you can notice also here that this inner part called the cell membrane, right? It has foldings here. The foldings or extension of cell membrane is called as mesosome here. It's called as mesosome. Similar to mesosome, there is also one more extension here, but this extension has pigment here. It's called as chromatophore. It is called as chromatophore. Both are different students. Both are different here. So chromatophore is present in the case of blue-green algae. Main function is storage. Nicely storage it will do. Okay. This is mesosome here. Now students, tell me in the chat right now. Do you find nucleus in the case of prokaryotic cell? Tell me yes or no. Students, tell me yes or no, students. Do you find here in the case of prokaryotic cell, do you find nucleus? You're like, no sir, no, we do not. No sir at all, not found. So if there is no nucleus here, all the genetic material is free floating. So we can see here, all the genetic material is free floating here. All genetic material free floating here. And the genetic material here is called as nucleoid. It is called as nucleoid here. No nuclear envelope here. That is the entire cell here. So outer layer glycocalyx. Second is called as your cell wall, cell membrane, flagella for movement, fimbria for attachment, pili for attachment, nucleoid genetic material, mesosomes, chromatophore, ribosome. Apart from the students, we can see some form of vacuoles here, some form of inclusion bodies, not vacuoles, inclusion bodies can be seen here also. Okay, students. No, here. Now students, they can ask you what is the function of mesosome also. They can ask you what is the function of mesosomes. Learn that also. Distribution of daughter cells, help in increasing surface area, helps in your cell wall formation, helps in respiration. All that you have to remember. It will help in cell wall formation. All that you have to remember here. Okay. No students. Now apart from the students, apart from this, in this bacteria, right, there is one circular DNA, students. Does anyone know what is it called as? Does anyone know what is it called as here? Here in this entire cell here, there is something called as round color structure called as extra chromosomal circular DNA. What do you call that, students? What do you call that? Can anyone tell me? There is something called as extra chromosomal circular DNA. What do you call that, students? It is used in your genetic engineering. We can cut it, join something there. It helps as a vector. It can be used as a vector, students. That is called as a plasmid. There can be a presence of plasmid also here in the case of your cell here. Okay, plasmid can be seen here. Okay, and the DNA, students, remember students, your genetic material is double-stranded, straight or circular. Double-stranded DNA can be found here. Double-stranded DNA can be found here, circular or linear. Okay. Capsule, slime layer done, cell wall done, chromatophore done. Done. Students, remember students, here what happens is the entire flagella has three parts: basal body, hook and filament. So the flagella can have three parts: basal body, hook and filament. Okay, basal body, hook and filament is the entire structure of your what? Flagella here. Okay, flagella and filament. Now students, ribosomes can be here. 70s ribosome we can find. 70s ribosome can be divided into 50s plus. Tell me students, how is ribosome here? 50s plus what? 50s plus? Tell me students, how is the ribosome here? How is the ribosome here? Tell me students, click in the chat. How is the ribosome here? Who can tell me? How is the ribosome here, students? 50 and 20 here. 50s and 30s. Very good. 50s and 30s. Now, what about in the case of eukaryotes? It is called as ATS. In the case of eukaryote, it is called as ATS. Eukaryote, it is ATS. What is ATS made up of, students? 60 plus? 60 plus? Who can tell me? 60 plus 20 or 60 plus 20? No. 60s plus 40s is made up of eukaryotic cell. 60 plus 40 in the case of eukaryotic cell. Remember that much. Okay. Large subunit, small subunit. Okay. Now what happens, students? Understand. Let's take, I have one mRNA here. Large mRNA. Okay. Now on this mRNA, if I have a lot of ribosomes, I have one mRNA, I have a lot of ribosome. This structure is called what? This structure is called as polyribosome. Polyribosome or polysome, also called as polysome. So polyribosome or polysome can be called as. Done. Done. That is the one more thing. Now students, there is something called as inclusion bodies. Inclusion bodies. Inclusion bodies is nothing but it is a storage unit. Here students, in inclusion bodies, all of you have to remember about syrophysan granules, right? All here the main thing they can ask you is the gas vacuole. Can anyone remind me, students? Can anyone remind me? This gas vacuole can be found in which bacteria or which organism? Gas vacuoles can be found as a type of your inclusion body in which of the following? Which of the following organism? Anyone who can tell me? Anyone? It can be found where? Gas vacuoles can be found in the case of green and purple sulfur bacteria. Green sulfur and purple sulfur bacteria, we can find the gas vacuoles. We can find the gas vacuoles. Okay. Type of inclusion bodies. Okay, students. Now what about your lipid bilayer, students? What is lipid bilayer? Understand, students. Now all of you remember, students, all of you remember, right? Who is the ultimate inspiration of your lipid bilayer? Who is the ultimate inspiration of lipid bilayer, students? Who can tell me quickly in the chat? Who is the ultimate motivation for lipid bilayer? Quick. Anyone who can tell me quick in the chat? Yes. It is going to be students what? It is going to be our Indian roads. Exactly. It is going to be our Indian roads. So this is like an Indian road. Can you see all of you? It is like an Indian road. This is a lipid bilayer. This is a lipid bilayer. In a lipid bilayer, students, there is something called as obviously no, tell me in the chat. Tell me in the chat. All of you in the chat quickly. Is my audible back? Is the audio back? Yeah, is the audio back? Students in the chat quickly. Is the audio back in the chat? Voice isn't voicing. Is it back, students? Is it back? Yes. Students, voice is back, huh? Perfect, students, perfect. Okay. Now, students, exactly, something or else will happen today. Okay. Now, students, this is like your Indian road. Can all of you see here? Yes, you can see, students. Now, what happens is, what is lipid bilayer made up of? Understand, lipid bilayer is made up of lipids, obviously. It is made up of cholesterol. It is made up of proteins. It is made up of water in general. Okay. Now, can all of you see, students, these are called as your lipids here. These are called as proteins here. Now there are two types of proteins here. There is something called as two types of proteins. Can you see here? Carbohydrates also here. Carbohydrates here. There are two types of proteins here. One is called as, students, one is called as your how do I say this? How do I see this? Let's say this is one lipid bilayer. Let's take I have a lipid bilayer here. Okay. Now let's take one protein is completely on the inside. It is completely on the lipid bilayer inside. This part is called as what? This type of protein is called as intrinsic protein or integral protein. It is called as what? Integral protein. Why? Because it is very difficult to remove. Very difficult to remove, students. Now, students, one protein is present on the outside. One protein is present on the outside. This is called as very easy to remove. Very easy to remove. This is called as extrinsic protein or peripheral protein. Peripheral protein. So all of you can see here, intrinsic on the inside, extrinsic on the outside. On the outside. Again, you can see intrinsic protein here. Okay. So this is called as your lipid bilayer. This is called as what, students? Lipid bilayer here. Okay. Lipid bilayer. Okay. Lipid bilayer. Now, students, one more question arises. One more question, students. You can see here in this lipid bilayer, all of you can see, students. Okay, students, in this lipid bilayer, all of you can see there is something called as phospholipid. Now, can anyone tell me, which I have to teach you next chapter, which phospholipid is present here? Anyone who can tell me which phospholipid is present here, students? Anyone? Who can tell me, students? Friends, I will teach you plant physiology. Wait, no. Without teaching this, how can I go to plant physiology? Tell me, students, which phospholipid is present here? Lecithin is present here, lecithin. If you see a phospholipid bilayer, it has something called as a polar head and a non-polar tail. Can you see? Polar head and non-polar tail can be seen here. Polar head and non-polar tail. This non-polar tail is hydrophobic in nature. Like, I don't want water. This is hydrophilic in nature. It loves water. It loves water. This is how they can be arranged. This is how they can be arranged here. Now, usually what happens is polar molecules cannot enter inside. Polar molecules cannot enter inside at all. Why? Because of the tail inside. Because of the tail. But water can inside. Even though water is a polar molecule, it can still enter because it has a special entry. It has something called as very special entries there. Okay, because of aquaporins. Because of aquaporins. See here. This entire model was given by Singer-Nicolson in 1972. Quasi-fluid means what, students? Quasi-fluid means it is going to be liquid and solid at the same time. Okay. Now, students, now. There is something called as transport. Passive transport, neutral transport, active transport. Students, understand all of you understand, students, what is going to be your passive transport right now. So, students, do you go in bus? Tell me, students, do you go in bus? All of you go in bus? Yes, you have gone in bus. So, when you try to go in bus, students, what happens is if the bus is very crowded, you don't have to put any effort into going into the bus. You just go stand there. You go stand there, students. Automatically, everyone will push you. They'll push you, and you'll go inside the bus. That is called as a passive transport. There is no ATP along the concentration gradient. From the inside the bus, it's empty. Outside the bus, lot of people are there. So, from lot of people to inside the bus, along the concentration gradient, high concentration, low concentration. Passive transport. Now, understand, students, what is going to be active transport. In active transport, what happens is that here, what happens is, students, you cannot enter as such. You cannot enter as such. You need someone's help here. The helping person is going to be whom, students? Helping person is going to be carrier protein. So, polar molecules cannot cross. Polar molecules cannot cross at all. Not possible at all, students. Tirupati line also, exact Tirupati line also, right? Here what happens? Polar molecules cannot cross on their own. This polar molecules will call a best friend. The best friend is called whom? Carrier protein. So, this carrier protein will be like, I need ATP, I will take you inside. So, it will take ATP, it will go inside. Okay. So, it will go from low concentration to high concentration. It is going to be against the gravity. It is going to be, students, what? Against the gravity, students. Against the gravity. Okay. So, against the concentration gradient. Now, here a passive transport example is osmosis, the example here. Now, cell wall, students. All of you, there is something called as primary cell wall on the out, secondary cell wall on the inside. So, always remember, students, primary cell wall is present on the outside. Inside we have secondary cell wall always. Now, students, let's take, I have one cell here and one cell here. And we have, let's say, cell wall also here. We have the cell wall here. Cell wall. Now between the two cells, students, between the two cells, there is something present in the right in the middle. Okay, there is something called as middle lamella. Middle lamella. Can anyone tell me what is it made up of? What is middle lamella made up of, students? Can anyone tell me what is middle lamella made up of? Anyone? So middle lamella is made up of nothing but calcium pectate and magnesium pectate. It is made up of calcium pectate and magnesium pectate here. Magnesium pectate. Okay. Now students, what happens? Imagine the cytoplasm of this cell and cytoplasm of this cell. They are connected to each other. The cytoplasm of this cell and cytoplasm of the next cell, they are also connected to each other. What do you call that? Can you even tell me? That is called as what? Plasmodesmal connection. That is called as what? Plasmodesmal connection. Okay. That is called as cytoplasmic connection right in the middle. It is given somewhere here. I think I mentioned it. See here. The middle lamella is the layer chiefly present bit made up of calcium pectate and which glues neighboring cells together. Okay, together. And also plasmodesmata connect the cytoplasm of neighboring cells. Cytoplasm is connected because of plasmodesmata. Because of plasmodesmata, students. Okay. Now students, next thing is called as endomembrane system. Okay students, all of you know, all of you have a gang in your school. Yes, you have a gang. So inside the cell also there is one small gang here. The gang name is called as endomembrane system. Now in endomembrane system there are 4 organelles here. Who can tell me the organelles and who can give me the, how do you remember them? So all of you know, there's a small trick which I always know, which I always tell every gamer loves victory. Now E for endoplasmic reticulum, G for Golgi complex, L for lysosomes, V for vacuoles. These 4 of them are what, friend? They are part of endomembrane system. Why? Because their functions are coordinated. All of their functions are connected to each other. Okay, that is because they are called as endomembrane system. Now, the first one is called as ribosome. Here, the only thing you have to remember here is that if it has ribosomes, it is called as RER. And RER will do what, students? RER will produce what? RER will produce proteins generally. Proteins. Now, what about SER? SER will not have any ribosomes. It will produce lipids. Here. Okay. And also remember, students, one entire endoplasmic reticulum, it can divide the entire cell into luminal and extraluminal. For example, this is your nucleus. Here we have the ER. Let's take, we have ER here. Endoplasmic reticulum is on top here like this. This is the ER here. Now, whatever is present on the inside is called as what? Luminal. Present on the outside, this part, the outer part, this outer part, students, this outer part is called as what? Extraluminal. This outer part is called as extraluminal. On the inside is called as luminal. Okay. Now, Golgi complex you understand, students. Golgi complex you understand. Very simple. Golgi complex, Camillo Golgi discovery. It is a flat disc-shaped structure. Students. Okay. Now, all of you need to understand here is that a Golgi complex has 2 phases. It has 2 phases. Unlike some people are there in life. No. It has 2 phases here. Now, what are the 2 phases here? Understand, students. One is called as your cis phase on the inside towards the ER. This is ER, endoplasmic reticulum. Towards the ER, we have the cis phase, also called as convex phase or forming phase here. The opposite one is called as what? Trans phase or concave or maturing phase. So cis phase, trans phase. Cis phase and trans phase, students. Now I want all of you to tell me, students, from which side will the molecules enter? All of you in the chat. From which side will the molecules enter inside the Golgi complex? Because in Golgi complex, the main function is packaging. You will nicely package and send it back. So tell me, students, in the chat, from which phase will the entry happen? Cis or trans? Always remember, students, always remember the entry point is always on the cis phase. Cis phase or forming phase or convex phase, the entry happens. Now, if it is entering here, packaging, and finally exit. Exit part is called as what? Maturing phase. It is called as what, students? Maturing phase. Cis phase is entry. Outside part is called as maturing phase. Very simple. See here. Outer part is called as what? Trans or maturing phase. Okay. Now let's. Now, what does it produce? Golgi complex is important site for formation of glycoproteins and glycolipids. Both of them are produced by your Golgi complex. Here, students, remember this protein is coming from RER and this lipid is coming from SER. Simple as that. As simple as that. All of you remember, students? All of you remember that? Tell me yes or no in the chat. All of you can remember. Glycoprotein and glycolipids are produced by your Golgi complex. Packaging is done by Golgi complex. Done, students. Then there is something called lysosomes. What are lysosomes? Lysosomes are basically small vesicles, and whenever they get mad, they will do suicide. Okay. They're also called as suicide bags, students. Lysosomes are also called suicide bags. They have a lot of enzymes in them. They have a lot of enzymes in them, students. Enzymes in them. Okay. So they have something called as hydrolytic enzymes that optimum at pH. They can work. Hydrolase, different types of enzymes are there. Main function is killing everything. Okay. Now what about vacuole here? Students, remember, vacuole is a dustbin there. Vacuole is a dustbin. Every single type of waste will go into the dustbin. It will go into the dustbin there. Okay. It is bound by a single membrane called as tonoplast. Very important. All of you students, very, very important. All of you, very important. Tonoplast. Okay. 2 a.m. done, no? What? I am not sleepy. If you are sleepy, I don't know, students. Now, next thing is called as your contractile vacuole. Vacuole can be of two types. Contractile vacuole is there. This contractile vacuole can be found in the case of amoeba here. With the amoeba, it can be found. Okay. Now, what is the main function of contractile vacuole? Contractile vacuole can help in osmoregulation and excretion. I don't think it's written here. It's written. Excretion and osmoregulation not given. So, students, you write down. It helps in osmoregulation. Remember, it helps in osmoregulation also. Right. Now, there is something in protist. What do we have? In the case of protista, we have the food vacuole can be present here. Can anyone give me, students, can anyone give me an example of which protist are they talking about here? Anyone who can tell me, students? Which protist are they talking about here? Chappal, like it looks like a chappal. It looks like a chappal, students. Can anyone tell me which protist are they talking about? Which looks like a chappal? Paramecium. They're talking about paramecium here. Paramecium. Okay. Not amoeba, paramecium. Paramecium are they talking about here. Okay. Food vacuole. Now, what about mitochondria, students? Mitochondria and chloroplast, students. Mitochondria and chloroplast, both of them will have its own DNA, true or false? Mitochondria and chloroplast, will they have their own DNA, true or false? True. They will have their own DNA. Mitochondria and chloroplast, will they have their own ribosomes? True or false? True. They'll have their own ribosomes. Will they have ATS ribosome? True or false? Will they have ATS ribosome? True or false? False. Because they will have what, students? They will have 70S ribosome. 70S ribosome they'll be having. Remember that point. Remember that point. Here, if you look at the mitochondria, students, mitochondria has two layers. Mitochondria has two layers. Outer layer, inner layer. Now, inside the inner layer, students, there is something called as foldings. These foldings are called as your cristae. They are called as what? Cristae here. In the case of Golgi apparatus, cisternae there. It was there cisternae there. Okay. Now, students, you can see here double strand DNA can be seen here. Now, here you can see something called a racket. All of you know, all of you play badminton. If you play badminton, you know what is a racket here. Here you can find something called as a racket shaped structure here. Can all of you see that? This racket shaped structure is called as F0 F1 particle or elementary particle or oxysomes. What is the main function? The main function is that they help in ATP formation. ATP formation. That's all, students. That's all. Okay. They help in aerobic respiration here. Okay. Aerobic respiration. How do they divide? They are divided by fission. Very important. They divide by fission here. Okay. Now, then we have plastids here. Plastids. Now, students, can anyone tell me? Anyone? Do you find plastid in the case of animal cell? True or false? Do you find plastid in the case of animal cell? True or false? Do you find plastid in the case of animal cell? Students, true or false? False. You cannot find in animal cell. You cannot find in the case of animal cell. Right? you can find only in the case of plant cell plastid. Only in the case of plant cell. Okay. So amyloplast, a type of leucoplast which stores starch. So leucoplast, right, stores starch. Okay. So amyloplast helps in starch storage. Amylose, amylopectin. Aleoplast helps in storage of oil. Aileroplast helps in storage of protein. Aileron layer, storage of protein is there. Okay. Now students, chlamydomonas, then this is done. Okay. By space limiting the inner membrane of chloroplast is called a stroma. Inner part is called a stroma. See this, all of you. Say inner part is called a stroma. Outer part is called as membrane, inner membrane. Then students, here we have something coin-like structure. This coin-like structure called as thylakoids here. When the multiple coins are stacked together, they are called as grana here. Now, can anyone tell me where do we get dark reaction here? Can anyone tell me, students, where do you have dark reaction? Anyone, students? Who can tell me where do we get dark reaction here? Dark reaction can be seen in the case of stroma here. Stroma. Where do you see light reaction, students? Light reaction can be seen in the case of granum or this thylakoid, or also on the stromal lamellae. Stromal lamellae is nothing but a connecting link between. It is a connecting link between two grana. This is called a stromal lamellae right in the middle. Called a stromal lamellae. So please remember that also. Okay. I told you, right? Ribosome of chloroplast and mitochondria have 70s ribosome here. Ribosomes are composed of ribonucleic acid and proteins. So if they ask you question examination, if they ask you examination on question, what are ribosomes? What are your ribosomes made up of? Ribosomes are made up of rRNA, ribonucleic acid and proteins. Just remember this much. Or RNA and proteins. Remember this much. RNA and proteins. Okay. Now in this S, what is S here, students? ATS in the case of eukaryotes. S means Sedgwick unit here. S means Sedgwick unit here. Okay. Now students, what is in the case of cilia and flagella? Understand, students. Difference in between cilia and flagella here. Very simple. Cilia and flagella are hair-like structures which help in motility. Yes, they help in motility here. But in most students, cilia and flagella both motility actually. Not in the case of fimbriae and pili, there was attachment. Okay. Now what is the difference here? Cilia is much more shorter, smaller. Flagella is longer here. Okay. Here we can see in cilia we can see oar-like movement. What is oar here? All of you know what is oar here? You have seen boats, right? They can help in movement here. That is an oar-like movement. Okay, oar-like movement. Now all of you need to notice here. This is the organism here. Here we can see, students, cilia is present throughout the body. All of it is cilia throughout the body here. While flagella is present only at the bottom, only at the back. Flagella, long flagella is present there. Okay. Now students, if you look at the diagram, if you look at the structure of the cilia flagella from top view, see students, if this is what is actually a flagella looks like. This is what a flagella looks like. Now in this flagella, if you look from the top view, if you see, this is what we see from the top view, right? And this is the arrangement of the top view of the cilia flagella. Here students, you need to notice here is that there is something called as microtubules arrangement here. Microtubules arrangement. Okay. It is not bacteria. Bacteria is prokaryote. This is always eukaryote. Okay. Now students, here you understand here cilia and flagella, what happens is that on the periphery there is something called as microtubules on the periphery. Okay. This entire thing is called as what? Core or axonium first of all. Now here students, let's count. Let's count how many do we have in the periphery. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have in total 9 microtubules in the surroundings. Now you might ask me, sir, what is a microtubule? Microtubules is nothing but, students, what is microtubule? Anyone who can tell me? What is a microtubule, students? Microtubule is nothing but type of cytoskeleton. It is a type of your cytoskeleton present in the plant, right? Or in the eukaryotic cell. Now here we can see all the microtubules on the periphery here. In the center also we have 2 of them. So 9+2 arrangement. 9+2 arrangement. Here students, all of you need to understand here is that here on the outer, every microtubule is present as doublet here. And this microtubule and this microtubule both are attached by linker here. Linker. This microtubule is attached to the center by this small line. Can you see here? This line is called as radial spoke. This line is called as what, students? Radial spoke here. Okay, called as radial spoke. Okay, students, this is called as radial spoke right here. Radial spoke right here. See here, all of you. See, this after all of you will remember, students, 9 plus 2, this is the main part here. Main part here. Radial spoke is present on the periphery. In flagella, the central tubules are connected by bridge here. Central, they have a bridge to cross here. See here. Central connected by bridge here. Central microtubules. Then we have your, this is called as your central sheath. See here. And enclosed by central sheath, which is connected to the each of the peripheral microtubule by doublet by a radial spoke. So radial spoke is present there. Radial spoke is present there, students. Okay. Student, that is easy. Next is easy. Here, can all of you see here the same diagram? Same diagram is given here also. Now, what is centrosome? All of you need to understand here is a small difference, students. You have Horlicks. Who wants to have Horlicks, students? All of you, students, all of you drinking tea. Students, all of you drinking tea at this point. Students, my coffee also is over now. I don't have a tea. Now, students, there was a fact I forgot about tea. Okay, students, tell me in the chat which type of tissue we find in tea leaves. A question to all of you. Students, tell me in the chat which type of tissue we find in tea leaves. Today only I taught you. Which type of tissue do you find in tea leaves? Anyone who can tell me? Anyone who can tell me, students? Coffee is better because coffee has caffeine, right? Coffee has caffeine. Tell me, students, which type of tissue can be found in tea leaves? Who can tell me? Who can tell me, students, in tea leaves what is present? Tea leaves, tea tissue. Sclerets, beautiful. Do you remember I told you in sapota, in your walnut, and in your many of the other legumes and tea leaves we can find sclerets, sclerenchyma. All of you remember? All of you remember, students? Yes? All of you remember now? Tell me yes or no. Students, who is this person inviting in Google chat? What do you want to do in Google chat, students? What do you even want to do in Google chat? Huh? See, sclerenchyma is proper, but it's already sclerets you should tell. Okay, sclerets you should tell. Okay. Now, students, let me ask all of you one simple question. Centrosome is there, no? Do you think we find it in plant cell? Do you find centrosome in the case of plant cell, students? Tell me yes or no? No, we do not. Centrosome is present exclusively in animal cell only. Only in the case of animal cell. Centrosome. Okay. Non-membrane bound duplicates in S phase of your cell cycle. S phase is duplicates. Okay. Now let's say this is a centrosome right here. Centrosome right here, students. One centrosome is made of 2 centrioles. Exactly, some random person coming at 2 AM. It's like, join this. So creepy. I am only getting creeped out. Okay. Now students, understand here. In the centrosome, what happens is there are 2 centrioles which are perpendicular to each other here. They are called as centrioles. That's all you have to remember. And the centrioles has a membrane-like structure around it. Membrane-like, non-membrane. Membrane-like structure. That is called as amorphous pericentriolar space or kinoplasm or centrosphere. Okay. Done? This is the structure of centrosome or centriole. Can you centriole? Here we can clearly see, students, here also we have 9 plus 0 arrangement because 9 there is periphery microtubules, but in the center there is no microtubule. In the center there is something called as hub here. So 9 plus 0 arrangement in the case of centriole here. Okay, centriole. What about nucleus, students? Nucleus, all of you know, nucleus is something called as outer layer and inner layer. Nucleus is something called as outer layer, inner layer, nucleus as, right? And between the two is called as perinuclear space. So between the outer layer and inner layer, the middle part is called as perinuclear space here. Okay. The inside the cytoplasm of nucleus is called as nucleoplasm. Nucleoplasm. okay, which contains nucleolus. Can anyone tell me, students, what is the function of nucleolus? Anyone in the chat who can tell me the function of nucleolus, students? Nucleolus is what? Nucleolus is a factory of rRNA, factory to produce rRNA, okay, rRNA. What is chromatin, students? Chromatin is the thread-like structure. Chromatin is a thread-like structure, not 9 plus 1, 9 plus 0. Chromatin is a thread-like structure which has histone protein, non-histone proteins, and everything is there, and DNA is also there. Okay, the interface nucleus has loose and distinct network of nucleoprotein called as chromatin. Yes, chromatin is there. Okay, which contains DNA, some basic proteins called as histone. So histone protein and DNA is present in the case of chromatin. Now, based on the position of centromere, we have metacentric, submetacentric, acrocentric here. Now, students, all of you can see here, this is a chromosome here. A chromosome, rRNA, not ribosome, rRNA. Okay, if you see a chromosome right here, students, the middle part is called the primary constriction, also called a centrome here. In the coordinates, what do we have? Coordinates top, we have secondary constriction called a satellite here. Now, this two long chromosomes, they are called as sister chromosomes. So all of you need to remember one more point here is that all the spindle fiber, they will never attach to centrome here. All the spindle fiber, students, they will always attach to kinetochore. Always attach to kinetochore. They will never attach to the centrome here. And students, that is your entire chromosome right here. And students, all of you know, right, what exactly is a chromosome? Chromosome, if you open the chromosome, right, we will find DNA only. So when we have a DNA, but I'll show you this one, just see this. If you ever get confused, just remember this slide of mine, okay? Just remember this. All of you, if you ever get confused what is chromosome made up of, just remember this. So let's say we have a DNA here. We have a double helix DNA right here. We have a DNA here. Now this DNA, let's start coiling it. Now this DNA, this is the DNA present here, right? Now students, this DNA will be coiled around a histone protein. All of you know histone proteins, right? Histone octamer, it is present there. Now this histone octamer is called as a nucleosome. We have a nucleosome here, okay, nucleosome. Now students, this nucleosome will do what now? Nucleosome will, we can have multiple nucleosome attached together. Multiple nucleosome attached together, right, like this. Multiple nucleosome. Now eventually what happens, understand. Eventually what happens, you understand, all of you. Okay. Eventually what happens, see this. So when multiple nucleosomes join together, we get the chromosome fiber. That chromosome fiber is nothing but chromatin here. So when multiple chromatin join this way, students, can you see here? We get the entire chromosome. We get the entire chromosome like this. Can you see here? When multiple chromosomes join together, when multiple chromatin, so your chromosome is nothing but multiple chromatin joining together, and that's how we get the entire chromosome. So we have DNA here. We have the DNA. DNA is being packed into the histone protein. Then we get the nucleosome. Then we get the entire solenoid model here, and then we get the chromatin here. Can you see chromatin? So what is chromatin, students? Chromatin is DNA plus histone protein, and then when it undergoes multiple coiling, that's how we get the entire chromosome. That's how we get the entire chromosome here. So this chromosome right here, students, it is made up of a lot of chromatin. Lot of chromatin. That is a chromosome. All of you understand, students? All of you understood? All of you students? Yes? Tell me so, students. Understood or not? That is how the chromosome has been aligned. That is how chromosome has been aligned here. Done? Students, then all of you understood what exactly is chromosome made up of? Okay. So if you have any more doubts, students, you can just start with this video right here, that is called as your cell, the unit of life. Okay, if you just see this, you're good to go. Okay. Students, leg I am trying to somehow manage. If you can watch this, you will be good to go in the unit of life. Now students, I'll give all of you one option right now. The one simple option is that, students, do you want biomolecules and cell cycle right now, or do you want plant physiology first? Ask me, students. Do you want plant physiology right now with full Josh? Like, 1.5 hour will finish off the entire plant physiology. 1 hour will finish the entire plant physiology, right? Or maximum 1.5 hour. Or. Do we finish the cell cycle and biomolecules, and we will do entire plant physiology separately, students. We can do plant physiology separately also. What do we do, students? Do we finish plant physiology separately, or do we finish this together? Or do we do biomolecules and cell cycle right now? Sir, you can do plant physiology separately. This week we can take one separate class on plant physiology. Or do you want it now only? I am okay with anything. Students. I'll give you exactly 2 minutes. I'll give you 1 minute to think. And tell me. If you want, I can make one short. If you want, students, we can do one short plant physiology also later on. So, students, what we'll do is we'll finish biomolecules and we'll finish cell cycle. It will not take more than 30 minutes. 30 minutes, both chapters are over. Okay, 30 minutes, both chapters are over. What we'll do is we'll do plant physiology separately. Okay, we will do plant physiology separately because I feel that all of you are very saturated by now. Tell me yes or no, students. Tell me. All of you are very saturated by now. Saturated, like so much of studying. Nothing is going inside the head. Okay, so what I'll do is, students, we'll finish biomolecules and one second, leg is hurting a little. I have to remove this. See this, I was wearing this on my leg the whole time, the leg support, right? So what we'll do is we'll finish biomolecules and cell cycle right now, and plant physiology we'll do separately. Okay, works? Okay, students, I'll give you exactly 2 minutes break. Just think, just relax for 2 minutes, because I know your brain is not braining right now. Just sit for 2 minutes, relax, take a deep breath, right? And students, exactly, why is sleep beating you, students? Oh God, why is sleep beating you? What is that? What do you mean by that? Why is sleep? Oh. Why will a sleep beat you? Oh God. Take 2 minutes, take a deep breath, chill for some time. We'll start in 5 minutes. Last part of the class. Machine running inside the brain. Like, think of, guys, someone is bribing the others. Janani is bribing the other students also. Think of it, it seems. Oh, bah. Brain is not braining, students. Imagine my condition where I'm talking continuously from that time. Now imagine how much of information I had to store in my brain to take this class. Crazy class this was. War between. Don't worry, this week only I will start, students. This week only I will start the end. I will do, let's take, today is Wednesday, right? By this Saturday I will try to take one class on plant physiology. Okay? Plant physiology I will do separate. By 18th, right? This week only I will do it, students. This week only I will do it. I will do it day after tomorrow only. No, I can't do day after tomorrow because day after tomorrow we have class 12th. I will do it this week only, students. Don't worry. This week, Saturday or Friday, I will do it. Okay. Agent Orange. Lol. Oh, Cash is sleeping, students. Students, let me just relax my leg for 2 minutes, no? I don't want my leg to be one elephantiasis tomorrow. I don't want to look like elephantiasis tomorrow, so. Give me 1 minute, students. Okay, students. I will do plant physiology separately only. Okay, then students, shall we start right now? Shall we start? Yeah. I will not, students, I will not sleep now. I will not sleep. If I go sleep, so students, I do not believe in power nap. Nope. Either I don't sleep or I sleep for 7 to 8 hours. There is nothing in between. If I sleep, no one can wake me up also. No one can wake me up. I just go sleeping. Okay. Students, right? Ideal time for robbing. This is the most ideal time for robbing, no? All the theft happens at 2:30 p.m. only. Like imagine someone is walking on the road thinking that I can stop, I can rob this entire place, and then they hear some random person talking in the middle of the night. They will think some mental is there in the road. Okay. Oh God. Yeah, I'm feeling a lot better right now. It's only the leg problem, students. It's only the leg problem usually. Stupid leg. Okay, students, shall we start right now? Biomolecules. Okay. Students, again in biomolecules, I'll tell you the most important points. I don't think so we can do plant physiology, because plant physiology will take 3 hours at most. Plant physiology will take 3 hours at most. So if I finish this by 3 p.m., even if I finish 2 chapters by 3 p.m., 3 to 4, 4 to 5, 5 to 6. Oh my God, 6 o'clock is too late, students. 6 o'clock is too late. Okay, students. Shall we start, students? Shall we start? Okay. Biomolecules, students. Biomolecules. So all of you know there's something called as a simple experiment here. The simple experiment, the first experiment is called as your right here. Here, if you can see, if you take a liver piece or leaf piece or liver piece, add trichloroacetic acid in it. Once you add trichloroacetic acid in it, you use a mortar and pestle, you make a chutney out of it. The chutney is called as what? Chutney is called as slurry here. Chutney is called as what? Slurry here. Now students, when you take this chutney, put it on the top of a beaker, and here you have to add something called as a muslin cloth. Muslin cloth. Now muslin cloth will act like students what? It will act like a filter paper there. Right? After some time you notice that some amount of slurry will come down, some amount of slurry will be on the top. Now whatever slurry is on the top, right, that is called as your retentate. What is coming down is called as filtrate. Retentate on the top, filtrate on the bottom here. Done, students? Done. Now this retentate is also called as acid insoluble fraction, because it is not soluble in the acid. Which acid? Trichloroacetic acid. The one which is coming down is called as acid soluble fraction, because it is soluble in the acid. Now here, students, what happens is all the molecules which are present in the retentate, their molecular weight is more than 1000 daltons, while whatever is coming on the bottom, their size is much more smaller here, They are called as what? Micromolecules, because the size is less than 1000 daltons. One which is on the top is called as macromolecules. Now students, can anyone give me an example of macromolecule in the chat quickly? For example, someone is eating Maggi there. Maggi is made up of carbohydrates. Which type of carbohydrate? It is made up of long chain of carbohydrates called as polysaccharide. Polysaccharide is a what? Polysaccharide is going to be a macromolecule. Now students, again, can anyone give me an example of micromolecule? Students, anyone give me an example of micromolecule? Anyone? Micromolecule, chotu molecule. Monosaccharides, students. Nucleotides, yes. Now students, what about lipid? Students? Lipid is very small. It is very tiny. But even though lipid is so tiny, it's like chota pataka bada dhamaka, you say, no? Big blast. So lipids are very tiny, students. So the problem here is that all the lipids will hold hands. They'll play chain. And even though lipids are very tiny, they're supposed to be in here. Lipids are supposed to be at the bottom, but they are not found here. All the lipids are found at the top here. All the lipids are found at the top here, because they're forming bond there, and they're forming something called as vesicles. They're forming something called as vesicles at the top here. They're called as vesicles on the top. Okay, so that is what is about your retentate and filtrate here. Okay, students. The second experiment is called an ash test, which tells you that in the case of your organic substances, we can find some inorganic substance also. Inorganic elements can be found here. Okay, this is called ash test. Now, students. Now, see, all carbon compounds that we get from the living tissue can be called as biomolecules. In most amino acids, the substitution. This I'll teach you later, students. Student, this is a typical structure. This is a typical structure of your amino acid. Here, let's say, now since Diksha ma'am is here, students, can anyone tell me what is a chiral carbon? Can anyone tell me what is a chiral molecule? All of the chemistry students, can anyone tell me what is a chiral molecule? Chiral molecule is a molecule, students, which has what, students? Which has all the 4 functional groups different. So here you can see, students, in the case of your amino acid, we have one carboxylic acid group, then we have an amino group, and we have a hydrogen here, and we also have a functional group here. Now, students, tell me in the chat if this functional group is going to be hydrogen. If this functional group is going to be hydrogen right now, in such a case, students, here we have hydrogen, here also we have hydrogen. Will that be chiral or non-chiral, students? Will that be chiral or non-chiral? That will become non-chiral. Okay, so glycine, if you put hydrogen, it becomes glycine. It is going to be non-chiral in nature, students. Now, what if I put CH3 here? If I put CH3 here, it is called as methyl. It will become alanine. If you add CH2OH, it will become serine. So you have to remember, students, whenever we add a functional group, the entire amino acid is changing here. Students. Okay. So in most amino acids, the substituents attached to the same alpha carbon are different. Right? They can be amino group, carboxylic acid group, and hydrogen and R group. The R group is hydrogen in glycine. It is alanine is methyl group. In hydroxymethyl in the case of serine. Okay. Now, students, can anyone tell me, yes, ma'am will ask you questions, students. Can anyone tell me in the chat right now? I have one more question to all of you, right? How many amino acids are there in total? How many amino acids are present in total? In total, how many amino acids are there? You will tell me, sir, in total there are 20 amino acids. Out of the 20 amino acids, how many of them are acidic in nature? 2 are acidic in nature. Can anyone give me an example, 2 examples of acidic amino acid in the chat quickly, students? 2 examples of acidic amino acid. So while you answer that, I'll be drinking some water. Which are the 2 acidic amino acids? In name only they have acid. Anyone? Glutamic acid and one more is glutamic acid and one more is, students, very easy. Glutamic acid and one more is, what is it? Tell me, students. Not acetic acid. Acetic acid is not amino acid. Not acetic acid, students, not acetic acid. Aspartic acid, very good. Aspartic acid and glutamic acid are the 2 different types of acidic amino acids. Now, students, there are 3 basic amino acids. Can anyone tell me which are the 3 basic amino acids? Anyone? I want you to think and tell me. Which are the 3 basic amino acids? Histidine, lysine, and arginine. So there are 3 basic amino acids. Remaining all are neutral. There. Okay, remaining all are neutral there. Human physiology, no, students. Plant physiology is not happening where human physiology happened. Okay, and students, last time I thought human physiology was 1 year back, 1.5 years back. So after 1.5 years back, I have never thought human physiology. So don't ask me in human physiology, students. 2 years back I thought human physiology, 1.5 years back I thought human physiology, but right now if I have to teach human physiology, I have to myself go through one more time, because it's been 1.5 years since I learned human physiology, right? Okay, so it's been 2.5 years. See, again I'm telling you students, it's been 1.5 years since I thought animal kingdom, 1.5 years since I thought structural organization, 1.5 years since I thought last chapter which I thought was locomotion, and I also thought not neural control, chemical coordination, as well as one more was body fluids. That was the last chapter I thought, and let me tell you students, it was there on YouTube. It was there on YouTube, and later on I removed it myself. Later on I only removed it myself. Okay, long back. Now students, now all of you need to understand that there is something called as your palmitic acid. Palmitic acid has, students, 16 carbon atoms. Palmitic acid is a type of your, palmitic acid is part of your lipids. Okay, fatty acid, part of fatty acid, students, part of fatty acid. Okay, 16 carbon atom including carboxylic groups, and arachidonic acid is 20 carbon. This can be asked as a PYQ, students. This can be asked as a PYQ, so please remember this. Palmitic acid is going to be 60, students. I'm thinking about gingerly oil already. Gingerly oil. Okay, gingerly oil. So palmitic acid is going to be 16 carbon, and arachidonic acid is going to be 20 carbon. Now your students, simplest lipid glycerol can also be called as trihydroxypropane, is another name for glycerol. Another name for glycerol here. Okay. Now students, what will happen? What will happen, students, when a fatty acid is not an amino acid, first of all. Okay, when a fatty acid combines with the glycerol, what do we get, students? When we have fatty acid and glycerol, if they join together, what is the baby called as? What is the baby called as? Anyone? Not gingerly oil, man. Not gingerly oil. Not gingerly oil. What happens when a fatty acid combines with the glycerol? We get glyceride. We get what? We get glycerides. We get glycerides. Okay, we get glyceride. Okay, so glycerides are called. Okay, we get glycerides. Okay, glycerides. We have monoglyceride, diglyceride, triglyceride. We can get glycerides, students. We can get glycerides. Where is that? Now, and students, fatty acids can be of two types: saturated and unsaturated. Students, the simple difference is that saturated fatty acids can have single bond, high melting point, solid room temperature. Butter and ghee is an example here. Butter and ghee example here. Okay. Now, what about your unsaturated fatty acids? Unsaturated fatty acids are double bond or triple bond. Melting point is going to be very low here. Liquid room temperature. Example is cooking oil and gingerly oil. So, gingerly oil is a type of your unsaturated fatty acids. Remember that point. Okay. I didn't teach you this. No, I didn't teach you this. Now, what is zwitterion, students? What is zwitterion? Understand. Triglyceride. Yeah, triglyceride also very important. Triglyceride also is a type of your glyceride only. Okay. Now, what is a zwitterion, students? Understand. Let's take, all of you should know, a amino acid will act very differently in different medium. Like all of you also. I've told all of you. You will act very different in front of your parents, very different in front of your teachers, very different in front of your friends. All of you have multiple personality. Okay, multiple personality all of you have. Similarly, amino acid also has multiple personalities. Multiple personalities an amino acid has. Okay. Now, students, imagine first of all, there is something called as one amino acid. At a particular pH, what happens is, at a particular pH, in this amino acid, this hydrogen is transferred to an amino group. That is called as intramolecular proton transfer. It is called as what? Intramolecular proton transfer it happens. Okay. Now, whenever such a condition is happening, right? In such a condition, what happens is that we get something called as a zwitterion. So, zwitterion is a result of intramolecular proton transfer. And here we can see, students, there is a positive charge on one functional group here. There is a negative charge in one of the other group here. So, there is a positive and negative charge together here. This is called as a zwitterion. This is called as, students, as a zwitterion. All of this happening where? All of this happening at a particular pH. The pH is called as what? Isoelectric pH. That is called as what, students? Isoelectric pH, and all of this happens. Okay. Now, students, I've given you more main points here. This is not in the proper order. The main points are given here, students. Main points are given here. Understand. All of you should know what is lecithin, right? Lecithin is a type of your lipid which is present in your membrane, cell membrane. Okay. All of you should know what is nucleoside, what is nucleotide, right? What is a nucleoside? It is nothing but your nitrogenous base plus sugar. Now students, if this nitrogenous base plus sugar, if I add a phosphate to it, then it becomes a nucleotide. This you have to remember students, very important. Okay, lipids are your biomacromolecules because they are found on the top there. Remember that point here. 20 amino acids, I told you. Now, what is collagen students? Collagen is the most abundant protein in the animal kingdom, and rubisco is the most abundant in the whole biosphere. Cellulose is a homopolymer. What is a homopolymer students? Homopolymer is a polymer which has a long chain of same type of repeating units. Let's say for example cellulose. Cellulose will have glucose, long chain of glucose, long chain of glucose. Okay, long chain of glucose. Fructose is a polymer of inulin. Inulin is a polymer of fructose. So in the case of inulin, what happens is long chain of fructose happens. Okay. Now complex, the I2, the iodine with starch forms blue color because it can hold that. It can hold that. Okay. Plant cells are made up of cellulose. All of you should know that. Yes. Functions are telling you functions. Now students, there is something called as nitrogenous base can be, they can be purines and pyrimidines. Now here, how do you remember students? How can you remember purines? Pure as gold. The best way to remember purines is pure as gold. That is, pure is P for purines, A for adenine, G for guanine. Now what about pyrimidine students? How do you remember pyrimidine? Cut pyramid. You can remember pyrimidines as cut the pyramid. Not given here, not given students. Cut the pyramid. CUT, cut the pyramid. So pyrimidines is pyramid, and what is CUT students? Cytosine, uracil, thymine. Cytosine, uracil, thymine is the examples of students. Life only is becoming a joke now. What do you want joke? Huh? Life only is becoming, students, I never thought in my life, students, I will teach 2:40 a.m. in the night, right? I'll be taking a class, and there will be students watching my lecture at 2:30 in the a.m. So this is the life itself is a joke right now. And if I tell students, everyone thinks my job is very easy. Many of my friends think you only teach, no bro, you only teach. But they do not know how much of effort goes into taking a class here, because all of you realize, right? If all of you are in the offline center right now, all of you will be in front of me, and when you nod your head, I get to know that you are learning something, and the energy flow and the teaching becomes very easier in offline. But in front of me, students, do you realize from like 11 to 12, 12 to 1, 1 to 2, 2 to, like from almost 3.5 hours, I am talking to myself. Students, all of you try this in your life, try this in your life, right? Sometimes just sit in your room, okay, sit in your room, right? And try to talk to yourself for 1 hour or 30 minutes. Just try to speak loudly for 30 minutes and making things interesting, students. Imagine that, students. So, and all of you are sitting in front of me, and the amount of energy which I have to show you, half of it gets cut in front of the camera. So that is the difficulty of this job. No one tells that. Okay. So exactly, grass is always green on the other side. Grass is always green on the other side. Okay. Where were we, students? Where were we? Now cut pyramid, cytosine, uracil, thymine. All the three are part of your what? Pyrimidines. Remember, students, remember that. Okay. Now there is something called as protein structure. Protein can have something called as primary structure, secondary, tertiary, quaternary structures. It can have different type of structures here. See, students, all of you can see here. See, this is called as a primary structure. Primary structure right here. Now, in a primary structure, what happens? Understand. In a primary structure, what can it tell you? Primary structure will always tell you which amino acid is present where. That is location of amino acid. See, 1, 2, 3, 4, 5. Here we can have leucine, isoleucine, like tryptophan. All the amino acids can be found here. That is primary. Now, what about secondary students? In the case of secondary students, what do we have? Alpha helix and beta plated. Now, here we can have something called as hydrogen bonding can be seen here. Okay. Then we have tertiary. In tertiary, what happens is it becomes a ball. One laddu it is becoming. For example, let's say this is going to be one. Let's say this is beta plated here. This is beta plated. This is how beta plated looks like. This is how beta period looks like. Now imagine I'm trying to make a ball out of it. Everything becomes into a ball now. Now this is called as tertiary. This is called as what now, students? Tertiary right now. Tertiary. This is called as what, students? Tertiary right now. Okay. No. Now what is quaternary, students? Quaternary is very simple. Let's take, I have one ball here and I have one more ball here together. That is called tertiary. That is called as quaternary here. So in the case of quaternary, we have multiple polypeptide chains coming together. It's given here, students. It's given here. See here. See. Primary structure of protein represents sequence of amino acid. Represents sequence of amino acid. In protein chain, the first amino acid is N-terminal amino acid and the last amino acid is called as C-terminal. Why N-terminal, students? Because of students amino group NH2, right? Or C-terminal because of carboxylic group. Okay. Tertiary structure gives three-dimensional view of the protein here. Tertiary structure of protein is absolutely necessary for many biological activities of protein. Quaternary structure of protein, and it consists of 4 subunits here. Example is that telling about hemoglobin. In hemoglobin, there are 4 subunits here. 4 subunits. Okay, 4 subunits, students. Okay. 4 subunits. What happens in 4 subunits, students? Here we have 2 alpha chain and 2 beta chain in the case of hemoglobin. Okay. Now they can ask you which bond is present between two glucose. Who can tell me, students, which bond is present between two carbohydrate, glycosidic bond? Which bond is present between two amino acids? Peptide bond, friends. Between bond is present between 2 amino acids. See, glycosidic bond, I told you. Now, what about phosphodiester bond, students? In nucleic acids, the bond between the phosphate and hydroxyl group of sugar is ester bond, right? So there is something called as phosphodiester bond. Phosphodiester bond is present between nucleotides, okay, nucleotides. All of you know ATGC, right? ATGC bond formation can be happening there. So DNA you learn in biomolecules. Now again, students, this is the homopolysaccharide, heteropolysaccharide. Students, I've always told you, students, where do we get chitin, students? Tell me in the chat. Is chitin a homopolysaccharide or heteropolysaccharide? Students, is chitin homo or hetero? Quick. Chitin is homo or hetero, students? Tell me in the chat. Chitin is what, students? Chitin is homopolysaccharide. So always remember, chitin is the structural homopolysaccharide. Starch, inulin, glucose also homopolysaccharide. What about heteropolysaccharides? We have peptidoglycan and agar are heteropolysaccharides. Here also we can see the functions here. Chitin can be present in the case in the exoskeleton of your arthropods. Okay. Now, all enzymes are proteins, but there are some or nucleic acid. That is, not all of them are see here. I'll tell you where is that. All enzymes are made up of protein except the ribosome. They are the RNA enzymes. So except the ribosome, everyone is a protein except ribosome. Okay. So what is the enzyme? Enzyme is a biocatalyst. Enzyme is a biocatalyst, right now, students. Okay. Morning crash course question was there. See, chitin is a very important question they can ask you usually. Okay. Biocatalyst. Now they can ask you what is activation energy. Activation energy is nothing but average energy difference between substrate and transition state. So for example, what is transition state, you understand? This is your substrate right here, substrate. This is called a transition state here. So before from substrate we go to the product here, between there is a transition state here, there is a transition state in the middle right now. Now this transition state has an energy that is called as the activation energy. Now for example, this substrate has to become product here. It has to cross the activation energy and then become. Now it is very difficult to cross it. Now what happens is that when you add an enzyme right here, it will decrease the activation energy. If this was the activation energy required, decrease this much. Now the barrier can be crossed very easily. That's how enzymes work. That's how enzymes work, students. That's how the enzymes work. Okay. See here. The formation of carbonic acid by CO2 and OH2O without enzyme produces 200 molecules in 1 hour. 1 hour. But if you add an enzyme, you get 6 lakh molecules in just per second. You get per second you get. Okay. Now students, now what is the inhibitor? Inhibitor is a molecule which will stop the entire reaction, it will inhibit the reaction. There is something called as competitive inhibitor, uncompetitive and non-competitive. But in your NCERT, you only have competitive inhibitor. The competitive inhibitor are used to control the bacterial and pathogen. This you have to remember very well. Okay. The example is not given, students. Malonate example is not given. Okay. So this you can skip today. So I'll teach you this. I'll teach you next class. Students, this you have to remember. This table is very important. They can ask you any of the secondary metabolites right now. They can ask you, students, any of the secondary metabolites. They can also ask you, students, any of the protein functions here. Now here, what they mainly ask you? They mainly ask you this one here, GLUT4. Mainly ask you the GLUT4 here, and here they can ask you any of the following, different types of secondary metabolites, and what are the functions or the examples also. Examples they can ask you. So this table is very, very important table with respect to your examination. And if you open any biomolecules, right, any biomolecules, this PYQs, you will see one question from here especially. One question from here will always come. Okay. Now, last concept is called as apoenzyme concept here. There is something called as your apoenzyme. Apoenzyme is this protein part. What is cofactor? Cofactor is non-protein part. Now, if only apoenzyme is present, it is inactive. Waste it is. Waste of all. This is waste body. You in the house. Okay. So, completely waste body it is. It is protein part here. Biologically inactive. But when we take a cofactor and we add it to the apoenzyme, right? Cofactor plus the apoenzyme, they will make something called as the holoenzyme, and this holoenzyme, students, this holoenzyme is biologically active. Holoenzyme is, students, what? Biologically active right now. Biologically active right now. Okay, biologically active right now. Holoenzyme. Okay, now there are three different types of cofactors here. One is called a prosthetic group, one is called as a coenzyme, one is called as a metal ion. Okay, now what is the prosthetic group? Understand, here it is going to be organic in nature, organic, inorganic in nature. Prosthetic group is very tightly bound to the apoenzyme, loosely bound to the transitive bound to the apoenzyme. Coordination bond can be seen here. Example is going to be heme group. Heme group, which is part of your heme is the cofactor, peroxidase is the enzyme, apoenzyme here. Together they make the holoenzyme. Okay, so hydrogen peroxide to water and hydrogen, we need heme. Heme is a cofactor. Without heme, the function cannot work here. Okay, now what about here? In the case of coenzyme, here we have NAD and NADPH here. And here we can see vitamin as niacin is important here. Now metal ion example is zinc is the metal ion example here. It is used in carboxypeptidase. This is the enzyme, this is the cofactor. This cofactor is present with this enzyme. Okay. So students, if you want more clarity, students, let me tell you again. The more clarity if you want, please watch this lecture, one short lecture on biomolecules. Let me tell you, confirm, you will not have any confusion for biomolecules. Today is going to be just a revision. It's just a revision here. Okay. So if you want a better clarity, please watch this video for entire one shot of your biomolecules. One shot of your biomolecules. Okay. This one right here. It's 3.5 hours. Very, very important. Okay. Now students, we come to the last chapter of your today's session. Right. That is going to be biomolecules. After this, I think we'll stop right now. I will try to do the plant physiology separately. Okay. I will try to do the entire plant physiology separately. Okay. Because I feel all of you are also burned out right now. Full burned out. And moreover, students, if you do not have a fresh mind, let me tell you again. If you do not have a fresh mind for plant physiology, right, it can be very risky. Let me tell you that again. Because plant physiology requires concentration. All of you agree on that? All of you agree on that, students? Plant physiology will require a lot of concentration from your end. And if you do not show the concentration, gone case. So I think that concentration is not there right now, right? So what we'll do is, students, I will teach this part and we will stop at cell cycle. Because if I teach you entire glycolysis right now, if I teach you Krebs cycle, there is a 90% will go from your head like this. It will not even go inside, it will not even go and come out. It will not even enter your brain. Like, this much only it will stop, it will go from here only. Okay. So plant physiology we will try to do in the separately. Might as well do it, right? So we'll just try to do this small thing, cell cycle, very cute chapter. I will tell you what you need to study here. Apart from that, you have to forget everything else. Nothing is more important here. Okay. And students, again, I'm telling you, this chapter cell cycle and cell division, I have taught so many times on the YouTube, and all the students, Christina, so all of you part of my DNA batch, I've taught you in DNA batch. If you're part of NEET Express, I've taught you in NEET Express. If you're part of crash course, I've taught you in crash course also. So, and on YouTube also, I've taught this chapter like around 3 times, I guess. First in RNA, line by line, pages series, and pre-COVID questions, pre-COVID pattern, and also recently I told all important 11th concept and question. So almost taught 5 times this chapter. So now I will go only like very slowly. Okay, we will mainly go on the main points right now. Okay, we will do only main points right now. Okay, okay students. Okay or not? Tell me students. Shall we start? Shall we start students? Shall we start? Yo everyone. Shall we start? Cell cycle and cell division. Okay. The first of all students, what is the need of cell cycle? The main need of cell cycle is to divide a cell. From one cell we can get 2 cells. That is called as cell division. That is called as what? Cell division in general. Okay. Now, sexually reproducing organisms start their life cycle from a single cell called as zygote. Now, all of you also someday, like in the past, you were a zygote. Imagine you were a zygote. Now, from that one cutie zygote to becoming one buffalo like this. Okay. From a zygote to buffalo, right? You have come a long way. You have come a long way, and it is only possible because of cell division. If there was no cell division, you might not exist right now because all of you would be a zygote itself. Okay, so cell division is very important in increasing the organism in size also. Okay, the stage through which all cell pass through from one division to the next is called a cell cycle here. Now, the cell cycle can vary. For example, students, in yeast it can be for your 90 minutes, but in the case of humans, how long do you think it is, students? In the case of humans, it is going to be around. Anyone who can tell me, students? Let's take a normal cell. In the humans, it is around 24 hours. 24 hours is the cell division here. So cell cycle here. Now, in this 24 hours, students, here it is entire 24 hours divided into 2 parts here. 2 parts. Okay. We have 23 hours as such, and we have 1 hour as such here. This is roughly around 95% of it and 5% of it. Okay. Now, students, understand here is that this 23 hours, right? When the cell is in cell cycle, it is actually chumma resting there. Okay, it is in interface here. It is in interface here. The actual cell division happens in this 1 hour. That is the M phase here. The M phase here. So all of you should remember this small part also. 23 hours it is chilling. 1 hour it is working very well. It is working very well. Okay, working very well. Now understand, students. The cell cycle is divided into 2 parts: interface and M phase. Interface and M phase right here. Okay, students, again I'll show you here. Say this. Students, where is that diagram? Here. Can you see, students? In this diagram, it's very clearly visible. This is called as your entire thing is called as interface, and here we have M phase here. M phase. Now again, students, the M phase is also further divided. The M phase is also further divided into 2 categories. It is divided into chirokinesis as well as cytokinesis. Chirokinesis and cytokinesis. And chirokinesis and cytokinesis. Can all of you see here? Here we have the purple color is chirokinesis. This pink color is called cytokinesis. Now, students, interface is again further divided. Interface is again further divided into 2 categories. One is called as your 3 categories. G1, S, G2. Now, what exactly happens in all 3 of them? What exactly happens in G1? Understand, students, understand what happens in G1. In G1, most of the organelles starts to duplicate. There will be duplication of organelles can happen. Yes. In S phase what happens? In S phase there is a duplication of DNA, right? DNA duplication happens here. There is DNA duplication can happen here. Now what happens in G2, students? In the case of G2, most of the proteins get synthesized, or RNA gets replication also happens, or RNA replication also happens here. But mostly what happens in G2 is the most of the proteins gets formed here. Okay. Here. Nuclear division is called as chirokinesis, while cytoplasm division is called as cytokinesis. In cell, the resting phase is called as your interphase. The resting phase is called as what? Interphase, and dividing phase is called as, it is divided into G1S G2. Okay, G1S G2. Now, what is G1? G1 phase of synthesis of RNA, ATP and proteins also happens here, but mainly that happens in the case of G2 mainly. But here also we can write in general. Okay, don't write. Here you can see, students, during S phase what happens? DNA replication happens here, that is DNA content doubles here. For example, there was 2C DNA, it becomes 4C right now. DNA content is doubling. For example, students, if this was the chromosome, it will develop into something like this. DNA content is increasing. Now I'll ask you one simple question, students. Is there a change in chromosome number? Is there a change in chromosome number, students? Absolutely not. The chromosome number will always remain the same here. The chromosome number will always remain the same, only the DNA content is increasing. If it was 2n here, it will remain as 2n. Chromosome number will not change. Chromosome number will never change, students. Yes. No change in the entire chromosome number. Okay. So if the cell has 2n number of chromosomes at G1, then the number of chromosomes after S will remain as 2n itself. No change in chromosome number. Okay. Now students, in this entire cell cycle, right, there is something called G0 stage, also called as quiescent stage. G0 is also called as quiescent stage. Okay. Now what happens is that some cells are not required at the point. There is no requirement of a certain cell. So what happens is that some cells will exit the cell cycle. Some cells will exit the cell cycle after G1 and they'll reach an inactive stage, that is called as G0 stage or quiescent stage. Okay. Quiescent stage, students. Now what is quiescent stage, students? The cells are metabolically active but do not proliferate. So they are metabolically active but they do not divide. This is what I mean by inactive. That is, they do not proliferate, they do not divide, but metabolically they are active here. Okay, G0 phase. Now, let's understand mitosis right now. Let's understand mitosis right now. Okay, during mitosis, the prophase one. So all of you know, students, what exactly is present in the case of your mitosis? CS, students. So mitosis is divided into two parts: chirokinesis, cytokinesis. Chirokinesis is divided into further PMAT. All of you PMAT in the chat. Prophase, metaphase, anaphase, telophase. PMAT. So we have pro, meta, ana, telo right here. Okay, pro, meta, telo, ana right here. Now, what exactly happens in prophase? In prophase of M phase, duplicated centrioles begin to move towards the opposite poles. The centrioles are moving towards the opposite poles right now. Yes, opposite poles. The chromatin condensation happens here. The cell organelle starts disappearing and nuclear membrane disappears here. That is what happens in the case of your prophase. Now students, if you watch my lecture, I have told you something called as early prophase, late prophase. That is also very important here. Because students, there is something called as aster formation here. Aster formation also happens here. Aster formation. Okay. Now students. Now, kinetochore on the surface of the centromere serve as the site of attachment of spindle fiber to the chromosome. So all the spindle fiber, right, this is the cell here. Okay. Now let's say here we have kinetochore. So all the spindle fiber, students, all the spindle fiber will attach to the kinetochore. Now can anyone tell me when does it happen? This happens in the M phase. This happens in the entire M phase. It happens M phase. It happens in the metaphase. Okay. Now the plane of alignment of chromosome at metaphase is referred to as metaphasic plate here. The anaphase, what happens in anaphase? What happens? Splitting of centromere happens and separation of chromatids. So in the case of anaphase, all the chromosomes will separate out here. Will be separate out, students. Students, I didn't forget to get the diagrams today. I forgot to get the diagrams today. One second, students. I might have my notes. One second, students. I might have my diagram notes. One second. Give me 1 minute, students. I might have my notes right here in my One second. Diagrams, no, one second. Obviously, with diagrams is better with the help of diagrams. Let me just check if we have notes right here, my old notes. Any of my old notes which I can find on my... Oh, found it, students, found it. One second, students. Let me just exit this. No, I can just share you the notes. One second, students. I got my old notes. Diagram is more important. It's easier with the help of diagrams. Students, do you see my notes here? How I've arranged my notes? No. Got it. Here we go. Got it. Here, students, these are the notes which I love. These are the best notes for your. These are the best notes. These are the best notes for your studying the entire cell cycle. Now, students, I always told you prophase has two main things: early prophase and late prophase. All of you remember, students. In prophase, what happens? Longest phase of the M phase. It is the longest phase of M phase, students. Right? Initiation of condensation of chromosomes happens here. In early prophase, what is happening? In the case of early prophase, condensation of chromosome is happening. Movement of centrosome. Can you see? Centrosome is moving here and moving here. That is what is happening in the case of your centrosomes here. Okay, students, centrosome, what is happening here? Okay. Now, students, what is happening in the case of late prophase? In the case of late prophase, what is happening? Disappearing of your Golgi complex, endoplasmic reticulum, and nucleus, everything disappears here. Now, again, students, here there are two types of microtubules can be found here. Two types of microtubules can be found here. One is called as your, can you see this part here? This part right here, students, this part here. This part is called as asters. The one which is coming from the top is called as, this is called as what? Spindle fiber. So here what do we have here is, from the centrosome, there is, on the front we have the spindle fiber, and at the back we have the asters. Together, aster plus spindle fiber, they will make up something called as, students, they'll make up something called as mitotic apparatus. They'll make something called as, students, mitotic apparatus. They'll make mitotic apparatus. So this is only seen in the case of your animal cell, because centrosome is absent in the case of plant cell. Okay. See, can you see this one? This is your centrosome. Two centrioles here, cartwheel shape, 9 plus 2, 9 centro, 9 plus 0 arrangement. Here we can see this is called as aster, and this is called as what? Spindle fiber. Spindle fiber here. Okay. Now, students. Now, this is your meta. Students, do you see the notes? Do you see the notes, students? Do you see the notes here? Right? It's so good here. So good. Right? Here, what happens in metaphase? Movement of chromosome happens. All the chromosomes are moving to the center here. Okay. Now, the middle part is called as metaphasic plate or equatorial plate here. Spindle fiber attached to the kinetochore here, like this. This is the spindle fiber attached to the kinetochore here. Okay. Now, what happens, students? This is the best stage study. Best stage to study the chromosome morphology. Why? Because condensation is complete here. The entire condensation is complete here. So, best stage to study the chromosome morphology. Best stage to study chromosome morphology. Okay. Now, students. See, this is the chirotyping can be done here. Now, what happens in the case of anaphase? Okay. Now, in the case of anaphase, what happens? Understand, students. In the case of anaphase, it is the shortest phase. All of you know that. Here, what happens is, let's say this is one chromosome right here. Now, what happens is that right in the middle, there's a slit here. Slit here. Now, this entire chromosome will split open, and we get sister chromatids of the chromosome split here. They're breaking up basically. They're breaking up here. Okay. So, they're splitting into two here. And then all of them are being pulled apart. All of them are being pulled apart to the respective corners here. Now, students, all of you tell me, students, in the chat right now, in this one cell right now, how many chromosomes are there? All of you. How many chromosomes there? You'll tell me in normal conditions, students, there are 46 chromosomes here. Yes, there are 46 chromosomes here. 46 chromosomes are here. Diploid cell or diploid cell. This one chromosome has two chromatids. One chromosome has two chromatids. So 46 chromosome will have 92 chromatids. Tell me yes or no? Tell me yes or no, students? One chromosome has, in general, one chromosome has two chromatid. One chromosome has two chromatid. So 46 chromosome will have double of it. No, 46 into 2 is 92 chromatids are there. Now what is happening here, students? Temporarily what is happening in this particular cell right now, temporarily every single chromosome, every single chromatid is acting like a chromosome. So every single daughter chromatid is acting like a chromosome here. So because of that very reason, we call this cell as 4n condition. Why 4n? Because all of you know n is 23, 2n is 46, 3n is 69, 4n is 92. So temporarily in anaphase, one cell has 92 chromatid. 92 chromatid is every chromatid is acting like a chromosome. So we have 92 chromosomes temporarily here. We have 92 chromosomes temporarily here. That's why we say 4n condition. Okay. Now student, this is the best stage to study the shape of chromosome. Here in the morphology, it was, so in the case of your metaphase, it was morphology. But in the case of anaphase, it is study the shape of the chromosome. Two different things, students, two different things. Now see here, this is how they're being pulled apart. Splitting of centromere here. So at the end we have telophase. What happens in the case of telophase? Chromosome cluster at opposite poles. All the chromosomes will come here. Remaining chromosomes will come here. They're clustering at the opposite poles here. Done. Okay. So they lose their identity obviously because they are again becoming thread-like structures again. Thread-like structures they'll become. Okay. Thread-like structures they'll become, students. Okay. Now students. Now nuclear envelope develops, is again reappearing. Golgi complex, heterologous reticulum, everything is reforming here. And at the end of telophase. Now is the cell divided now? Will the nucleus divide? Yes, nucleus has been divided. Nucleus has been divided here. Chirokinesis is over. Now what happens, students, is we have cytokinesis now. Cytokinesis. Okay. Cytokinesis is different in the case of plant cell and animal cell. They are different here. How are they different? Understand here. So in the case of your plant cell, what is happening here is it is happening from the inside here. That is, there is something called as cell plate formation or emotional blackmail, which I call it. Okay. From the inside it is happening. Inside cell plate formation, it will be pulled apart. Okay, cell plate formation. But in the case of animal cell, what happens? In the case of animal cell, what happens is, students, right? Here we have something called as pinching will happen from the side. Pinching will happen. That is called as furrow formation. Furrow formation of the sides. And we end up getting two cells eventually. That's how the cytoplasm divides in the case of animal cell. In the case of plant cell, we have cell plate formation right in the middle. Cell plate formation right in the middle. So very, very important concept for your cytokinesis. Okay. Now what is the significance of mitosis? Growth and development, reproduction, repair and maintenance, growth of meristem, and restoring cytoplasmic ratio. All of these are basically in significance of mitosis. Now students, now what about meiosis? Now before we go to meiosis, students, okay, imagine a condition where chirokinesis is happening. We imagine a condition, students, where chirokinesis is happening, but there is no cytokinesis. Students, tell me in the chat quickly. Imagine a condition where chirokinesis is happening, but no cytokinesis. The cell is like, I don't want to divide now, students. Tell me what will happen in such case. Can anyone tell me what will happen in such case, students? When there is chirokinesis, all this prophase, metaphase, anaphase, everything is happening. But cytokinesis will not happen. In such conditions, students, what will happen is syncytium formation happens. So if chirokinesis is not followed by cytokinesis, they will lead to a multinuclear condition called as syncytium. Example is liquid endosperm of coconut. If you drink coconut, okay. So we get liquid endosperm. We get, students. Students. In COVID time, I had a own meme page. Do you believe that? In COVID time, I had my own meme page where I used to post memes and general memes in general. Okay. So I love memes. So when I see any biology memes, I love it all. Students, if you encounter any biology memes, please send it to me in Instagram. Okay. Please send it to me in Instagram, students. Okay. Is this live? Yes, it is live only. Okay, please send me in Instagram if you find any memes. Okay, syngenesium. Now students, this is a DNA content which all of you love. This is the where you get the entire concept clear. Okay, so all of you know students, in G1 phase what do we have? In the case of G1 phase we have 2 and 2C condition, that is diploid 2C DNA content. Diploid 2C DNA content, students. Done? Okay. Now what exactly happens in S phase? What happens? All of you know, in the case of S phase, what is happening, students? What is happening in S phase? In S phase, DNA content is doubling. So 2 and 4C, 2 and 4C happens. Now what happens in the case of G2? Nothing changes much more. Pro phase, nothing changes. Meta phase, nothing changes. But as soon as we come to NR phase, so all of you remember, students, in the case of NR phase, every single chromatid is acting like a chromosome. All of you remember, students, in NR phase, every single chromatid is acting like a chromosome. We had 92 chromosomes there, 4 in condition, 4 and 4C. Now what happens in telophase, students? Telophase, per cell, 4 and 4C is there. Per cell it is 4 and 4C, students. Understand here. Here what is happening is, per cell, this entire cell is 4 and 4C. Now students, I want all of you to divide 4 and 4C divided by 2. What do we get? What do we get, students? What do we get, students? What do we get? 2 will go this side, 2 and 2C will go this side. Remaining 2 and 2C will go other side. Simple as that. Okay, simple as that, students. So per nuclei, there is a small change here. Per nuclei, there is a small change here. 2 and 2C. Now students, all of you can agree with me. We are ending with 2 and 2C. We are starting with 2 and 2C. But here we have one cell. Here we have 2 cells. So can I call it? Can I call it, student? Can I call it? Can I call it as equational division? Tell me yes or no in the chat. Can I call it equational division? From starting we are 2 and 2C, ending with 2 and 2C. So equational division, equational division. Done and done. So that is the concept. That is the concept right here. That is the concept right here, students. That is the concept. 2 and 2C to 2 and 2C. Equational division. Mitosis. Students, all of you understood? Students, all of you understood? Tell me yes or no in the chat. Yes or no? Yes. Equational division. Okay. Students, now we go to meiosis. Now we go to meiosis, students. Now, what is the need of meiosis? Some of you ask me, sir, why do we even need meiosis? Is there any requirement for meiosis, students? Yes, there is a requirement. Understand? For example, let's say we have a sperm here and we have egg here. Okay. If it undergoes mitosis, there will be no change in ploidy. There will be no change in ploidy, students. You are seeing blur because your eyes are closing. Okay. There is no change in ploidy right here. So 2n, 2, 2n, 2n to 2n. What happens? Zygote becomes 4n here. Let's take we have one more zygote, 4n, 4n. This will develop into one more female, develop into male, 4n, 4n, 4n plus 8n. So in such case, what happens? In such case, it cannot sustain. The ploidy will keep on increasing. It will never decrease at all. So it is very risky. It is not just risky. It is not sustainable at all. And not possible at all, students. Not possible at all. So to counter this, we have something called as meiosis. Because students, meiosis is called as what? In meiosis, there is a change in chromosome number. If there is a diploid cell, if it undergoes meiosis, it will become haploid. Like, we'll cut it off. Okay. So diploid will become haploid here. Diploid can become haploid here, students. Diploid can become what, students? Haploid here. Okay. So that is main important, meiosis. Now meiosis can be broadly classified into 2 categories, interphase and M phase. Again same, in intercase we have G1 as G2 and in the case of M phase we have meiosis I, meiosis II. In between meiosis I and meiosis II we have the interkinase also right in the middle, interkinase. Students, remember students, this interkinase is similar to interphase, but there is a small difference. The small difference is that here no DNA replication here. No DNA replication happens here. And friends, remember, this meiosis I is actually the reduction division where 2 and 2n happens. Here we have PMAT again, PMAT again, prophase 1, metaphase 1, anaphase 1, telophase 1. But this meiosis II right here, right here, it is actually scamming here. Because this meiosis II is nothing but equational division and it is nothing but mitosis only. This meiosis II is actually mitosis itself. Nothing. It is just like mitosis. So if you learn this one, you are good to go, students. You're good to go this one. If you learn this one, you're good to go, students. Okay, students, you're good to go. Okay, now see this. Now what exactly happens in meiosis I, students? Meiosis I has something called as prophase, metaphase, anaphase, telophase. It has prophase, metaphase, anaphase, telophase. But what you need to understand here is that this prophase here has multiple parts. It has multiple babies here. Okay, this prophase has multiple babies here. Okay, it is called as your leptotene, zygotene, pachytene, diplotene, dikinesis. Now, students, all of you will know by now. What exactly happens in leptotene, zygotene, pachytene, diplotene, dikinesis. All of you are aware. So I'll give you a quick revision. Just listen to me for next 10 minutes and I'll leave you. Okay. Students, understand now. Understand. Okay. Now understand what happens, students. What exactly happens here, understand. Okay. Here the small trick is let zebra play during the day here. Now what exactly happens in leptotene, understand, students. In leptotene, I'll tell you only one point you have to remember. The only one point about leptotene is that the chromosomes becomes gradually visible under light microscope. First point done. That's all. Now, what happens in zygotene? Students, in zygotene what is happening is there is something called as homologous chromosomes. In zygotene what is happening is one chromosome here, both the chromosomes will start to pair up. The pairing of chromosome is called as what? Anyone who can tell me in the chat? Students, anyone? Pairing of homologous chromosome is called what? The pairing of homologous chromosome is called as synapses. It is called as what? Synapses. So two chromosomes are coming together, that is called as synapses. Students, now you understand, whenever once the synapses has happened, in between the two chromosomes there is a complex formation and that is called as what? Synaptonemal complex formation. That is called what, students? Synaptonemal complex formation. Now students, again, this is the first point here, second point here. Third point is that, students, in this stage right here, all of you listen to me. In this stage right here, it can be called as bivalent or tetrad. It can be called as bivalent or tetrad. Now you want to ask me, sir, why is it called as bivalent? Why is it called as tetrad? Understand, very simple. It is called as bivalent because one chromosome, second chromosome, bivalent. Tetrad because 1, 2, 3, 4, 4 chromatids, tetrad. Done, students? Done. Now, these 3 points you have to remember about zygotene. Now, what exactly happens in the case of pachytene? Pachytene, all of you know, students, imagine, students, if you don't bring tiffin, what do? If you don't bring tiffin, you will take your friend's tiffin. You don't even ask if to snatch from your friend. Okay, same thing is happening here, students. Same thing is happening here. In pachytene, what is happening is, let's say I have one chromosome here, second chromosome here. Now, what do I do here, students? This is called a sister. But one pink, one yellow, that is called as non-sister. Now, what happens here, students? There is something called as crossing over. Now, what happens in crossing over is that, students, this genetic material is transferred this side, this genetic material is transferred this side. That is called as exchange of genetic material. Exchange of genetic material is happening here. Okay, and this exchange of genetic material is happening, that is called as crossing over. Understand, students, what is crossing over? Crossing over is nothing but exchange of genetic material between two homologous chromosomes between, students, sister or non-sister, tell me, students. Can anyone tell me this exchange of genetic material happens between sister or non-sister? It happens between non-sister always. So exchange of genetic material always happens in the non-sister. Always remember, non-sister it happens. Okay. Now here all of you need to remember 4 things. Okay. First thing is that bivalent and tetrad becomes clearly visible. Bivalent tetrad becomes clearly visible, point number 1. Point number 2 is that there is formation of recombination nodule at the site of crossing over. At the site of crossing over, nodule formation happens. Third point, the enzyme involved here, recombinase enzyme. And the fourth point is going to be what, students? Crossing over happens here. Fourth point is, students, what? Crossing over happens here. Okay. Done, students? Done. So if you remember all of these 4 points, you're good to go. Bivalent becomes clearly visible. Recombination nodule formation. Recombinase enzyme. And the 4th point is going to be crossing over. So if you remember these 4 points, done and done. Done and dusted. Okay. Pachytene. Crossing over happens here. Now last point is called, next is called as diplotin. What happens in diplotin, students? Now students, all of you remember, right? Here you have to remember only 2 points. Here there was something called as synaptonemal complex, right? Synaptonemal complex. That synaptonemal complex disappears. First point. The synaptonemal complex disappears here. Okay. That is the question. That is the question here. Okay. The second point is that the 2 chromosomes will start to separate from each other, except at one point. The 2 chromosomes will start to separate from each other except at one point. That one point is called as what? X-shaped mark, that is called as chiasmata. This X-shaped mark is called as chiasmata. Except the chiasmata, everywhere they'll separate. So these are 2 points you have to remember and you're done. That's all. 2 points have to remember. That's all. Now, last part is called as diakinesis. What exactly happens in diakinesis, students? In diakinesis, what is happening is that X mark is there, no? X mark also separates out. That is called as termination of chiasmata. That's all. Termination of chiasmata is the most important point here. The second main point is what, students? The complete condensation is over. It's prophase, no condensation is over. And everything else also disappears. Everything is disappeared by now. Okay, the diakinesis. So then we have mitosis. So then we have metaphase. In metaphase, what happens? All the chromosomes align on the center. We have 2 equilateral plate here. Why? Because homologous chromosomes. Okay. Now, what happens in the case of anaphase 1? In the case of anaphase 1, the homologous chromosomes separate out now. Homologous chromosomes separate out. See this. Homologous chromosomes are separating out like this. Homologous chromosomes. Is the centromere splitting here, students? Is the centromere splitting here? In anaphase 1 of meiosis, is the centromere splitting? No. Centromere remains attached. Centromere remains intact. Chromosomes are separating out here. Main points here. Sister chromatids remain associated. No. What happens in telophase 1? Telophase 1 again, what happens, students? Again, the 2 nuclear envelopes are reformed here, right? Nucleolus and nuclear membranes reappears here. Cytokinesis occurs later on and we get diode of cells. Then we have cytokinesis and we have 2 cells. So what did we have right now, students? What exactly happened here is that from a diploid cell after meiosis 1, right? After meiosis 1, a diploid cell became 2 haploid cells. Diploid cell became 2 haploid cells. That is what is happening in the case of at the end of meiosis 1. Now, what exactly happens in meiosis 2? Understand, students. Meiosis 2. Okay. In meiosis 2, what is again prophase 2 is similar to mitosis. Similar to mitosis, students. Very similar to mitosis. In prophase 2, what is happening is nuclear membrane disappears again. Chromosome becomes compact. Metaphase, they align on the equilateral plate. That's all. Anaphase, sister chromatids split here. Centromere of the sister chromatids split here. Similar to mitosis. Very easy. Very easy. Telophase, what happens again? Everything again, reappears. That's all. And we get tetrad of cells here. Because what exactly happened is that, students, first we had 1 cell divided into 2 cells here, meiosis 1. These 2 cells now went under mitosis to give us 4 cells here. 4 cells in the bottom. So that's how we get 4 cells in the bottom. Okay, students. Functions, meiosis significances, genetic variability because it can cause variation because of crossing over, evolution obviously, and conservation of chromosome number. Conservation of chromosome number, students. Okay. So students, I will not teach you that this part here. I think we will end here, students. I think we will end here. Sir, in some studies they say dissolution of chiasmata happens only in anaphase. Not really, because in anaphase most of the time what happens is the splitting only happens. There are some cases where, see students, in your entire cell cycle, right? Entire cell cycle is not very absolute. There can be some steps where something has been crossed over. Something can be slipped into other one. Okay. Sometimes what happens is the 2 chromosomes do not split also. 2 chromosomes do not move also. That is called non-disjunction. So there are multiple cases where so many anomalies can happen. Okay. Anomalies can happen, students. Okay. I am wondering how your brisk secret of boost, drink boost, you'll be fine. If you drink boost, you'll be fine, sir. Students, SN, there are questions generally come from NCRT only. If you solve any PYQ, question will come from NCRT only. If they come out of NCERT, they can ask you about colchicine. Colchicine is a substance which can stop the cell division. That's all. Apart from that, they cannot ask you. If they ask you questions, students, if they ask you detailed question, right, then in such case question can come from here. This I'm not teaching you right now. This you have to study on your own. Okay, you can watch any of my older lectures where I've taught you, right. This is very important because from here question can come. From here question can come from here also. Okay, so please be careful when they ask you such questions. Okay, Horlicks is my secret. Horlicks is nice. Done, students? Done? Students, when did we start? I don't even know when we started. I think 11 to 12, 12 to 1, 1 to 2, 2 to 3. 4 hours, no, I think 5 hours, that's all. Almost 5 hours. Okay. Students, we have done question series. We have done question series multiple times. Students, don't worry. Coming week, we will do entire plant physiology. Right. We will do entire plant physiology very soon. Don't worry. I will make sure no one will take even 1 mark from you. Even if they take 1 mark also, you catch hold of me later on. I will prepare you in plant physiology in such a manner that, see, plant physiology is my favorite. Apart from any topic in botany, my favorite topic is taxonomy and also plant physiology. Okay, so I'll make sure you learn in such a way that you can solve any question from plant physiology, and I'll make you perfect like that. Perfect. You know, like when I'll mold all of you in plant physiology. Okay, students. So thank you so much for today's class. It was really fun. I am not tired. I am just out of breath. Okay. So students, thank you so much. So, did all of you enjoy today's session? Students, did all of you enjoyed? Tell me, students. Did all of you enjoy? It was fun, right? Yes, it was little rushed because it was a revision session. See, this is not a one shot where you can learn from scratch. Students, I'm telling you again and again, students, if you want to learn from the scratch, right? For this, we have different sessions. If you want to learn from scratch, there are multiple other sessions for it. Let's say if you do not know any session, see, if you want to learn from scratch, here are the other sessions are there. Right? All of you might be knowing that, right? Every single session, if you go to the channel, every single session has been done multiple times from scratch, right? So let's say if you want to watch cell cycle, sorry, I want to learn cell cycle in detail. If you want to learn cell cycle in detail, this is a chapter you should go. If you want to learn cell cycle from scratch, this is a video here. And I've taught you in 3D here. Go check it out. I've done it in 3D. This is for cell cycle from scratch. This is 2.5 hours. So this was a revision, more of a, you know, getting your memory fastened again, right? So students, thank you so much. I will scoot now. I think I have to sleep right now. 3:30, no, too soon, no? So I will sleep right now, students. I hope I can wake up tomorrow because I have one more class tomorrow. Tomorrow morning we have a class. Okay. So thank you so much, students. Bye bye. Take care, all of you. Have a great day ahead. And bye, students. Bye, students. And students, I want to know in the comment section how many of you attended from the morning. Plant anatomy also is there, no, students? Peter, see this. If you watch this lecture, it's more than enough for plant anatomy. There is a lecture of mine on plant anatomy. If you just watch this lecture once, you will not have any doubt. This one right here. This one is for plant anatomy. Just type anatomy of flowering plants in 3D. One shot, Basfarad sir. This video you can get. Just watch the lecture. It's best video for anatomy. Okay. Okay. So thank you so much, students. Bye bye. Take care, all of you. Good morning again. Bye, students. Bye. 4 plus from this live? No, this live is mainly for students. This live is mainly for revision purposes. Okay. Students, thank you so much. I will scoot now. Bye, all of you. Bye. Let us know in the comment section how was the class.